right, good morning. Good morning and welcome to the Northeast DAS and Small Cell Association's third annual In-Building Wireless Summit. I cannot believe that it's already March 31st and we are sitting here in this room. To me, it feels like yesterday we were just in Philly and now we're already here. I hope that the weather actually can keep up with us and it feels like spring. But my name is Amy Cecil. I am the event producer for NEDAS. Our association, we try to put together these unique events where you guys can really learn and grow with industry-leading professionals. So welcome as we peer into the future, and we really hope that you guys have a fantastic day, and we're really, really happy to have you here. Just a few housekeeping items. All of you have badges, or you should. If you don't, please make sure you see the registration desk. But on the back side of those badges is your schedule for the day. All you have to do is flip it over and you can see the schedule. So you know what's coming up next, where you're supposed to be when. So there is no excuse for no one having any idea. No one should be asking me questions about what time each panel starts. You all have it right at hand. But yeah, so also on the back side of that, besides your schedule, there is a Wi-Fi password at the bottom. So if you want to get on the Wi-Fi, there is the network name and the password on your badge. Things to note throughout the day, at 1 o'clock, we will have lunch. It will be on the second floor. It is literally directly above where we are right now. There'll be lunch and exhibits from 1 to 2 p.m. We'll be back down here by 2:15, and then we will take a coffee break at 3 o'clock that will be sponsored by Aquest International, and that will be right upstairs from 3 to 3:15. We'll be back down here until 5 p.m., and then at 5 p.m. we'll be back upstairs again for lunch and exhibits. The exhibits are only open from 1 to 2 and 5 to 8, so make sure you really utilize that time to network, interact, and visit as many tables as you can. We have in the program guide, there is a list of all of the exhibitors and their booth numbers, so you will be able to easily find the people that you are trying to in your booklet. Now, today would not be possible if it wasn't for our event sponsors. So here's a total list of all of our event sponsors, and we're so grateful to have and to be able to support NEDAS event after event and year after year. I'd also like to take a moment to really thank our media partners, Dark Fiber, DAS Congress, and Light Reading. And today, which is something new and unique and we're so excited to have, is we are live streaming all of the panel discussions today. So we will have a video of all of the presentations for you at your disposal. And we're really thrilled about this unique opportunity. So thank you so much to the Internet Society for being able to do that. And at the bottom, you can see the link that you can, excuse me, that you can see the live webcast right now. And finally, really couldn't be more happy and more proud of our annual sponsors. They really give so much to the association. They provide us direction of the trends in the industry, and today's entire program, you know, Alyssa and their support wouldn't even be what it was without them. So I really, really appreciate all of the sponsors that are here. So thank you guys so much for being here, and we hope you have a fantastic day. And if you have any questions, any feedback, anything, please feel free to contact any of the NEDAS staff. We're here to help you. We're here for you. So, and without further ado, Ms. Alyssa Miller.
All right, good morning. Wow, what a great turnout. Thank you guys all so much for coming. So I'm going to kick off the program today with the theme, peering into the future. So where did this all come from and where is this all going? So I'm going to give you some insights, you know, as I walk through this presentation, which I hope will serve as a way to foster discussions today and will inspire you to take us where we all need to go in the future. Just want to make sure I got this working right. All right, so here we go. Everywhere we go and no matter where we go, we all have to be connected. That's just the way it is. We all have to share this information wherever we go as well. We're sharing what we eat, what we watch, what we listen to, where we go, where we shop. Even when we're shopping other places, we're price checking. We have to have these mobile devices, and if we can't have those with us, we know that we feel like there's something missing, there's something not quite right when we don't have it. Our ability to control nearly everything from any device is really proliferating everything that we're doing and everything that everyone else is doing. We can control what information we choose to be shared with us. We can manage events. We could read the news. We could make the news. We're doing so right now with the webcast. We're making the news as we go on any kind of device. These devices are supposed to help make our lives simple in our world, but with so much access to information everywhere, and it's nearly so difficult to make anything happen at any given time. Now we have the ability to see anything from anywhere. We can see who's at our front door. We have this Goji smart lock. We can actually log in and see who's at our front door when we're not even home. We have LG smartwatch phone, which is a wallet. We could pay for anything everywhere that we go. If you want to know where your package is shipped, it's here. It's right on your watch. It's on your phone. It's on your computer. It's every little place that we can go to access information is at our fingertips. You guys all remember this game, Where's Waldo? Well, we don't need that anymore. We don't need to play these games because our devices will tell us where they are at any given time. We've gone from a world of where's my iPhone to where's my suitcase. Seriously, you have this suitcase with its own SIM card now that's available to you. And it's incredible. I have an 11-year-old son, and he was home one day waiting for me, and he calls me up and he says, "Mom, why are you on the hutch?" I said, "What do you mean? How do you know where I am?" He's watching me based on the movement of my own phone. He can sit there. Is that the future of babysitting? Absolutely not. But the irony is that you don't need to guess where things are at because they will tell you where it's at. Our world today is a world that we've just started to enable. The ability to buy anything, nearly anything, at any time. We seek control in everything that we do. We can buy, sell, trade, refill, price shop, compare, research, talk, eat, pray. We could share any kind of thing with just an elegant few taps from our fingertips. We all know about these self-driving cars. They drive, they detect, they stop for you, they anticipate movements, they tell you where you've gone over the line, where danger may be lurking. I mean, we don't have to think as much as we used to, but we ought to. We do a lot of online shopping, and then there's Google. With the Internet of Everything demands everywhere, should we feel threatened or enabled? It is true. Google is becoming a mobile virtual network operator. And the ramifications for what we do in this collective room and for the rest of the world of this can be really, really intense. And there's a lot to think about, and there's a lot to process here. And these are the opportunities that we have available to us. We in this room are enabling the ability to access information from anywhere. The Internet of Things revolution is upon us, and we are experienced, knowledge thought leaders that know how to enable what businesses and consumers want, which, as we know, they want it all. The people in this room design networks. They architect technology, they connect wireless and wireline systems, they build signaling and amplification platforms to ensure information can be shared quickly, efficiently, and effectively. Information is funneled between data centers and consumers everywhere, and we in this room are the people that enable information to go from point A to point B. We ensure that these paths take us not only are well constructed, but they're optimized for immediacy access to information anywhere. Our end users are people like your cousins, your nephews, sisters, neighbors, and they have no clue what it takes to ensure a highly connected world, but they do know when they aren't connected, and that's most important. You can't go to a stadium or arena today without expecting to post a photo to Facebook or Instagram. You can, get access to live streaming TV and radio broadcasts while you're sitting there in the seat within the arena itself. Hospitals, forget about it. You can't even get sick anymore without being connected. We expect the ability to let anybody know where we are at any given time. And also doctors in those hospitals have the ability now to monitor operations across oceans. And it's remarkable what they're able to accomplish from New York to Japan. They can collaborate on everything and anything. And in our homes and in our offices, we know that we have to be connected at all time. And you know that feeling when you have no signal on your cell phone and there's no internet access? You feel shut off, shut out, and shut down. And a single entity, you have no ability to know anything at that particular time. And the municipalities, they have enough to deal with in regards to public safety, which is a huge concern, and residents requiring access to any kind of information at any given time. We are on the go, and we're constantly on the know. So how did we get here? Taking a few steps back in time, you could see that I'm going to be reminding you about how short of a distance it's been in the history that we've had communications to where we are today. Over 170 years ago, Morse code introduced the electric telegraph. And I'm not going to read everything here, but as you could see, it was in 1929 that Herbert Hoover, who was the first US president to have a desk phone in the White House. It's pretty remarkable. And it's not just what we were able to communicate, it's also where we were able to imagine this. It was the first fantasy book in 1931 that described a science fiction nightmare city with mobile phones and moving walkways. And this was before mobile phones were even invented. And then it was Arthur C. Clarke who first proposed this idea of satellite communications. In just the past 50 years, the pager, modems, touch-tone phones, computers, the internet was founded in 1969. And this, remarkably enough, is an era where many people in this room were alive and born and may remember some of these great inventions. I'm going to skip ahead. We were all born into an era of enablement. For most of us here today, those revolutionary inventions occurred within our lifetime, and not all that long ago. I may have been born in 1971, but I'm only 25. It's pretty remarkable what has happened. And most of the history that we ran through was the wireline world. We haven't even touched on what the wireless world has started. In our lifetime, what we are enabling is just beginning. In 1980s, the dawn of the modern internet and introduction of mobile communications. Is anybody here 31 years old? You don't have to raise your hand. Well, if so, you're as old as the very first cellular phone. And it's incredible. I mean, you could have been many people in this room could have been teenagers and had a cell phone back in those, and not even have a cell phone. Today, teenagers have to have cell phones. And the advent of technology continues. You could see here, major companies with, Bluetooth being developed and Wi-Fi, the Wi-Fi Alliance, wireless communications, and digital wireless users by 2000 outnumbered analog subscribers in such a short period of time. So a little history about me. In 1998, I worked for Ericsson, and I was excited to be in an office trialing Bluetooth for the very first time. I didn't even have my own cell phone until 1999. And just think about how not too long ago it was when you even got your first cell phone. And now, it's all about, when did you get your first cell phone? When did you get your first wireless modem? It's about where we were. And imagine how quickly all of that technology was developed to take us to where we are today. There are more than 356 million wireless subscribers in the US alone. There are more than 100 billion SMS messages sent daily. And that doesn't even touch the amount of wireless data we're sending in each and every moment, including right now. As we go from today to tomorrow, we know what we have, right? Amazon is now testing a new Wi-Fi spectrum. Google had, announced that they are becoming an MVNO, which was announced just a few weeks ago at the Mobile World Congress. And the FCC is changing laws and regulations in order to enable this to be easier and better for us. We know Amazon is trialing wireless networks. We know Starbucks created a digital network. And now we have Facebook, who is set to beam internet from drones that could be flown for 60 to 90,000 feet above the ground for 3 months at any given time. It's not a bird anymore. It's not a plane. It's an internet drone. These test flights are starting this summer. And this is how information is going to be shared, at least for the near future. We can't even imagine what's beyond that. So today, I really challenge us all not to think about where we were. We just went through that. But where are we going? What does tomorrow mean for us? We have a new era upon us. We have to stop thinking about the old ways. We have to stop thinking in the old ways. And we have to start thinking new ways. What we know is great, but the truth is, what we don't know yet is probably better. At the core of what we do collectively is our ability to enable. We enable all of this and so much more. And we in this room are the people that are collectively making this happen. This old diagram only touches upon what capabilities we have. And we live in a world where we can talk to anyone, anywhere, we can see them at any time, we can send messages to them simultaneously. We can peer with them from a network standpoint, from a personal standpoint. We house information about our collective selves in data centers. We beam signals to and from base station hotels that must interconnect with the wireless world. But there's more to this that needs to happen, and that's why we're here. The truth is, we're all just looking at the horizon. We can't even fathom what's beyond, and each step we take takes us closer to knowing what we don't know. And all at the same time, it reveals something to us that's different. Data is everywhere. It's literally and figuratively everywhere. It's in this room right now. The wireless signals traversing this room alone is incredible just to think about. Communications are all around, and the history of what we've learned has only started to inform us of where we could even be going. Our imagination is really what is going to help us take us beyond, and that is what's most exciting. And I challenge you all today to imagine, where is this all going, and where is this world taking us to, and how are we enabling that? Because at the end of the day, we are just a tip of a dandelion. Thank you. I want everyone here to really work and collaborate and trust one another, because we can't do what we're doing without that trust. We shouldn't have secrets, unless they're intellectual trade secrets, of course. But feel free to challenge each other in a positive way and get those discussions going and question what you know and question what you don't know. And that's what's going to help us spark those conversations. Our first panel this morning is called RFP Do's and Don'ts. It's sponsored by Squan. And if we have those panelists ready to go, I'd like to make that introduction. Can you raise your hand if you're on that panel, just so I can see in the back of the room? Great. We have Doug right here. So I'll have Doug come up first because it's going to take him a little bit longer. We have a seat for you as well, along with all the panelists. Sure, absolutely. We're going to just give Doug a couple minutes to get his group together. So maybe take 5 for all, and we'll also get them mic'd up, and then I'll do a proper introduction as soon as they get set up here, okay? So thanks so much, everybody, and we're preparing.
there before it begins.
Folks, so we're going to get started with our first panel. I think we got all of the kinks worked out, so we'll be able to get the program on. We've got a fast-paced program this morning, as you all know. So without further ado, I will be introducing the RFP Do's and Don'ts panel. My job here is just to introduce to you our moderator. Douglas Fishman. He is the Director of DAS Design and Implementation for SQUAN. He's responsible for design, testing, implementation, and commissioning of DAS systems. His bio is fully in your program, but I'm also honored to be able to work with Doug as he's on our advisory council and has given us great recommendations and has added tremendous value to the program today. So thank you so much to Doug for all you do for the association, and without further ado, here he is.
Wow, thanks, Alyssa. That was a very nice introduction. Good morning. Welcome to our panel here on RFP Do's and Don'ts. We promised a lot of excitement this morning. I hope you're all ready for it. Let me just take a minute here. We've got a lot to cover and not a lot of time. We've got about 50 minutes. We're hoping to get through the presentation in about 40 to 45 minutes and leave 5 to 10 minutes for questions at the end. Let me introduce our panelists here from right to left. Mr. Larry Werner, who is Senior Project Manager and Engineer for the Clariant Group. Larry's got over 30 years of experience in all facets of project management and engineering, including analysis, concept development, programming design, engineering, project management, administration, as well as the training and commissioning of integrated technology-based solutions. He has extensive experience in design and implementation of RF-based solutions, including Wi-Fi, cellular, LMR, point-to-point microwave, radio, and television, and is currently responsible for design of cellular two-way radio and first responder DASs at the Clariant Group. Sitting next to Larry is Ray Dutremblay, who is the VP of Building Technology Systems for WSP Flack & Kurtz. Ray has a broad range of knowledge in technology, project management, and construction. He's been working with computers since the 1970s. He specializes in analyzing user requirements, accomplishing system software design, RFP development, managing projects, and communicating technical system criteria in simple terms to architects, engineers, and construction trades. He has in-depth technical expertise in audiovisual RF systems, medical technology, digital imaging, and imaging software, data integration, and network integration. Next is Mr. Tom Chamberlain. Tom is the sales director at ADRF. He has 19 years of sales experience in the telecom industry, including 12 years selling DAS solutions to carriers, integrators, neutral host providers, REITs, and enterprise customers across all vertical markets. Tom's worked for Andrew Corporation and Mobile Access, as well as a position as VP of Sales for leading a national expansion for an integrator specializing in in-building DAS. And last but not least is Mr. Robert Lopez, who is a Senior VP at RCC Consultants, a private engineering and consulting company established in 1983, and he's been in the wireless telecom industry for 30 years. Rob joined RCC in 1989. He holds a BSEE and MSEM degree from NJIT. He's a licensed professional engineer. He is also IB Wave Level 2 certified and heads the DAS Consulting Engineering Group at RCC. Okay. With the introductions all done, I want to turn this over to Larry, and I'll be back at the end to lead the Q&A session. Thank you.
Thank you, Doug. Can everyone hear me? Okay. We have an agenda. We're going to go over it very quickly. We only have about an hour, so we're trying to get a question and answer period in at the end of this presentation. So if you'd hold your questions until then, we'd really appreciate it. Next slide, please. Oh, okay. Oops. We went one too far. So I'm here to talk about the challenges. Before we even start to do an RFP, we have to face all these challenges. We have to establish a strategy and set expectations. Set expectations for our clients, set expectations for everyone who's going to be involved. Some of the questions that we bring up would be, what kind of project is this? Is this a cellular project only? Is this a UHF and cellular project? Or here in the city of New York, is this more than that? Is this an ARCS or auxiliary radio communication system for the FDNY, a two-way radio project, as well as a cellular project, okay? Is this project involving a new construction, or is it existing? There's a whole bunch of challenges that come up with that process. New, it's all on paper. How do I predict? Existing, I can get in the building and get a sense of, when a cellular world is involved, the macro around me. Wireless service provider buy-in. I'm sure there's some wireless service provider representatives in this room. This has become a big issue. There's some third-party neutral host providers in the room as well. This has become a very big issue. In other words, what's the appeal of this project? Is this something that is an MDU, a multiple dwelling unit, that people are only there at night? Is this a hotel? Is it a hospital? What is it? The technology that's going to be used. Some of the wireless service providers have preferences as far as the technology is concerned, as well as the FDNY with their ARC system. And who are the stakeholders in this? We have a project today, the stakeholders came out of the woodwork. In other words, we asked the question and all of a sudden everybody was, well, I have a frequency I need done, I need carried on the system. What does the owner want? Who's the developer? How do they want to approach the project? And I'm sure there's architects in this room today, and that is the biggest battle of all. How do we hide the technology, though everybody wants their cell phone to work inside of this space? Concealment has become a very big deal. The surrounding environment, we call it the macro outside. Where are those antennas? What is the power levels? How can we predict that when we're not 15 stories up in the air right now because it's a hole in the ground? And the project schedule, especially when we're using a third-party neutral host provider. How is that schedule going to work? How are we going to get wireless service provider buy-in in advance of this project? And of course, as far as the client is concerned, what are the expectations? When is this going to be done? A few of the approaches that we have taken in the field is, we're going to get this cable pulled now. And you get a little bit of a kickback from some of the third-party neutral host providers, because all of a sudden the carriers are going to say, well, you've already paid for that. So you get a sense of those questions. Next slide, Doug. Oops, you went too far again. So from a needs analysis, we do have technical requirements that we have to address in advance of writing this RFP. We're going to talk about them further in this presentation. What is the purpose of the system, as I said earlier? Is it a cellular system? Is it a first responder system only, or combination? And is it have any sort of two-way radio communications required? Most of the projects in New York City that we are doing today have all the above. And most of the time, you'll see us designing two separate systems into that project. One being a fiber optic based system for the cellular, and one being very passive for the two-way radio and the first responders. What are the coverage requirements? Well, we have a very good sense of what the carrier coverage requirements are, and if you delve into the New York City documentation, you get a sense of what they're looking for as far as coverage is concerned. And the UHF, or two-way radio, basically follows those requirements from an FDNY perspective. Who else do we have to coordinate with? This is becoming a bigger and bigger issue, because a lot of the technology people, and some of them in this room today, are deploying what we call ubiquitous Wi-Fi, especially in the AC or 802.11 space. And those wireless access points are very sensitive to the power level of radiating antennas that we're putting in very close to them. What frequencies are we involved in here? From a UHF perspective, Mr. Client, do you have these frequencies? Do you have an FCC license for these frequencies already, or is that going to be part of the process? And who's going to be responsible for filing for those applications? And again, as I said before, is this project new or existing space? Existing space, of course, how do we get our cables out there? How do we hide our antennas? But we already can do a walk test. We can sense what's going on. We know what the power levels are that we're going to have to compete with from the outside macro coming into the building. New, well, what does it look like at 10 stories up, at 15 stories up? We don't know, because there's just a hole in the ground. So these become issues. Next slide, please. From a business consideration, technical business consideration, who are the stakeholders? Obviously, the developer and the owner are stakeholders. Obviously, the wireless service providers are stakeholders. And obviously, if you go that way, the third-party neutral host provider is a stakeholder in this process. Okay? Considerations from a business perspective is, while you're building out the project, do you build out the cable pathways right away? And the other big question, especially today, and I'm sure everybody's dealing with this, is if you build it, will they come? Will the wireless service providers come? Well, Antenna Solutions Group is not coming, so I'm sure we have representatives from AT&T in this room. How is that going to play out? How fast, or how can we premeditate what the buy-in will be from all the carriers? All right? Funding, who's going to pay for this? Is it going to be the owner, or is it a third-party neutral host provider, or is it even a carrier? And is there any revenue possibilities in this for the owner of the site? And who is going to maintain this after it's built? Obviously, technology is changing. Who's going to be responsible for upgrading this plant as technology changes? And of course, who's going to be responsible when somebody calls and says, I don't have cell service on this particular floor? Next slide, please. So I'm going to hand this off to Ray now to continue with the writing process itself. Thank you very much.
Thank you. Okay, can everybody hear me okay? Good. I'm going to go through these slides fairly quickly. I'm hoping that after this conference, you can use this as a checklist when you're either writing an RFP or reviewing an RFP. The first most important point is to make sure that you define the requirements carefully enough so that you can get enough detail in the responses and that you provide a checklist so that you can review the costs accurately and apples to apples. The next slide. So the writing of the RFPs, you have to avoid enough specificity, enough so that you can give the respondents some flexibility in choosing your design. An example of this would be to don't specify the exact equipment manufacturer of the antennas and the bidirectional amplifiers, but give them some flexibility so that they can choose the most cost-effective product. So next slide, okay. What's most important is that drawings accompany the RFP so that they can look at antenna placements, areas excluded from coverage, so on and so forth. And especially the risers. What are the size of the risers and where they're located and how much room is in the IDF closets or the distribution rooms for their equipment. So drawings are very, very important to include with your RFP. Okay, next slide. Your technical requirements, the most important thing again is to understand what carriers are going to be included in the building. You know, is it AT&T, Sprint, T-Mobile, and Verizon, or there's some other carriers that you need to be included in that. The technologies, as was mentioned before, the frequencies are very important, the channel counts, and usually the coverage area is defined as like 95 to 98% of the building. Your signal strength. RSSI is not used too much in New York City, but so it's important for the respondents to these to understand what signal strength measurements, and then the public safety requirements. Is this going to include a DAS and an ARC system, the FDNY Auxiliary Radio Communication System? In New York City and some other cities, you cannot combine a DAS and the ARC system. So it's important to mention that. You have to look at your local codes and contact the fire department before this RFP is issued and understand exactly what their requirements are. Okay, testing, next slide. It's also important, just as a specification that we do in technology, the CSI specs, to understand what are the testing requirements, who's going to do them, how they're going to do them, are they going to provide PIM testing, what are the baseline metrics that you're looking for, and also what's very important for the backbone is who is going to install and test the fiber. That's extremely important. Okay, next slide. Writing RFPs, again, it's important to show contact information and to write the RFP again so that you can compare. When you're writing the RFP, a good thing to keep in mind is how are you going to review it? Think about review process when you're writing so that you can compare apples to apples. And then some union requirements. It's also, especially in New York City, important to know if there are any Local 3 requirements. Can you use CWA? Because this really affects the labor cost, as everybody knows. So this is extremely important to include in the RFP. Okay, next. The writing, the coordination requirements is again, when you're writing the RFP, keep in mind who's going to approve, who's going to actually pay the bills and put out the money for this design. What are access agreements in the buildings in New York City, elevator schedule? Is this going to be done on straight time? Is there equipment have to be installed during overtime? And then integration with signal sources, and just in general, ongoing coordination between all the trades. Because the sequence of construction, I think, should actually require a separate section, because when things are installed, ceilings, walls, wiring, even going back into the MEP stages, ductwork and things like that, it's important to include at least a little paragraph on what the sequence of construction is, and if you have it, the timeline of this. Okay, the next slide. Again, if there are any MBE or WBE requirements, that's important. There are some firms that are MBE, WBE, and sometimes this is a requirement, especially in government jobs. Again, to my last comments, the working hours, is this going to be done on straight time, overtime, and security requirements, meaning when equipment is installed and is is in storage at the site, what are the security requirements? Again, a paragraph on this. Of course, next slide, the warranties, extended warranties, service level agreements, remote monitoring. All these are important to mention in the RFP. And then, so at this point, I'm going to turn it over. Thank you.
Okay, I'm going to talk about responding to the RFP, and if everything that we just talked about is done that way, it's very easy. Unfortunately, and we're going to talk about the order in which you do what to address in going through the response, but most RFPs aren't well written. That's why we're having this panel. They're just not. And it makes it very, very difficult to respond, and you have to make some decisions in the process. The first thing you do is the initial RFP review. The best thing to do is read it through. Several people should be involved in that process on your team that's going to respond. Read through the RFP, read through it again 2 or 3 times. Develop the key summary of the key requirements. The best way is just go down through in bullet points. Anything that's absolutely jumps out at you. In that process, you are going to come across a whole bunch of questions because, like I said, most RFPs aren't written with that format and structure. So they tend to either be vague or there's just missing information. Ray had mentioned RSSI versus RSRP. I saw one last year that was RSSI written for New York, and it's just not going to fly. The carriers aren't even going to consider that. So each integrator that gets that RFP, they have to decide, do I want to bid this to win it according to the way it's written and then address that later, or do I want to write my RFP response according to the way the carriers are actually going to go on it and address that. And it's a risky decision because you really don't know, whoever's evaluating it, you don't really know what their level of experience and knowledge is. So you have to make your persuasive arguments, and sometimes it works, sometimes it doesn't. In a perfect world, everybody would write the RFPs according to the actual needs, but that's just not the way it is. So during the list of questions, you want to get some of that out if you can. When you get into the specific building, are the risers stacked? Is it union, non-union? Is it access issues, as Ray had referenced. There's a lot of questions. I've done hospitals. You know, it's interesting when you see there's a lot of new people getting into this business, and they'll ask the standard questions. You do a hospital, where are the x-ray rooms located? Where are the MRI rooms? Where are the CAT scan rooms? You mark it all out. These older hospitals in New York, you've got to ask other questions. You have to say, are the x-ray rooms where they were always, are they located where they were always located? Because they may move the x-ray room to another area of a hospital, but they're not going to move the lead walls. So when you do your design, you do your propagation, it's not going to work if you've got lead walls there that you didn't know about. So you've got to go through that in the questions. The whole question process is really critical. And then draft a straw man response, go through the whole thing and try to come up with a response so that you basically play devil's advocate on your own work to see if there's anything you're missing. And that's usually the best thing to do is, you know, again, multiple sets of eyeballs on it. It's going to be the most effective way to do that. And that leads to the next point. Solicit sales, marketing, engineering, operations. Operations is critical because they're going to see things completely differently. Once you turn up the DAS, it gets commissioned, everybody goes on it. It's not the last time somebody's going to touch that DAS. So the operations people are going to have some input. You know, how easy is it going to be to upgrade later on if, for instance, you know, Sprint's rolled out BRS. Was it considered in the RFP? You know, how easy is it to add BRS? You have to think about that, and operations has some input on that. And then also maintenance and monitoring in general. And then compile your responses, make sure all the requirements are addressed. Usually you have to go through that a few times and see if you've missed anything. Because Rob's going to talk about the evaluation piece, but that's critical. I mean, if you may have a great response, but if you missed a couple things, you know, it's just going to lead to questions and drag out the whole process and jeopardize your opportunity. And then write an effective cover letter, including an executive summary, the key selling points, and key contact information. A lot of times, you know, one of the things that everybody's looking at is not only did you have an effective response, but, you know, what is your background? Have you done this before? You know, have you done it in New York City? This is a different world. A lot of people come into New York City to do a project. They could lose their shirt and go out of business if they don't know what they're doing. So it's critical to address all of that. And then complete the response at least 2 to 3 days in advance to give yourself enough time to do your production so that it's not rushed. I'm sure there's no integrator in this room that did it in the 11th hour. Unfortunately, we're all busy, and that's how it usually is, but if you're able to, give it the proper time and package it, and you're going to get the best opportunity to win the RFP. And now I'll hand it over to Rob for the evaluation.
Okay, when it comes to evaluation, it all comes down to price. Thank you. Now, all kidding aside, we've been doing this for several years now and been on every aspect of the writing of RFPs and evaluating systems integrator responses. And one of the hard lessons in all of this is that, as it was said earlier, one of the most important pieces to be as specific as possible in being able to draw a direct line between the stakeholder requirements. In other words, what is the owner expectations? What are the wireless carrier requirements? And then translate that into very specific metrics so that the systems integrators can provide a credible and very specific response. So one of the things that we've learned in the process is that when you're looking at the possibility of 4, 5, 6, 7 possible proposals being submitted for one project, it becomes an extremely difficult task to compare if there are no rules set up front as to how those responses should be provided. So to make our job easier, one of the things that we've done is we've included templates embedded into the RFPs that specify how is it that we would be evaluating the responses. Ultimately, the information in terms of the number of remote amplifiers, for example, for a given DAS vendor, and we know that there are several out there, so we do need to take that into consideration. We do not necessarily specify any particular vendor or equipment provider to be used, so we leave that up to the systems integrators to decide based on their own business relationships, of course. Nor do we specify the type of antennas to include. However, what it comes down to is how well does the design meet the desired specs, okay? So one of the things that we spend a lot of time on is before the RFP is published, we engage each and every one of the expected wireless service providers to be joining a DAS. And most often, we do get cooperation from the local market lead engineers as far in terms of detailing up front how many channels will be required by technology, what frequency bands, or what the bandwidth is on a per channel basis. So it's all very important. And then, of course, what are the design metrics? And we've seen over the number of years, it's gone from a very simplistic view in terms of defining everything in terms of RSSI. As we know, as technologies became more and more complicated, that basically doesn't apply anymore. So again, what are the specific requirements in terms of, for CDMA, for example, received signal code power, and it's with respect to LTE, reference signal received power, and so forth, the EC over I naught, that's all specified up front. Another thing that we've learned is to minimize the response time, because of course, we primarily get involved in new construction. We've done existing construction, but primarily we engage early on with the architects in defining those building plans and defining what are the space requirements, minimum for the IDFs, the MDFs, and all the different pathways, vertical, horizontal, conduit. So when it comes time to run the RFP, all that information should be very well defined up front. As part of the RFP, the deliverable would include, of course, the building plans, which is, of course, from a design perspective, is a must-have. But one of the things that we found is when you have 5, 6, or 7 possible systems integrators responding and using the same exact building plans, you would get 5 or 6 or 7 different IB wave design files with 5 or 6 different scales assigned to a design file, making the comparison of apples to apples extremely difficult. And what happens is it puts us in the position of becoming teachers reviewing, a student's homework assignment and then issuing correction requests to resubmit, and it lengthens the entire review process. So to shorten that, we leveled the playing field and decided up front to working with the architects, we create the IB Wave design templates. We do not specify what DAS equipment vendors to utilize in the design, but in terms of defining what are the target coverage areas, the exclusion areas, wall properties, ceiling heights, whether it's a sub-level all the way up ground, including let's say party areas, amenity spaces, are all defined up front within the IB Wave template itself. So the RFP that describes in writing what's required, it's also there in the design template. So from a response perspective, each of the systems integrators would then be working off exactly the same song sheet, thereby minimizing any potential risk and differences in the final designs. Once the responses are provided, and hopefully the systems integrators will have adopted the templates to be used for filling out the number of remote amplifiers by IDFs, the number of antennas that are counted on a per floor basis, we can then start and looking at the cost that's divided up by not only the entire system, but looking at it from the standpoint of what is the cost required to implement the amplifiers on the IDFs with the passive components, that is the transmission lines, the antennas, and so forth, in the event the owner just wishes to install the cabling up front all the way to the IDFs, especially new construction, and thereby go through a phased implementation of when to light up each of the floors, as opposed to have everything turned on from day one. Once those responses are provided on that basis, it makes it quite easier to look in terms of things of what is the cost per antenna installed, what is the number of antennas on a per remote amplifier basis. And by looking at all those metrics, we can then compare the designs, okay? So everything is reduced down to a cost per metric. And then, of course, what is the total cost of ownership of the system to the owner? If they expect to share in the cost, for example, by having a neutral host system provider to take care of all of that up front and then lease back the system, there's various ways to handle that. So with that, from a analysis and comparison perspective, that's done with my talk, and I'll be more than pleased to entertain any of your questions. Thank you. Doug?
Okay, well, I want to thank you four gentlemen for the presentation here. I want to open the floor. We've now got a good 10, 15 minutes for questions. Anyone with questions for our esteemed panelists here? It's hard for me to see, so. Over here on the left, I see a waving hand.
Playing Phil Donahue.
Hi, this is a question for Rob. I appreciate the difficulties in putting an in-building system design together. You mentioned that as a consultant, you'll put a design together and have the integrators or anyone bidding on the job bid to that design. After that design is put in, and if the carriers come in and find difficulty with the design, who then is responsible, the integrator or the company that did the design?
That's a good question. So in order to avoid that from occurring, you get the wireless carriers up front, okay, to tell you what from a design metric perspective, the system should be designed to, okay? So that's provided by the wireless carriers. The instructions to fulfill those requirements are set forth in the RFP document. The systems integrator's design seeks to achieve those requirements. Okay. Now, there is a lot of vetting that goes on in terms of verifying if, in fact, that design will meet the design objectives. And we are in a position of doing that. So we work very closely with the systems integrator at that point. And that's across all, this is still going through the evaluation phase. So no one is ruled out until each of the designs are properly vetted down to the percent of coverage per floor. Okay, not in the entire building, for example, but on a per floor basis. So when it comes down to answer your question, when it comes down to implementing that final design, and through that process, even through the implementation side, in order to ensure that the system is properly being designed, then one of the things that we include in RFPs is a requirement to do testing as the installation is being done. In other words, not wait until the entire system is built and designed to then go back and say, gee, it's not performing, where did it go wrong? All right? So you try to implement processes to try to minimize the risk of, at the end of the day, the wireless carrier comes in and says,
oh, you're not meeting my minimum KPIs for this, right? So you try to do everything possible to avoid it. But at the end of the day, it comes to the systems integrator to ensure that that system is implemented according to the design spec.
And can I add to that, Rob? You know, ultimately, the responsibility is going to fall on the system integrator. So, you know, hopefully the consultant's done their job, defined everything appropriately, so the design that is ultimately awarded will also be acceptable to the carriers. But it's the system integrator's responsibility as well to double check and make sure that the specs are appropriate and that the integrators would accept the design to those specs. So you can't just blindly take whatever the specs are. You need to use your own experience as well.
Just one additional comment. It's very important that the carriers approve the design, sign off on it before the design is implemented construction-wise. And that's one way to avoid the pointing of fingers.
Exactly. Excellent question.
And by the way, sorry, the same applies to the public safety first responder ARC system as well. Same applies. I have a question for these gentlemen. How do you address...
I guess we can allow that.
I'm sorry?
I guess we can allow that.
How do you address a situation, you've got a building and it's a, 2, 3, 4 year long project and you've gone through this whole process and the carriers, when you get to the point where you've either awarded it or close to awarding it, and the carriers all of a sudden change the requirements, they have new requirements. How do you address that?
Well, I guess I'm going to try to make an answer of this. This is part of the beast right now, and I'm going to elaborate on the question because it's even more difficult than that. The macro, we see the macro changing outside of the spaces that we're designing to, like in a 12-month period. So, yes, how do you address it? Well, we typically design in additional coverage as far as cabling is concerned for the possibility of the future. In other words, do we need to fight a coverage at a window? In other words, from that perspective, we're always worried about what's changing in the macro. Now, from a technology perspective, I think everybody in this room is watching technology change presently, and we at least can see out so many years, and we need to design to that view, that future view, keeping in mind what we have today. I think right now, Sprint's Project 25 or 2.5 is one of those things that we have to keep in mind as we go. If we want them to come in, all the equipment manufacturers, we don't know of any equipment manufacturer right now that is providing that in their remote fiber unit. Well, yeah, right there. But he set me up, didn't he? But typically, there's a lot going on, and as much as we can without going crazy, spending-wise, on the infrastructure, we want to be waiting for it, so that as it comes out, the upgrade in the closet, in other words, we're centralizing. I think everybody on this stage is of agreement that the remote fiber unit is in the telecommunication space. It's not out at the antenna. It's back in a controllable space. The antenna is connected to that device. And keeping yourself with space, with power, with cooling, for a future that you're going to have to grow a high-powered unit, or add a high-powered unit in, or a new technology is all critical.
If I may answer that, hopefully specifically, it's flexibility in the infrastructure and the equipment room space. One of our biggest problems is that the owners find out that, oh, you need 100 or 200 amps per each carrier. You need extra power, so that's the 200 amps for AT&T and Verizon, and 100 amps for Sprint. And T-Mobile. Is that reasonable? The air conditioning. So one of the ways you can plan for the future engineering-wise is to make sure you have room for additional panels. Make sure that the transformers have additional, or there's ability to add a transformer. And then when they find out the equipment room has to be 500, 600, maybe even 1,000 square feet for the DAS equipment, wow, we never considered that in our design. Now, what we see coming up is that communications hotels, that there will be a centralized data center in an area like Wall Street that will then feed, all this equipment will be in this co-location center, and then you have fiber optic or you have high-speed feeds to the buildings. So this is the trend we're seeing in New York, and that's one way to mitigate. But I think to answer your question specifically, it's to engineer expansion in the original design of the building. You don't have to build it, you don't have to buy it, you don't have to install the extra panel, but the space should be planned for.
Good. Other questions?
Yep.
Up here, where? Right down here. Mike's coming.
Ed Donlin, Telecom. Thank you for your presentation. Pathways and spaces are one of the big issues, but what I wanted to ask about was really when you talk about a building owner and you're in the design phase, you're talking about the tenants, we're finding that one of the big restrictions for our productivity as contractors here in New York is tenant coordination, or I should say tenant cooperation relative to deploying the DAS. Do you get involved with talking to the building owners and talking with them about tenant coordination and access issues when you're in the RFP stage? Because we presuppose that we're going to have unlimited access to the space, and what we're finding is the difference between a good job and a bad job is one that where you have cooperation and one that you don't. So I'm wondering if you actually, do you actually talk with the building owner regarding tenant access?
Well, we definitely talk during the creation of an RFP to the building owner, along with the architect and the engineer. But if it's an occupied building, that's a little different from an unoccupied new building. And that's a very good comment. I think that a section in the RFP should be about if it's an occupied building, what are the restrictions from the tenants and how do you mitigate that? If there's construction, and this is what was mentioned before, that can you only construct, after hours because of the noise? What are the restrictions for that? And absolutely, that has to be vetted out in a good RFP.
Absolutely. Other questions? Go around. No one? Okay. All right. Well, I want to thank everyone for attending. There'll be time afterwards. We've got all day. I mean, not saying you guys aren't going to be sitting in the other presentations, but you could always find any one of us afterwards to ask follow-up presentations. We also actually had a number of more slides in here. I assume, Alyssa, are these slides going to be available if people are interested?
Yes.
Okay, so you can always get the slides through, I assume, the NEDAS site or something like that?
Yes, we'll be sending those around to all attendees, and we'll be making them available online.
All right, terrific. Okay, again, I want to thank everybody for your attention and participation, and Alyssa, I'm going to hand it back to you.
All right, well, thanks so much. That was really informative, very helpful. If you guys want to leave your lapel mics right on your seats, That would be great. We're going to get ready for our next presentation. Mike Jones, are you here? Mike Jones is our next speaker, so I just want to make sure he is here. If he's here, he'll come right up to the foot of the stage. We're just going to take a moment or two here to make sure that everybody gets comfortable as they and collect their items. Thank you. Where's Zach? I just want to wrapping up to get. Okay, he needs to be in here, paying attention to this, and he needs to be by my side. Okay. Yeah, he's got to anticipate a little bit. So just let him know as soon as he grabs the mic, let him know. We are waiting for Mike right now.
Yeah, how are things by you guys?
We have a few minutes, actually. We want to give them a few minutes to do their ramblings, like 5 minutes or so, and then I'll come right back. Okay. All righty, so we're going to get ready to introduce our next speaker here. If I can ask everybody to just wrap up some conversations and settle down. I do notice that there is a fear of the front in this room. This is not a comedian show. We're not going to heckle you or call you out if you're sitting in the front row. I also do expect that people are here to get, insights and education and get some knowledge share, but I also realize that it is a work day. You might have phone calls or emails that you tend to. So if you have to get up and out, from your seats, that's absolutely okay. Don't feel shy about that. It is expected, so if you, want to sit up front or, if you're concerned about the optics there, don't be too concerned. We're all friendly here. We're all in this together. So without further ado, I'm going to introduce our next speaker. We're going to talk a little bit about tower safety and some key developments in that arena. And that is going to be presented to us by Mike Jones, who's the Chief Development Officer of HPC Wireless. Mike has over 15 years of telecom experience within the tri-state metro area in the Northeast. He's held various management positions in both the carrier side of the industry as well as the vendor side, ranging from his start with ArcNet Architects to Sprint Nextel, in addition to Wi-Fi. So his full bio is in the program. Feel free to take a read up on that, and certainly keep your ears peeled as Mike presents. Thank you.
Thank you, Alyssa. Can everybody hear me go all right? Okay. Good morning. As Alyssa stated, my name is Michael Jones. I'm the Chief Development Officer at HPC Wireless Services. I'm speaking to you today as a follow-up to our recent first annual Northeast Safety Summit we held at February 4th in Tarrytown, New York. The impetus for the first annual news event was to keep the focus on safety in our industry. One of the primary core values at HPC Wireless Services is safety, and while that is great to have as one of your core values, we want to take it a step further. We didn't want to just focus on tower safety, but safety in general in our industry. When I spoke in the news event, I referenced a 25-year-old Seth Garner and a 38-year-old Martin Powers of St. Peters, Missouri. These two men woke up one morning in 2014 and had every intention of returning home safe that day. They did not make it home safe. On March 19th of 2014, Chad Weller of Stevensville, Maryland, also expected to return home from a rainy day of work where he was improperly prepared with a safety harness too large for him to safely work that day, and he also failed to make it home safe that day. 2 weeks ago, a man working on a rooftop in Baltimore, Washington, fell 2 stories, seriously injuring himself, sending him to the hospital. And this past Sunday, this weekend, March 28th, 2015, it is reported that a 28-year-old woman, Stephanie Gurney, fell 200 feet to her death from a tower in San Angelo, Texas. It is yet to be confirmed if she's currently working in the tower industry. In 2013, there were 13 tower deaths in the telecom industry. In 2014, there were 11 tower deaths. In 2015, that rate is at 0, pending this week's investigation. Construction workers in the telecommunications industry are 10 times more likely to die than workers in the rest of the construction industry. In 2014, OSHA ranked tower climbers as the most dangerous job in the U.S., surpassing some of the standard jobs you would expect to be on that list. 2% of the estimated 10,000 individuals in the telecom industry climbing workforce will be impacted with injuries from their job this year, or approximately 1,300 people. Safety in our industry is not just related to tower work. This is related to vehicle safety, travel to job sites, equipment setup, use of machinery and tools, unsafe workplace activity, both on interior deployments as well as rooftops. Close proximity to equipment exposure, ladder falls, improper safety with tools seem to be still a common occurrence. In addition, falls off of scissor lifts, a standard piece of equipment used in our industry, have accounted for 2 of the construction deaths so far this year outside of the telecom industry. While there are usually reasons used to justify these injuries, most are preventable. At the end of 2013, the National Association of Tower Erectors, or NATE, was integral in organizing the Telecommunications Industry Safety Summit, which was held to work to address industry safety concerns and bring focus to these tower deaths. In 2014, continuing on this course, the Wireless Industry Safety Task Force was formed and initiated the campaign 100% Tie Off 24/7. In February of 2015, last month, the Industry Safety Task Force formed the National Wireless Safety Alliance. The task force that established the alliance consists of the 5 largest carriers in the U.S., 3 largest vertical realtors, and all the prominent general contractors and OEMs, as well as NATE and tower climbers. Industry companies and workers will be encouraged to continue to utilize the training pathways of their choice. Only now the NWSA will serve as the official national assessment and certification arm after industry workers receive their training. Also coming up this May 4th through the 15th, OSHA has organized the National Safety Stand Down. The purpose of the National Safety Stand Down is to raise awareness of preventing fall hazards in construction. Fatalities caused by falls from elevations continue to be a leading cause of death for construction workers, accounting for 279 of the 806 construction fatalities recorded in 2012. Those deaths were preventable. Fall prevention standards were among the top 10 frequently cited OSHA standards during the fiscal year of 2014. The goal of this intended stand down is 20,000 stand downs across the U.S. to educate more than 3 million workers. If they hit that goal this year, that will impact 4 out of every 10 construction workers in this country, not just in our industry, but of all construction workers in this country. While all these are very important initiatives that I've outlined so far and things that have taken place in the industry, there needs to be an equal focus from carriers, tower cos, OEMs, PMOs within the industry on the current trend towards service providers and general contractors in the industry. The topic of driving down deployment costs and its impacts does not seem to get mentioned during these summits and conferences on safety. While wireless leases continue to escalate, steel and equipment and material prices increase, attorneys' fees and insurance rates continue to rise, service provider rates and construction prices continue to get driven down. As the construction rates continue to drop, there is the expectation of the same level of service and quality from all these service providers. As the prices continue to drop, there always seems to be a service provider or GC that is willing to engage at these lower rates no matter how far they seem to drop within the industry. In addition, there's a continued drive to impose unpaid equipment training from our clients and added unpaid industry safety training. This is considered the cost of doing business. In addition, with an emphasis on driving pre-construction design costs down, it leaves more and more emphasis on field decisions for the construction deployment teams. If we are going to have a true effectiveness of this open discussion on safety, it needs to include all aspects of telecommunication deployment, not just tower crew safety. When smaller companies are forced to incur more safety training and more deployment training added to the lower and lower build revenues for equipment installs, something has to give. Keep in mind, no company that I'm aware of sends their deployment crews out with the assumption that the crew will not come back safe that day or not come back at all. Some of these companies' actions may fly in the face of that end result, but the intent is just not there for unsafe conditions. While some do not employ the correct level of safety focus within their organizations, others cannot absorb the cost or carry the overhead required to assure day-to-day preparedness for their crew or crews. While that's not the case with HPC, the problem is real and exists and needs to be addressed. If there's going to be a true focus in the industry of safety, there needs to be an open discussion on how the industry trends are affecting the crews and companies on the front line of the deployment of their infrastructure. We welcome and embrace the increased focus at the higher levels of the telecommunications industry and welcome the dialogue that will come on some of these issues that I've outlined earlier. At HPC, we are currently in the process of planning the second annual Northeast Safety Summit for February of 2016 to continue to expand the dialogue beyond the upper tiers of our industry and take safety beyond just tower safety to all aspects of safety and deploying infrastructure. Our hope is, as we approach February of next year, we are still at 0 for the 2015 fatalities and injuries and are on the decline, with the exception of this weekend when that investigation is completed. In closing, I'd like to thank the NEDAS organization for continuing to bring focus to the telecom industry, Miller for assisting HPC Wireless Services in putting together the first annual news event, all of our sponsors that help with the news event, and the attendees that helped to get the event off the ground this year. Please continue to support the organizations that work hard to assist families impacted by tower fatalities. Bridget Hester with the Hubble Foundation at www.hubblefoundation.org works tirelessly to help families of those impacted by tower deaths, as well as the Tower Family Foundation at www.towerfamilyfoundation.org. In addition, please look for upcoming information on the sponsorship and attendance for the second annual Northeast Safety Summit, or as we call it, NEWS, to be held in February of 2016 on LinkedIn and at the hashtags NEWWS or hashtag It's Your Life on Twitter. For additional safety information, please visit the OSHA website at www.osha.gov and the NATE website at www.natehome.com. Again, thank you for your time and listening, and hopefully we'll continue through this year safe and at a 0 death rate, which is the goal of this overall industry as well as the organizations that work within it. Thank you.
Thank you, Mike. Hey, Mike, did you want to take any questions? If anybody had any questions about anything? All right. Okay, we do have a question. One question coming up.
Hi, Mike. John Solentano. Where's the teeth? I mean, by that I mean, where's the enforcement of rules and regulations? Is it at OSHA? Is it the new initiative with NATE? Where's the enforcement? And even with enforcement, we see fines that are levied that are almost laughable. You know?
I think through the new initiative and the organization that's been framed, I think that's the first start to this. As I said, I don't think, while it's a great first step, and I think it's an important first step, as the initiatives that I talked about earlier, there's got to be a combination of this, because I do not think the tower industry has a bunch of rogue people that on a regular basis just go out there assuming there's a 50-50 shot they're going to come back. So I think NATE has helped to facilitate that. I think OSHA is ultimately responsible for enforcing that and making sure that they continue to update the guidelines. I don't think the impact should be to the bottom line on a lot of these deployments. Are there's sometimes smaller contractors that are greatly impacted by a lot of these fees and associated training and associated, carrier enforcement of training. And I think that's got to be addressed when you talk about this, because it's not, again, the carriers and the tower companies, while they're responsible for their deployments and the deployments on their infrastructure, they're not the front line who's deploying this equipment. So the deaths that are impacted, whether it was a tie-off issue, and a lot of these are tie-off issues, but we're not reporting on a lot of the issues on rooftops, on people that are injured on rooftops, on emissions where someone doesn't know an antenna is broadcasting, or depending on if it's a high-powered antenna or not. I think OSHA is trying to step that up, and I think we have the attention of the industry. But again, it's got to go further, and I think it's got to be driven down to the front lines. And I'm not sure that while this is a great first step, I think the initiative has to be there beyond there to make sure that that the training is there for everyone, but the impact of the frontline people is addressed. Does that answer your question?
Thank you. Any other questions? The people here in the back of the room, you don't have to be so shy. You can walk up the stairs. It's okay. All right. Well, thanks so much, everybody. And we're going to transition to our next presentation, so it'll just be a couple of minutes, so feel free to chat. Okay, Fedor. Okie dokes. So we're going to get the program moving along here. I'm going to be introducing the DAS and Wi-Fi, a symbiotic relationship panel here. So this is an interesting idea for this panel, is that, it's not the, or aspect of whether or not you need DAS or Wi-Fi, but it's how they actually should be working together. To lead the conversation here is Fedor Smith. Fedor's a long-term friend of mine in the industry. He is the president and managing partner of Atlantic ACM. He specializes in operations analyses, customer feedback research, and market sizing. And Atlantic ACM, at his firm, they do proprietary projects ranging from competitive benchmarking to customer satisfaction for major telecom providers and more. He has extensive experience in both the wireless and wireline industries and is a regular panelist and speaker at some of the nation's premier conferences, including the Northeast DAS and Small Cell Association. So without further ado, Fedor, take it away.
Thank you. Thank you very much. Rather than do podium speakers on the other side, I think we'll kind of treat this as more of just a discussion down here. I will walk through and introduce each speaker. They'll take a few minutes to speak to whatever slides they brought, and then we'll get into the questions. Just a little background, as Alyssa mentioned, our firm is a research and strategic consulting firm based in Boston. We've worked with just about everybody domestically on the carrier side, lots of colo, as well as a lot of due diligence on the finance side in the many acquisitions that have been going on over the last few years. And we've been doing this since 1991, so we feel pretty well entrenched in the marketplace. Up first, we have Jeff Bonja, the wireless solutions engineer from Corning. Jeff, take it away.
Hi there, thank you for coming. My name is Jeff Bonja. I'm a solution engineer for the eastern half of the country, supporting primarily the enterprise side of the house, but also doing a lot of the, supporting a lot of the carrier and tower company projects. Corning acquired Mobile Access a number of years ago, really is investing heavily in delivering really that infrastructure from layer one up to deliver the bits and bytes to the end user via whatever mechanism that works the best.
Excellent. Next we have Bill Grego. First, I think you're going to have to explain your nickname and then proceed with your slides.
Yeah, I flew fighters in the Air Force for 27 years, so that name came, and I'll have to kill you all if I tell you what it means. So, I think the key here is when you're talking about networks now, our company being a neutral host, third-party provider, originally started as a DAS company, first outdoor, and then in about 2007 timeframe indoor, and it was DAS focused. But the technologies are all changing, and we consider ourselves a distributed network company now. And so you see some of the technologies and things that are on the bottom of that. And so the discussion today with combining Wi-Fi and neutral host systems, including small cells and other things, for the indoor space, is what we're hearing from our customers, both from venue owners, in every vertical, hospitals, healthcare, sports and entertainment, commercial A, Class A space, and, tenants and things that want to know, should I still do my own Wi-Fi, or is the building owner providing some of that? So the dynamics there, we're starting to get asked the question, hey, when you put your DAS in or your neutral host system in, could you also put the Wi-Fi in? And there are obviously some synergies there in labor costs and things that can happen. So we'll talk about that as we go.
Thank you very much. Up next, actually, Mike, I think your slides are not in here, so Mike Claudio of Solid, you...
Verbal only introduction.
Verbal only. Yeah, thanks for the introduction. Mike Cliato, I'm the Vice President of Marketing for Solid, where we keep people connected and safe in a rapidly changing world through a portfolio of RF amplifier, RF radio, and optical transport solutions. Translation, we're talking about DAS, backhaul, front haul, solutions like that. Some of our projects include the Seoul Metro, the Daytona International Speedway, Amazon headquarters, Ronald Reagan building, and in our own backyard here in New York City subway, 432 Park Avenue, Lincoln Tunnel, terminals 4 and 5 in JFK. We were really excited about the opportunity to join this panel because we have this industry discussion about it's a toolkit approach for densifying the network. And we see that a lot of the industry likes to look at an either or, as Alyssa mentioned in her opening remarks. And I think it begs the question, why not use all the tools in the kit? And particularly Wi-Fi, and most of us kind of come from a cellular background. Wi-Fi is very unaffectionately known as the garbage band. And yet it's a tool that somewhat in the public begrudgingly, the wireless operators are saying, yeah, we're looking at doing that. And so it is an important element of the toolkit. And one other thought, before we move on, is that the toolkit needs to, in order to keep pace with the needs of the market, needs to both, we need to identify both evolutionary and revolutionary strategies and technologies in order to get there. And I think we'll unveil in this discussion some of the things that are happening on the DAS side and on the Wi-Fi side within the market that show that. And then one final thought is wanted just to take a quick opportunity. Solid has been involved with NEDAS very early on, from Ezra's original vision, and it's really gratifying seeing how this event, how this organization has continued to make inroads, bring people, really the smartest in the industry, together for social events, some of these thought leadership events. And so really kudos, great job to Alyssa and her team. And kudos for all of you coming out and supporting this great event. So thank you. Glad to be here.
Hear, hear. Last but definitely not least, Chintin, Fafadia, Director of Business Development Northeast for PCTEL.
So thank you for this opportunity. I'm glad to be here. We have been involved with NEDAS for almost for 2.5 years now since so PCTEL, just want to tell a little bit about PCTEL and then come to the topic. PCTEL, as most of you might know, we are into test and measurement, both products and services. Quite a few people here, we work with you, and we want to work with every one of you. So that's our aim as PCTEL, because we call ourselves where you come, you need products, you can come to us. So in terms of our products, we do test and measurement products where scanning receivers are our main test and measurement product suite. Combines of scanning receiver, you have data collection tools, we have interference hunting tools, we also have network analytics, and next slide please. And in terms of services,
there's my slide.
In terms of services, we provide test and measurement services in the DAS, in-building and DAS industry, and not only focus on in-building but also outdoors. But we go through the spectrum and the life cycle of the network, starting from design to all the baseline benchmarking, CW, and then commissioning and system verification. So we try to cover the entire spectrum of services as well. And coming to the topic today, it's a very interesting one, that discussing about DAS and Wi-Fi. People always consider Wi-Fi as another capacity adding solution. Yes, it inherently helps you get more capacity, but also want it to be cheap. So it's a good discussion that if people want it for free, DAS comes with a cost. So I think with the questions that we have and the points we'll discuss will help us evolve towards what is the right solution for the industry right now.
Absolutely, thank you very much. Like I gave the one guy who has notes the handheld mic. So starting out, Mike, we'll let you lead off. You mentioned the either or. Just to lay some groundwork, what are the inherent advantages individually of a DAS system versus a Wi-Fi implementation?
Yeah, sure. So, DAS is sort of a tried and true method for densifying the network inside medium to large buildings. So it's known by the industry. Very little interference issues. Works well with the macro network. It's ultimately, in spite of certain arguments, a cost-effective solution for doing that. Wi-Fi unlicensed spectrum, of course, on the other hand, again, coming back to DAS, is the support for multiple operators on generally a single infrastructure and neutral host system. Wi-Fi is a cost-effective way for bringing in capacity. DAS traditionally has been viewed as coverage. Wi-Fi is capacity, and I think once we get further into the discussion and look at more of the evolutionary and revolutionary approaches, we'll see that the lines are blurring a little bit and why they coexist. But ultimately, yeah, Wi-Fi and DAS, you see this at stadiums, you see this at college campuses. They coexist very well, as Bill could probably talk to as well.
Yeah, Bill, is that combination rapidly becoming basically the standard for be it in-building or campus-type implementation?
Yeah, I mean, I wouldn't call it, a rapid combination of, what's happening, but in the sports and entertainment realm especially, so if we've done the Barclays Center and Florida Marlins Stadium, Dunkin' Donuts Center up in Rhode Island, things like that, the combination of the two make complete sense because then there's some economics that can be involved in it, right? There's liability piece to Wi-Fi, as you can imagine, because you're all users, right? You always have to accept those terms and conditions, and there's a reason for that, because obviously if somebody hacks through a Wi-Fi unlicensed realm and does something, takes your bank account information, whatever, somebody's got to figure out who's liable for that. So if we put a network in, what is it that we're doing, and how are we using the two systems together to do that? So the DAS part of it, or the neutral host part of it, being FCC licensed, somewhat secure, because we're the pipe for that network. It hasn't been there, but the Wi-Fi opens up the what I'll call the wild, wild west of all these things that you have to be considered, including interference and et cetera. If you haven't gone online yet and seen, for example, the AT&T build of Dallas Cowboy Stadium, and while it's a competitor and all that stuff, it's pretty interesting because there's, multiple thousand of nodes now. I mean, you're literally sitting on a Wi-Fi antenna, or it's in the rail that you're walking down to, and then of course the number of sectors in that facility to make sure that 80, 90, whatever thousand people have capability, is quite remarkable. And I can tell you from our perspective, with starting in the sports and entertainment, we go by requirements for what a Verizon or AT&T or Sprint or T-Mobile needed in that venue. They didn't even realize what was going to happen. And so the initial builds on a lot of these sports and entertainment facilities were not adequate because people started bringing their iPods or iPads and using their phones, to send video and all these other things. The next thing you know is there's not enough sectors, there's not enough capacity. And still today, I'll guarantee many of you are going to sports events and not having what you desire. And so that's leading to this crash of, hey, what can we do with Wi-Fi, because we can offload some of that capacity problem to the Wi-Fi while the DAS does what it does. So it's an interesting, change. And we're even in my world where I'm kind of responsible for all verticals, including the Class A space. We're now getting REIT owners asking us, should I have you guys put in the Wi-Fi in my common areas, et cetera, while we build this DAS? They're asking that question. And obviously there's some advantages because that union labor here in Manhattan, we might as well use it once and lay the cable and put in the access points and all that stuff versus doing one build and then doing another build and all those costs going up. So it's all happening in our world that we have to consider how are we going to approach it from a commercial perspective. So it's out there, and it's a very interesting dynamic.
That's interesting to hear building owners making a concerted effort to implement things that inherently benefit their tenants but will cost them money. Is that something you're all seeing? Historically, I know there's been a lot of concern where, be it DAS or Wi-Fi, the expectation from building owners is that a carrier or someone else should be paying for that, not themselves.
I mean, I'm starting to see that, the building owners are recognizing that it's a cost of doing business. It's a cost of entry. The people down the street are offering it as an amenity, so now I have to offer it as an amenity. And it's growing. I've been evangelizing for DAS in the enterprise for probably about 6-8 years. And I remember when I first went in, people would roll their eyes saying, yeah, nobody's going to care about this. And now, you have hospitality operators saying, I need to have this here because my clients are going to go down the street because my cell phone doesn't work or my Wi-Fi is not good enough. So it is definitely becoming recognized. It's going to take time. And as the technology evolves, as things become easier, I think you'll see a much better adoption.
We're seeing it in the commercial real estate world, the innovative and creative and those that are looking for value in their portfolios, so REITs that turn over, they have 7 funds or whatever they have, and they need to turn over that portfolio. So they buy a set of buildings that need improvement. They put the X dollars into each building, and part of that improvement is to say, so how do I lease this new building product up? And they want to have the best technology ratings. So you'll think, many of you may know about Wired Score, or it used to be called Wired NYC. So they're like we started in the LEED world with sustainability, calling the LEED Gold, the LEED, all that. Now we're doing it with the technology in the building. And that's affecting whether you get the Google tenant or you get the old school tenant that just wants to use landlines in their phone. And that creates differences in the cost you can get per square foot. So the intangible amenity of cellular and Wi-Fi all working, harmoniously together is creating value for those REIT owners. And they're the ones that are hearing about it, the managing directors and those folks that I speak with at the asset manager level are getting it. And they're starting to say, okay, how do I do this? And how do I do it in a way that adds value to my buildings but doesn't cost me so much?
And it's not only the commercial building owners, even the residential building owners have started focusing on it because it makes a difference. It makes a difference to everyone who's coming into the building, whether it's an apartment building or a condominium complex. You want to market it that you have the coverage that is required in the building. So that helps in getting tenants or clients, and everyone is recognizing things. Obviously, commercial building owners have been on this bandwagon a little earlier than the residential ones, but everyone is getting on that.
So just to add to that point before we move on is I saw some ABI research recently that shared that in what I like to call the middle ground, the enterprise space, only worldwide 2% of that is being covered by in-building wireless. So it's an enormous opportunity that informs that not only a technical but also a business use case, they need to be perfected and to be able to successfully address this space.
That makes a good point, and obviously building owners are often behind and this technology moves very fast. When you are positioning this to property owners, how do you ensure at least a certain degree of future-proofing, or what do you do to ensure that, to give them at least 10 years, let's say, without having to go back and rip everything out and start over again? Is there anything you can do to address that?
We generally come into the face after our customers have pitched in, but I assume that they are making in the pitch where they can provide them a longevity of the system, because yes, stadiums and everything they evolve much quickly because you have 80,000-90,000 people coming in at the same time and you want to meet the capacity. But building owners, they cannot do things again and again. So obviously the proposals have to include all the carriers. Hopefully you can get all the operators in there and try and see from a frequency point of view that if you can have everything in the same fiber, then that helps out. So I'm assuming that's the way it's been proposed. Probably Mike can speak more on that one.
Yeah, I think that so from our perspective, we've never had a system be the way we've architected our system and our solution. We've never had a rip and replace of a solid system. But looking forward, particularly for that middle ground space, I think there are 3 keys to success. It's about reduced total cost of ownership. It's about flexibility, meaning the ability to add multiple services and technologies over that infrastructure, and then intelligence. And those are the things that, certainly OEMs, I think us sitting up on the panel are looking at, are actively developing in order to address and deliver those three things.
Yeah, a company like ours, we have to deploy a system that's going to be upgradable over the next 20 years. Our mindset is because we design, own, operate, maintain it for 10 years plus 5 if we can. That's the ultimate goal, so the economics work out with the current environment, with where we are, with what these things cost. So we actually, tell our venue owners, our network will not be the cause of an upgrade not happening. So because they look at us and go, wow, 10 years and then 15, we're going to be on 9G, not 4G, but we're going to be on 9G by then. What does that mean? And so we educate them on the industry and say, look, 5G is, when is 5G? You tell me. 2019, 2020, I don't know. But the other thing that the world has done, which has been much better than when we started indoor DASs, where we put a 2G or an older system in, a lot of those had to be ripped out, right? They didn't meet the standards of what's going on. But there's been great coordination among people. Your 4G phone works at 3G, right? And the 5G phone, when it comes out, it's going to work at 4G for a long time. So you can tell your owners that even though Verizon puts out 5G in 2019, what are they going to do first? They're not going to come to your little 400,000 square foot building and give you the 5G equipment, right? They're going to go outside and start working on the major metropolitan outdoor networks, and then maybe 2 years later it'll show up in a building. But the point is that we have to be secure in the way we build the network, that when it does come to that owner's building 8 years from now, our network isn't going to stop that happening. And so we actually guarantee an upgrade for no cost to them, as long as the carrier comes to the table. So it's dynamic, but you have to do that because these are 10-year plus deals, even though they're going in their mind, technology changes every 18 months is what I always was taught, but here we are. So it's an education for those that are not, like many of us in the room, that understand what's kind of going on in the industry.
I think back 10 years ago, and I can't even imagine the differences, where we are today. And a lot of that is that infrastructure, making sure you're pulling in hardware, and all of that connectivity that has the bandwidth, the connectivity, and we can take a page really from the structured cabling world, because they've been struggling with that. We've been going from Cat 3. We're at 6, 7, 8 or something at this point. I'm sorry, I work for a fiber company. I don't keep up with that as much anymore. But the reality of it is that layer 1 infrastructure that is universal. And really to then even get to that layer 2. And that's really what we're doing with what we're here right now, DAS and Wi-Fi. This is a layer 2 platform. Everything is becoming primarily data. So to then have different applications that we may not know what they're going to be today, but to have that layer 2 that those things can plug into later on, that's the best way to defend against it. So, we've got AC coming out right now. I mean, that was a challenge to have to run 6A or whatever out to 25 or 50 foot grids. AD will be out after that. All of these technologies, again, make as robust of an infrastructure as you can today.
That makes sense. And in terms of flexibility and longevity, DAS does offer a pretty high degree of that, not to mention, have you ever been able to position it as a public utility or something from a right-of-way standpoint? Are there advantages to the sort of universal applicability of it that it has over Wi-Fi?
I've seen, some residential, high-end, high-rise buildings look at it as, part of the condo fee, part of that infrastructure that, the residents see it as an amenity that's worthwhile. That may still progress down.
One of the steps we have to get over in negotiation with venue owners is the assignment issue, right? These are REIT owners that want to sell buildings. They don't want to encumber their building with any problem child that could stop a sale. So, they look at us and they say, well, we have to be able to kick you out. And so economics are based on 10 years and 15, and we can't allow them to say, hey, your Starbucks store is closed because the new owner doesn't want a Starbucks store in your building, i.e. DAS, and you're gone. So we have to discuss, well, wait a minute, are you going to kick out the water in your building? Are you going to kick out electricity in your building? Are you going to shut the air conditioning off because you have a contract with the elevator company, or, you know, on and on and on. And once you get, again, you're hearing what I'm saying, there's a lot of education of what this is so that they get that, no, that you don't have to worry about it. It's a very simple process, and we've had many buildings sell, and our stuff's still there. So, but it can be a sticking point. We've lost deals because the owner will not agree to that. And obviously, you put a couple $1 million in the building, you can't be told to leave a year later. It's not going to work. So.
There's been a lot of excitement around small cell, and obviously the model of small cell, traditional small cells evolving a bit more towards a front hall, hoteling type model in a lot of places. Does the DAS Wi-Fi combination present a real threat to the small cell implementation plan, or are they complementary? Could one supplant the other?
Go ahead.
I feel they are complementary because it's depending on, every venue is different. So the need for every venue is different. You're not gonna satisfy each and every venue with the same solution. So at some places, you might have DAS Wi-Fi and small cells too, because depending on the location, I mean, you want to cover a stadium and something that is just outside the stadium, then you might want to put I'm sorry, that might not be a right example because you cover it by DAS, but there are locations where you can have a small cell next to it, and they are complementary. So I don't see them as mutually exclusive. They will complement each other, all the three technologies.
Yeah, the point I was going to make, and I think that's an excellent point. As we say, it's a toolkit approach. Every venue, every situation, all the requirements are unique, and so that informs of the right mix of the tools from the kit. But I recall a discussion I had with Ken Rabin, who's analyst at 451 Research, who shared a concern that in the enterprise space, that the prospect of voice over Wi-Fi as a strategy that the carriers will adopt to ensure coverage inside the buildings, that could be voice over Wi-Fi quality good enough for the enterprise, for an office space, and that could be a real threat, actually, to the wide-scale deployment of small cells going forward, if small cells are positioned to be an ideal solution for that space. Kind of an interesting data point.
Yeah, that makes sense. And also, just from a data standpoint, the Wi-Fi per meg is considerably cheaper too. So that was my thinking, is that there's a lot, billions of dollars being poured into stuff that there might be some cheaper solutions out there. In terms of the shortcomings of this structure, obviously Wi-Fi handoff is still not a perfected science. Where have there been venues where you felt this was not, or verticals or types of businesses like maybe hospitals where there's a lot of sensitivity and mobility, or financial services, towards your point about having unlicensed spectrum in a building, if you're handling sensitive information, that becomes a bigger concern.
Yeah, I still think it's a cultural thing too. You know, there's the security aspect that tenants want to do it their own way, whether they're a hospital or they're a JP Morgan Chase Financial on 3 floors of a commercial building. Their attitude is they need to control that, and they need to know what security is going on with it. And so if you're going to end up doing a Wi-Fi for an entire building, they're going to have very specific requirements, or they're going to just not use your Wi-Fi, and they're going to put their own in anyways because of those security requirements. So I think it's a trust issue, it's a culture issue. The cybersecurity hitting the newspaper daily with hacking doesn't help. And so I think it's a compromise between the value you can gain by the capacity offload that's going on between a DAS and the carrier's asking us to put Wi-Fi in, so that offload can happen from the cellular to the Wi-Fi, but for just their use, not for the tenant use. So we're very transparent with when a commercial, venue owner, JP Morgan, whatever, wants to do something like that, is, who's going to pick up the liability, who's going to pick up the security issues, who's going to do that. So right now it's a juggle.
I think just to jump from that point, yeah, certainly security is one point. The other point is that making voice calls over Wi-Fi can be clunky, right? I mean, it's not naturally, it's not easy. The topic, of course, the theme for today is about peering into the future, and clearly, LTE unlicensed, which there's number of news put out at Mobile World Congress, which has this promise of within, I don't know, 2 years, I think, of being more real, that the chipsets, the phones will have that capability, so it is more seamless, that potentially does address some of the security concerns and the clunkiness.
There's a mobility access to it, right, as well, right? We can drive down the street right now and your phone transfers from one cell tower to the next. You can walk on the floors, get in an elevator in a building, and if you have the DAS in the building, in general, you're not going to drop that call. Wi-Fi, however, you're in an office space, you're on that Wi-Fi, you walk out and go to the restroom and you can drop that call because you're off the access point. So as the technology evolves and changes, that's where the threat becomes more. If you get mobility and Wi-Fi and you do a whole building of Wi-Fi, because there's a future there in it, it could be an interesting, small cells now aren't needed, right? Because you got a robust Wi-Fi that's mobile.
I mean, but that's really where the benefit of having the two interaction, really from a macro point of view. Because the macro network, the LTE network, the data network, that becomes the overall connectivity for all of these disparate, smaller Wi-Fi networks possibly. So when you're leaving, you hop on. Now granted, with the voice over Wi-Fi, that's not quite there yet. But the data streams will. If you're not using something that is latency specific, which 90% of what we're using our devices for nowadays are not voice calls. If I'm browsing a web, I really don't care if I have a little bit of a millisecond hop, between when I get off the elevator and go outside. So we're seeing all of these technologies evolve together. I think it's exciting to see all of it. And it's just, we're going to see really the market drive all of these things. And the one caution I say is that we need to not be extremely voice-centric, because it's not all about that. My daughter never uses the phone to talk on it, so.
I think it's funny to hear about clunky calls and dropped calls, and we consider that a bad thing. It's nothing like the cellular network we know now, right? not the audio perfection we enjoy over macro cell. I'd like to open up the floor if anybody has any questions for our panel. I think we have a few minutes left. I want to give people an opportunity to jump in there.
Hi. One question regarding the integration, or actually maybe that is the question. Do you see DAS and Wi-Fi as two parallel systems or integrating them? And if so, at what level can we integrate the hardware?
Well, so from a hardware level, at layer one, so your physical media, obviously you can share the sheet. There aren't that many DAS architectures. I don't think you guys can share the actual cores with any of your hardware at this point. I'm not aware of anybody that can coexist on data streams. So you can share the sheet at least. Depending on your architecture, at some point you may have to transition over to a coaxial or maybe a twisted pair architecture. With some architectures you can run fiber all the way out to the edge and really enjoy a lot of kind of shared cost and shared infrastructure.
Yeah, I wouldn't call it integrated right now. It's just not there yet. It's really two networks, but we're trying to gain the synergies by having the two networks be put in together. So like he said, decrease in labor or using the same conduit or whatever we're doing. But it's not to the level that it's a thought about combined network. It's really two networks.
Most of the cost is installing that first cable. You need to go back and pull another cable because there's a technology evolution, or you went from SISO to MIMO. That's where your upgrade costs are. So being able to have that, put in enough fiber, put in enough coax day one, that'll really protect your investment.
And I would just add, once again, peering into the future, as we look at next generation DAS, and I don't know if we're even going to call it DAS as it becomes next generation, but I think at that point you're looking at very fiber, all fiber networks where RF and IP ride the same infrastructure, so you get those economies
Still, you're going to architect it. The antennas are going to be placed differently. You're going to design a system. The RF antennas are going to probably, in order to gain that densification, are probably going to be in different spaces. But as we look at those all-fiber kind of enterprise passive optical LAN type of architectures, I think then we start talking about integration, at least on the infrastructure side.
I agree with all the comments that have been made. I mean, in terms of into the future, if it's all fiber, that's the time you'll start seeing them probably evolve towards a single network. But at the same time, right now, if you have a greenfield design, you want to put the two systems, though if they might be parallel networks, you want to do things at the same time, save cost in terms of everything, installation, testing. You want to make sure that you can do everything at the same time.
So what if it's not all fiber? Obviously, ideally, it would be, but towards your point, 2% of the in-building is covered. There's a lot to do. Aren't some people using Cat 5, Cat 6 type structures, and there's a lot of home run networks out there that you could plug into? Is that a viable short-term solution, or what's the longevity of that kind of utilization, you think?
Well, I almost think that's the way they're doing it with a Wi-Fi system. They're using the current backbone of the building to do their Wi-Fi. We're an add-on, you know, we're another conduit that's filled with our stuff kind of thing. I mean, when you're talking about integration, I'll give you an example. In the power world, you know, when we put a DAS in, some of them we put in where you're literally plugging in those units up in the IDF closets on floors 6, 8, 12, right into that wall, right? And there's no real backup power for those things. The backup power and all that thought process is in the head end. We're actually have integrated our power now into the head end. So when we can run dedicated power up the conduit. So it's the same kind of philosophy here that if we're doing all the power out of one room, why couldn't you do all the services out of the one room, kind of a managed way? So you're effectively running a integrated, heterogeneous kind of network that's Wi-Fi, power, DAS, you know, all simultaneously to get the full effect of what the tenants want in that facility. That's kind of what it is.
Sorry, another question from the audience?
I just had a question about the Internet of Things. So from a business model, product, or infrastructure perspective, do you see yourselves having to pivot? I mean, you will do, some of you do similar things, some of you do different things. You have to pivot to take into account this potential influx of more and more data from your refrigerator and your toaster and whatever else might be thrown on the IoT.
Absolutely. From a hardware point of view, you know, we very much broadened our point of view on how we design things, you know, the hardware that we're designing ourselves, but also other third-party hardware that can be integrated onto these infrastructures, because we can't develop everything. That's one of the nice things about a competitive marketplace, is it's going to drive innovation, and there are going to be other folks that can ride, you know, possibly over that infrastructure. So for the Internet of Things, it's kind of why I make, you know, while we are very voice-centric, being a DAS point of view, there are a lot of other things that need to connect to these networks. Cameras, building automation systems, door locks. You know, these are all opportunities where you can get an ROI on that infrastructure and still deliver your DAS, still deliver your Wi-Fi. So it is really pretty exciting for me as a structured cabling engineer and RCDD that came over into the DAS world to really see things evolving just the same way structured cabling did a while ago.
The capacity issue is what's driving this whole market. It's not, to me, it's not coverage anymore. It's, you know, the macro's got a problem in the major metropolitan, right? I call them the NFL cities. If you got an NFL city, you're going to have a macro problem outside. So when it started to hit 80% max on these cell towers and all these other things, oh, guess what? We got to offload some of that to indoor. And so the carriers want to go to that building because they can offload capacity. It's not really about, it's almost not even servicing their customers. It's about servicing their customers only because the macro will work better. So in a building, we're finding the intangible results of the same thing. So where a building owner or tenants put in what they thought was the right capacity Wi-Fi system, and they did not have a DAS in it, now they're having to upgrade their Wi-Fi, upgrade their Wi-Fi, upgrade their Wi-Fi. We have intangible results now of when a DAS gets put in there, a number of those people that are now happy with their Verizon or AT&T coverage in the building are not going to the Wi-Fi. So they're freeing up capacity on Wi-Fi by staying on their cellular system. Exception, what do we all have? Data plans. And so it's still driving many people on their phones to go to the Wi-Fi, right? Because they don't want to use up their data. So as that market change and the industry adjusts, and if all of a sudden there's enough competition that data gets unlimited again, you'll see a shift again, because they don't have to go to Wi-Fi for that cost savings. So we're watching all that as we build these networks.
Yeah, and just to add on, I think, you know, IoT informs of the need to break what I like to call the infinite coverage and capacity cycle. It's how do you drive ROI? How do you do more stuff? How do you create real business models that you can literally strap on services onto these networks, that the infrastructure stays in place, and that the front and the end pieces are the things that get swapped out or added or expanded to and drive real revenue opportunities, and to do the things that these two gentlemen were just talking about, building automation. You know, we're seeing beacon advertising technology. You know, you want to look for a revenue and ROI model, that one could be pretty compelling. Yeah, if we can get past the kind of scary Big Brother aspect of it, but it's coming.
You're buying hot dogs at your seat in stadiums, and they're bringing them to your seats off your Wi-Fi. So it's.
Yeah, hello, Ed Via with Edge Connect. You know, I think over the last year, what we've seen is more and more landlords, hospitality industry, they're coming around to the idea that they have to have this. And I think what's missing actually, and they have control over that, over Wi-Fi. We know particularly a particular hospitality group that built some DAS and nobody came to it. I think what's missing is there is now, the challenge seems to be more getting the carriers to agree to come on board some of these systems. The 2% you mentioned, Mike, that's only been addressed, this is huge market. With BYOD and everything, everyone's getting the picture, the venue owners, landlords and things like that, that this kind of capacity, that they need to bring it. And they have control over Wi-Fi. But if they build a system today, there's no guarantee that the cellular providers are coming to it. And I think that's something we need to really start addressing as well. I'd love to hear what you guys think about that.
Well, on the neutral host side, and we get venue owners that think they can make tons of money off of us building a neutral host, right? And we're going to give them a bunch of rev share and all these other things. And then we do an evaluation of their building, and it said, no, the reality is you're going to have to pay for the whole thing, because the only way to entice a carrier to come to this is you're going to have to foot the whole bill, and then we'll go and say, would you please bring some kind of RF source to this building? And that's our role to try to make that happen. It doesn't always happen, you're exactly right. And so that's why we, in our qualification of what real estate we go after, we have to be, you know, as good as we can be, so we have a hit rate that doesn't, you know, create credibility in the DAS industry where we go sign up a bunch of real estate and then they're all disappointed real estate owners. So you're exactly right, and you know, so our philosophy isn't to go, you know, sign up 1,000 buildings and then only get 100 of them built and then have that credibility problem. Our philosophy is to try to find the market where it makes sense, this capacity issue that the carriers want to do. And if we build relationships well enough in the regions with each carrier, the carrier will come to us and say, hey, Super Bowl's coming to Minneapolis in 2018. That would be a good place for you guys to go. San Francisco, you know, is coming up this year. Houston's coming up this year. We built networks in Tampa because the Republican National Convention came in. You know, so you have to kind of go through the philosophy of what the carriers are looking for, helping their wealthy clients, their people that stay in 4- and 5-star hotels, because they don't want that person to give up their Verizon phone and go to AT&T. So it's a very dynamic.
Those are the large ones, right? But
Yep.
I think, what about that
Right.
huge
Yep.
market that's not large?
So I believe that is a cycle which is governed right now. While, like, if you look at the data plans, how they are evolving, we are inching towards unlimited data again. So if that keeps going forward, unlimited data will again make the carriers to focus on that part of the market, which is 98% of the market where buildings are not covered. Because if your customers are demanding it, it's going to come by your customers' demand. So they have to meet it. So that is where if the cycle keeps evolving and the pricing keeps falling and unlimited data actually becomes true on all the carriers, then you'll see that demand grow again. And that will in turn have them come back to the building owners and have their networks to provide the same capacity and coverage in those areas.
They want to come to a lot of buildings. The issue is their funding within their region of how much they can do, and so we deal with that. What will it take? You know, and so we'll, you know, we've got to figure out if $4 a square foot isn't the right answer, if it's $1 a square foot. In other words, portion of this build is getting commoditized. The problem is, we have labor union costs to do, and we have, the equipment from these guys to buy, and it's got to be all worked into a model that can work,
And that's really, again, where kind of the mixture of these two work well. Because, the Wi-Fi, particularly if it's an enterprise-owned Wi-Fi, is self-determinate. You know what it costs, you know the timeline, you control it. That's a short runway for you. You can get that up and running. If you think ahead and design so that you can do both, that way you can have on that longer runway the DAS RF path. And you can get the best of both worlds possibly. And you're not necessarily slave to it. So if for some reason you can't get all of the carriers that you want on there, but you can get 2, you still have that gap covered with that Wi-Fi infrastructure. And obviously you're not going to get the voice part of it. But it's an evolving network, and as technologies change, you may be able to get the voice over it.
So,
Okay. We have another question back here, if that's okay.
Morning, guys. Ray Hill with Galtronics. So I've heard convergence, right? I've heard platforms, infrastructure, Internet of Things. The one thing that I'm wrestling with is the FCC rulings that have come down the last few weeks about location-based services inside of a DAS. As of, right now we know that Sally reports to the head end when in fact there could be an issue in the dorm, right? I see that as a potential driver for the carrier to get engaged in location-based types of technology, but I also see a major upgrade issue with the 100,000 DASs that have been deployed around the United States. But in my mind, I would like you guys to comment, in my mind there's a common theme here about convergence, and I think that perhaps the FCC rulings may help us move more towards the Wi-Fi cellular convergence for them to comply, A, and we can build a smart network that allows them to do that, then overlay applications on that infrastructure. Do we not now have a HETNet? The comment I'd like to hear is, how do you guys think the FCC rulings plays into this discussion?
So from one bald head to another, I appreciate you're setting me up for this, right? Public safety was actually a point that I did want to touch on. I had the chance to speak with Donnie Jackson, who's the editor at Urgent Communications last week. And so Donnie was telling me about a couple weeks ago at IWCE, there were some announcements that some of the LMR, the public safety radio manufacturers, are adding Wi-Fi to the radios. And so one of the issues that a lot of us in this room are wrestling with is, how do we ensure that the public safety, the first responders, that they're able to communicate effectively inside the building? If we assume, pulling back Wi-Fi, the importance and value of Wi-Fi to the network, Wi-Fi then becomes a very interesting way that, as Donnie said, kind of turns things on their ear in being able to successfully enable the public safety, the LMR radios that are equipped with Wi-Fi to work so that the public safety guys can do their job better. In terms of location, E911 location, Wi-Fi once again is one of those leading technologies that we're looking at as to how do we pinpoint not only the X and Y, but also the Z coordinate of where you and I as the general public where the fire guys, where the first responders are going to be able to find us. So Wi-Fi plays a very interesting component in solving for that, changes a lot of things.
I just don't know, is my answer. I mean, there's a lot of confusion. The whole net neutrality and the rest of this that's going on right now has caused, just a lot of confusion in what's possible and where markets might change, and have you impacted the carrier's ability. I mean, they spent billions for these FCC licensed frequencies, and now they're saying you can't, you need to level the playing field for what you can make off of those frequencies. So I feel for them as well, as they go through their business models trying to figure out what's going to really happen here. I think we do have to do public safety, and it should be included in things. And I don't know how many of you are vendors. How many of you are like building owners or users? We generally at these conferences don't get many of them, even though we all invite them, right? I mean, I do. But it is what it, so everyone understands that a public safety network, you're going to have 50 firemen on that network. You're not going to have 3,000 people in the building on that network. So that it can be spread out, right? There can be less access points. It's a coverage thing. It's not a capacity thing. So that network should be fairly easy, less expensive to build, and it really is the right thing to do. We've all lived 911 and all the other things where people got lost. So we've tried to figure out ways, how do we integrate that into our cell? Again, we get back to, guess what? Liability. So we own, design, maintain, we're responsible for the DAS network. The DAS network is an amenity. It's not guaranteed to be your safety network. Therefore, the liability is limited, right? Zero, almost. You put a public safety network in, you guarantee that 800 megahertz or the 450 megahertz is going to fly across it, and the fireman is going to be able to use it. Different liability. Fire happens, he goes in there, it doesn't work. Big deal. So our litigation, as it is in our country, makes it hard for us to figure out how to do that and to take that risk. So it's just another game, and that's the same thing with Wi-Fi, with this hacking and all the other things. So all those considerations make the business model, the risk, cost, benefit thing, very interesting to deal with.
Ray, I think to your question on location-based services, obviously the current hybrid fiber coax architecture, that's going to be a little bit difficult to do when you're looking at particularly a single amplifier feeding 10, 20, 30 antennas. You get no spatial resolution. The Wi-Fi architecture, they've really they're ahead on that. They've got the location-based capabilities. And some of these smaller, really active antenna type of architectures, those are going to be the ones that are going to be able to do it, but it's not out there yet. So, build it and they will come. It's an exciting time in our industry, and as these challenges come up, you're going to see various vendors and folks rise to develop those solutions.
We work with partners on the Wi-Fi side, and the location-based services, remember that network's a lot more expensive than just a basic Wi-Fi because of how they have to work out, so smart malls, right? You may have heard of that concept, right? Because the mall owners want to know, what door are they walking in? Where are they hanging out and getting on? Are they hanging out near the Starbucks? If they are, and there's a Best Buy right next door, can I push a coupon for Best Buy while they're standing there at the Starbucks? That's the kind of location-based stuff that is economical. But that Wi-Fi costs more than a basic, just give them a Wi-Fi, in a common space kind of thing. So it's there though, right? We're doing it in sports entertainment and everything else, so.
All right.
Excellent. Unless there's any more questions, I think we are out of time. Thank you very much to our panelists. It was very enjoyable. Appreciate it.
I need 6 8x10s, 3 4x7s.
Oh, in wallet size.
Wallet size for my kids.
Okey dokes. So I'll give you a moment to settle down so we can go swing right into our next session, because this is the only thing that stands between us and lunch. After this session, we will convene for lunch. It is on the second floor. There should be signage. It should be pretty straightforward for you to find it. And it will be a buffet-style lunch and nice hot food. So I'm going to get your stomachs grumbling here with great anticipation as we kick off DAS design and deployment start to finish. So Snyder & Snyder, thank you so much for sponsoring this panel. They are here, and Jordan Fry, representing Snyder & Snyder, is a senior associate of the law firm. He will be moderating this panel. He's most recently focused on negotiating complex distributed antenna systems agreements for Class A office buildings, hotels, and sports venues throughout New York City. He's obtained numerous zoning approvals for communication towers and rooftop installations throughout the New York metro area, and he is a New York Law School graduate. So without further ado, I introduce you to Jordan.
Good afternoon, everybody. So I want to thank you all for coming and to our DAS design and deployment from start to finish panel. We have a great group of panelists today. They have a combined 100 years of experience servicing the wireless industry. Starting us off will be Jeff Reale of Antenna Systems. Jeff's going to be discussing the DAS design phase. He'll be discussing determining venue needs and specific requirements. This will include determining existing macro service at venues, as well as designing a system to meet the venue's needs. Following Jeff will be Fred Bancroft of Corning. Fred will discuss the DAS architecture. His presentation will include topics such as equipment selection and the convergence of multiple technologies over one single platform. Next will be Ray Kramercy of Alpha Technology, and Ray will discuss powering up the system within the venue. He will focus on two segments, the head-end area as well as the remote access units. He will also discuss backup power considerations as well as space issues within the venues. Next, Carla Schaefer of Annixter will discuss project management and system implementation. Her presentation will highlight the importance of coordinating material, construction planning, installation management, and validation of the systems. She will also discuss just working together with the contractors, the integrators, making everything work together. Finally, Art Meerdurk of INAC will discuss operations and maintenance of the system. He will highlight key operations and maintenance and support issues that need to be considered actually at the start of the design phase. He will also hit topics which he will discuss following construction. Now, we have five presenters today, so we do have a limited amount of time, but following our presentation, we will open up the panel for a Q&A. But to the extent that we can't get to everyone's questions, please feel free to approach us after the presentation. So without further ado, Jeff, please start us off.
Thanks, Jordan. Appreciate it. First name is Jeff, last name is Reale. I've been in the DAS industry now for about 13 years, wireless in general for about 17 or 18. When I started out, I spent the first 9 years of my career working for a wireless service provider. 5 years as a macro cellular RF engineer and 4 years as a project manager deploying DAS solutions. Then I made the jump to a DAS product manufacturer, and for the last 4 to 5 years, I've been working on the integration side. So I've seen this industry from a lot of different angles, and I've seen it evolve in tremendous ways over the last probably 5, 6, 7, 8, 9 years. So we're going to try and lay out a blueprint for you today that it was hopefully smooth out some of the bumps. The DAS industry can be very complex. There's a lot of moving parts, and it's only become bigger and more complex over the last handful of years. But Antenna Systems, having been in the business since 1998, we put together a fairly methodical process that kind of walks you through each and every one of the steps needed. All the bases are going to be covered, and hopefully you can have a much smoother implementation where you don't run into some of the commonly held snags that kind of hold us back every now and again. So this is a really obvious slide. I realize that I'm pointing out the obvious, but the keys to success on a project, you got to have really good planning, good execution, good leadership, and good communication. It can't be overstated. There's an awful lot of areas and situations where one of these things kind of falls out of the mix on a 3 to 6 to 9 month process, and it becomes a lot more difficult than it really needs to be. So the rest of the presentation is really built on a process that provides a blueprint for handling all the various tasks that come into play. Now, a company like Antenna Systems as a legacy DAS integrator that's been around for a long time, we can do all of these things, or we can do individual tasks to fill in the gaps. So the ecosystem within the DAS space has become a lot larger over the last handful of years. So there's many more players, from consultants and low voltage installers, and just an awful lot of players that we're working with these days. So we've kind of migrated our business model a little bit away from the turnkey aspect of things and more into the smarts and parts, where we dive into the design process, we help out with the requirements definition, we pull off the system acceptance testing, the commissioning and optimization, but a lot of times other parties and other organizations fill in other gaps on implementation, on material procurement, on some of the design work. We've been working with Ray's team to upgrade our power plant capability for a lot of our DAS solutions. We work with Fred's team on a lot of the next generation product designs. So those two guys are really going to fall into what I'm discussing with the requirements definition and the system design. Then Carl is going to discuss system implementation, and Art's going to handle maintenance and support. Each one of these 4 building blocks is equally important. If you're missing specific steps within each of these areas, sooner or later the project's going to kind of go sideways. It's just a question of whether or not that happens at the beginning of the process, during implementation, or a couple of years down the road. If you want the DAS to live a nice, long, healthy life, you're going to need to take care of monitoring and maintenance. If you want the DAS to be installed correctly, you're going to need to have certified installers that really know how to work with the product sets. You need to have good construction management. So going into the requirements definition phase, really it's just the acquisition of floor plans in AutoCAD, determining the services. This is the area where people kind of really get hung up. This is where we see a lot of RFPs fall apart, because defining the services can range your cost per square foot from 50 cents a square foot for a single layer public safety system to in excess of $2 a square foot if you have a multi-technology, multi-carrier design. One thing that I really don't like seeing in RFPs is when an RFP is led, we're going to require a public safety system first, but we want an add alternate for a cellular system that you can just add to that public safety backbone. You really can't do that. It doesn't work well. It's apples and oranges. There's antenna density related issues. There's a lot of equipment issues. There's a lot of incompatibility with filtration from lower UHF and VHF bands with the higher cellular bands. So you really need to know what you're doing up front in that services defined phase. The next step is the budgetary design process. In Ivy Wave, we put antenna layouts to floor plans, we put in the architecture, we decide what architecture is the best fit for that set of applications and the assumptions that we need to work off of, and then we get into the budget refinement phase. Now this step right here, this requirements definition, Antenna Systems will perform this to deliver a budgetary design package for free. We don't charge for these services, and we can get you about 90% of where you need to be in terms of price point and in terms of how the architecture is going to be laid out. The next step, though, is the actual system design, where we get on site, boots on the ground with an installation site survey, knowing the code, safety, and installation requirements, going through the ambient signal testing. This isn't something that was done 5, 6, 7, 8, 9 years ago at the beginning of the process. Now it is. So we benchmark all the carrier signals and all the carrier penetration and all the carrier technologies inside of a building, and it helps us validate our design process. And you have to go through that up front, and these are manpower-intensive activities that also have a pretty high price tag in terms of the software and hardware to support that type of testing. Then we'll get into the design and predictions, we'll validate the design, we'll make adjustments to the design, and we'll deliver the final design and carrier coordination packages. Make no mistake about it, you shouldn't ever activate a DAS without carrier permission. You can't rebroadcast the carrier signals without getting the paperwork in order. So there's a lot of rogue systems out there fed by wideband bidirectional amplifiers. They're illegal. You're not allowed to configure them in that fashion. So Antenna Systems spends an awful lot of time working with the right carrier contacts, making sure their requirements are met, and then putting together the packages to get the approval. So we facilitate that process between the enterprise and the carrier. Next, we're going to get into some of the product differentiators that factor into defining the requirements and defining an architecture or choosing an architecture that fits and satisfies the requirements.
Thank you, Jeff. So not to be outdone by my friend, and I'll also stand up. I feel a little bit like a motivational speaker. Who wants to change their life? So we have a great panel, a lot of industry specialists across a wide variety, but we cross-pollinate quite a bit, and we were talking about who should talk about what topic, and they said, Fred, we want you to do equipment selection. I work for Corning, right? So, okay, but I know what the answer is. But no, I'll try to be as neutral as possible. So yeah, as Jeff has said, there's a couple things to think about. There's the architecture itself, and then once we get into a selected architecture, there is the manufacturers. A lot of the manufacturers, all make great products. There are different aspects to each of them, and we'll dig into that a bit.
So from a high level, when we want to decide what kind of architecture we're going to deploy, those who have been in the industry know we started with a passive architecture, really just a repeater-fed system, which is all coax and antennas. Then we've moved into hybrid fiber coax architectures, which have sort of a little bit of both, but can grow and can accommodate neutral host systems. And now we're in the age where we have all fiber architectures available to us. When you are selecting some of the products or the specific OEMs that you want to decide, some of these key considerations are what you want to look into. Now, sometimes that selection is already made for you. The carrier may already have decided based on preference, but usually if they've decided on some of these points already. So some of the considerations: remote output power and power consumption. Those are two different things, but the amount of RF output from these remotes is going to be critical and should be matched to the venue. So if you have a large open air topology, you want to use a higher power remote so that the signal gets down to the users. Likewise, or the inverse, a small dense environment may be more applicable to a lower power remote. Then when we get into ODAS, of course, we're talking about very high power. And then it comes to power consumption, because we have to supply electrical power to all these things, and you just may not have the infrastructure available to power very high power remotes, or you may come into the requirements where DC power is required. And in that case, we need to supply our own power directly to the remotes, and we can't count on building power. So those are the top two considerations. Then we get into physical equipment size. Everybody who has done deployments in major cities knows that space is at a premium. So we need to house the equipment both at the head end, and if we have equipment in the remote closets, we need to know how big the equipment is and if we have space to do it. So that's a key consideration. The last panel talked about converging Wi-Fi and DAS, and that was a great tee-up for me to talk about upgrade path. So upgrade path can be several things. It can be upgrade to support additional carriers, so you may have one lead tenant but have it neutral host ready, but it also may be an upgrade path towards other technologies, Wi-Fi, building automation, passive optical networks, and really the sky's the limit when it comes to services and technologies that we could foresee in the future that we'll deploy in a DAS system. A little bit more on neutral host. The way that we accommodate multiple carriers can be done in different ways. Depending on the OEM, you may have a situation where one remote has all the bands and each wireless service provider shares some of that amplifier for their own signal. Other architectures may use a dedicated amplifier for each wireless service provider. There are pros and cons to both. Cost and size come into play. But I heard the question or the issue raised, what if we don't know if a carrier is going to come on? We don't know. We can't foresee, if T-Mobile and Sprint are ever going to join the system. Well, in that instance, it may be in our interest to deploy the kind of architecture that has separate dedicated amplifiers for each wireless service provider, and then grow as other carriers agree to come on. And then finally, the services to be deployed. So we're at a stage now where OEMs have 4, 5, 6, 7, what's the highest? 8 bands, in one remote. So that covers a lot of what we have today, most of the bands, but we have WCS, we have AWS-3 coming. It's really probably never going to stop in terms of what new frequencies and technologies we're going to deploy. So what do you do about that to future-proof it as best you can? So in a typical installation, and for here I'm talking about both Wi-Fi and cellular DAS, what we have is dedicated head-end components, and then we have amplifiers at the remote, and we have dedicated coax, typically half-inch coax, through the building out to antennas. These other services, Wi-Fi, LAN, they all have their own parallel dedicated layer. And that works fine when you do them separately. But as the last panel said, we're getting to a phase where we want to converge all these networks onto one architecture. And it was sort of implied that that was something that's in the future, and it really is not. There is all fiber architectures available to you. The Corning One platform is that architecture. So it basically allows you to have the same amount of services that you want to deploy, passive optical networks, cell, Wi-Fi, and share a structured cable that you pull once. So we don't know what technologies are going to be on the ends, both as an input and the active electronics on the edge. But we do know that fiber has unlimited capacity and bandwidth, and it's frequency agnostic. So no matter what comes down the road, an all fiber optic infrastructure is where we think we want to go. There's several additional other benefits in terms of space, cost of installation and all that. So real quick, just some of the benefits of fiber, all fiber in an infrastructure versus coax. Unlimited bandwidth, as I said, just the size too. Sometimes you don't have the ability to pull half-inch coax easily. Fiber is pretty rugged now, bend insensitive. There are benefits there. We talked about location-based services. On the last panel, they mentioned it. With a system like the One architecture, we have one-to-one optical connectivity out to the edge. The antenna is the remote, and so we can leverage these location-based services with almost a Wi-Fi-like granularity. Future ready, I talked about that. MIMO. So MIMO is a hit or miss in buildings. We typically don't see it too often unless the capacity requires it, but we may want to future-proof it. Right now we're at 2x2, but it can go up to 8x8, I think is the future. And so if we want to be future-proof, we want to add the redundancy for separate paths for MIMO. Gigabit Ethernet support, they talked about that in the last panel. So an architecture that can support the Wi-Fi, support the DAS, support PON all in one. Configurable sectorization, that's really going to be key to the carriers in the future. Those network radio assets are expensive, and you take a stadium in a college, which is empty 95% of the time. They spend a lot of money with the radios to cover the games, but it's unused most of the time. If we can steer capacity to where it's needed on the fly, that would be an architecture I think that would make the most sense for the carriers and for the venue owners. And with that, I'm going to hand it off to Ray.
I appreciate all of you letting us delay your lunch a little bit. I know everyone came here wanting to talk about power. It's the most exciting part of the DAS system. But it's actually critical. You can do the best design work possible, you can pick the best equipment possible, and if you don't have reliable power, it's not going to work. You're going to have remotes that go down. We've got a couple projects with Jeff's team that we're doing where we've gone in and they've figured out, hey, I've got 3 or 4 remote sections that are down. What's going on? It's power. They used a small power supply. It failed. And so they had widespread outages. They thought it was an equipment issue, and really it was just a basic electrician error. So there's 2 main areas we're going to talk about when we look at power. The head end, everybody thinks about the head end. Everyone thinks, hey, I'm going to back the head in. I'm going to put 4 hours of battery backup or 8 hours of battery backup in there, and I'm going to be good. The issue is they don't consider the remotes. Well, if you don't back up the remotes, it really doesn't matter if the head end runs 24/7. You're not going to feed any signal back. So when we look at the basics of DAS power, first thing we're going to think about, I'm going to put my remotes out there. Do I have available AC? Because I've either got an AC or a DC fed remote. Traditionally, the indoor remotes have been AC fed. We're seeing more and more DC. Well, I might be putting it in an IDF closet, telco closet. Well, that's great. Here in New York City, you may not have access to it. You may be putting it in a closet. They may not give you AC power. You may be responsible for getting it there. What's the cable distance from my, let me get all these up. There we go. So the 2 architectures you look at are local or remote. So localized, I'm going to put a UPS or a DC plant in every single remote. Remote, I'm going to put in one big power system in my head in, and I'm going to cable up. So there's advantages and disadvantages to both. Available at AC at each is one. The cable distance. How far my farthest remote is from my head in is going to dictate whether I can remotely power it or what method I can use to do that. I wish I could defy physics and the rules of electricity, but you can't. There's a thing called voltage drop, and you can't get past it. So, space availability. You know, this is probably the most expensive city in the country. Well, it might be really hard for me to find a 2 foot by 2 foot by 2 foot space in every closet to put in a power system and batteries. That may not be feasible. And it's not really very aesthetically pleasing, especially if you're going to be in a public venue. If you look in the New York City subway, you'll notice all the power is up on the ceiling because they don't want people to be able to touch it. Individual remote loads and voltage. This is, again, a city where we're seeing outdoor remotes used indoors. Well, that's a much higher power consumption, much higher power capacity, and that's going to affect your plant. Maintenance. If I've got 30 remotes and I put 30 UPSs out there, that means that every 2 to 3 years, I'm going to be out there changing batteries. It also means I now have 30 points of failure within my system. Is that a good design? Probably not. And then, can I go with a Class 2 architecture? And we're going to spend a next slide on Class 2 architecture as to that's a remote power system method. And then length of backup time required. How long do I want it to run? Standard for some carriers is 4 hours. Standard for some carriers is 2 hours. And then some are just using evacuation plans. If the evacuation plan for that building is an hour and a half, that's how long the system has to be up. So Class 2 fundamentals. So the reason you're going to use a Class 2 architecture is it allows you to run the power cable just like a comm cable. It means that I'm going to be below 60 volts DC, and I'm going to be below 100 VA per circuit. There's a couple of misnomers on that. A lot of people think, hey, if I use a fuse panel, I can do that. I've got a 48 volt plant. I'm going to get 48 volts out, 54. And then I'm going to put a fuse panel on there with a 1 amp fuse. There's no possible way I'm going to pull more than 100 VA out. Well, the issue is that fuse goes bad, and the contractor goes in and goes, all right, I got a 25 amp fuse, and he sticks it in there. Well, now you're not Class 2 compliant. So in order to meet Class 2 compliance, you have to have 2 methods of circuit protection. So that if the primary method is bypassed, your circuit still cannot go over 100 VA. Class 2 circuits don't require conduit. They don't require an electrician to install. That can translate to about a 30% installation savings. Huge, huge materials cost. If you're a DAS, your DAS integrator can now pull the cable themselves. They can pull a single Corning composite cable all the way from the head end to the remote, and that handles your communication and your power. There are a couple of caveats to that. In this city, if you are in a designated cable shaft, that NEC rule applies going between floors. If you go out of designated cable shaft, you will have to use conduit. City of Chicago is another caveat where conduit's used everywhere. We think that's political, but we won't get into that. So when you look at a Class 2 power layout, the head end, you're going to put all of your power there. We're going to put a big 48 volt plant in, big depending on the size of your system. Off that, we're going to use a DC to DC converter. Our elimiter product has a built-in DC-DC. So it says 48 volts DC. We're actually going to raise the voltage up to 57 volts DC. The original systems that came out that were Class 2 compliant took 48 volts in and put 48 volts out. The issue with that is you actually can't calculate your voltage off 48 volts. You can only calculate it off 42, your battery cutoff voltage. So that means the max distance you're going to get with a 48 nominal current limited panel is about 1,000 feet. Well, if you got 40 stories, you're going to be in a lot of trouble because you're not going to go straight up and straight to the remote. It's usually up, over, around, through stuff. So 57 volts is going to give you about 2,500 feet. If you've just got a single small remote, you can home run it. Single cable, head in to remote, you're done. Power, communications. But let's say I've got one of the Corning HX remotes. Corning HX is about 450, 500 watts. That means I can't use one cable. So what you have to use on the other end of that is what a product called the aggregator. So we're the only ones on the market that have one. It's UL listed. What that does is it aggregates the circuits to the end. You can take up to 8 pair and land them on there with a single bulk output. To meet NEC Class 2, you cannot bond pairs. We do bonded pairs for outdoor line power, and on that we can go 190 volts, 5 miles. Indoors, you can't do it. You have to aggregate the pairs at the other end. So why would I not go with non-Class 2? I just figured out it's a 30% cost savings. Sounds like it's great. Well, it might have an AC powered remote. I can still remotely feed an AC powered remote. I'm just going to put a big UPS in the basement, And I'm going to run the cable up. I'm going to use conduit. I'm going to size my wire gauge based on voltage drop. High power consumption remotes. About the maximum you're going to be able to do with a DC fed remote is about 650 watts. You've got to account for voltage drop again. We can't get past the laws of physics. Jurisdictional restrictions, again, Chicago. And then the same conceptual layout. As I said, we're going to put that AC UPS in the bottom and lay it out. Or if I've got a high-powered DC remote and I can't do it with the aggregator, I might just use a large DC plant, home run it, and put it in conduit again. And then head-in power. So touch on just for a second. Standard runtime is 4 to 8 hours. Huge range of power. For an enterprise, for a high-rise, it might be 1,000 VA. If we're doing a stadium, it could be thousands of amps. A lot of times we'll look at stadiums, they'll say, hey, I want this design to last. Well, that's where you got to look at modularity and scalability. If you're going to look at, hey, this system's going to last about 5 years, I've got to make sure that I've got enough growth capacity that if I put in a remote that's 3 times the size, I'm going to have the room to grow into it. And then space and environmental conditions. I wish they all went in nice, clean rooms, but they don't.
Milestones and really the whole process as to how DAS kind of starts from start to finish. And we really want to make sure that everybody understands this, because while everybody needs this and they need it to deploy quickly, it doesn't deploy as quickly as everybody wants it to. So setting the right expectations for your customers is absolutely critical. So we start with identifying a DAS need. And that can actually in of itself be a difficult piece. Whether or not a building understands throughout their entire high-rise in an environment like New York City, is it absolutely necessary? That's something that can require a design and some RF survey testing in of itself. In some cases, it's only the basement. In some cases, it's new construction with LEED requirements with low E-glass windows, which makes it a little bit more obvious. But when you have an existing building, first of all, you just have to identify, do I need a DAS? Do I need to enhance my coverage, be it cellular or public safety? And do I need to do it throughout the whole facility? The next piece, once the identification has been made, is the budgetary quote. How much does this cost? For some reason, a lot of people have a number of $10,000 to $20,000 in their heads. Where that number came from, I have no idea, but it's so common and we hear it all the time. And making sure that our customers know that it's actually going to cost anywhere from $100,000 to $1 million or more dollars, depending on the size of your venue, is absolutely critical. Because right then and there, a customer can decide, how critical is this for me? Our services, whether it's public safety or more so cellular enhancements, they're becoming more and more necessary throughout our day-to-day lives, and it's becoming more of a utility. So now customers are more seriously looking at it if a carrier is not paying for it. And we've all seen a big impact to carrier funding in the last 6 months. It's more on the enterprise to look at it and say, okay, I need to take care of this for my customer myself. I need to ensure that this service and the satisfaction of my tenants and the people in my building are here. So making sure that they have a realistic budget is absolutely critical. The last thing you want to do is go through this entire process to end up with a customer having sticker shock after design and time and RF engineering has been spent, to have a customer say, oh, there's no way I can afford $250,000. I thought it was $10,000. So it's really important to get there to that stage in the game. This is an area where someone like Annixter can help to work up a ROM tool to give you and your customer a budget as to what's expected, what's realistic. Another area is our integrators. So you want to make sure you are working with the level of expertise that can do this and that can walk this whole process through with you. That's really what we're going to talk about right now in my portion of the presentation, is the importance of having the key players between the integrators as well as the contractors, consultants alike, and then the distributors who provide all of the parts and pieces to make this process seamless. So once the budgetary quote has been established and a customer says, yes, I recognize it's going to cost me $500,000 and I still need it. I've taken it to my upper management and we've decided to move forward. That's when an RF site survey can be done. Not the full-blown benchmark testing and the full-blown RF survey, but a site survey to go out and show to your customer, here is a layout, get some floor plans, have an integrator go out, take some initial test readings. Sometimes this step is missed But oftentimes a customer, before they want to commit, especially when it's a big dollar amount, they just want to see a basic representation of what it's going to look like to the building. This is a step for the integrator, and this is an area where they're more than happy to take some floor plans, understanding where the market is and what type of venue and customer it is, and give that information back to you with a bill of materials and some floor plan layouts. Next, once that is determined, if the customer has said, okay, now I have a more realistic budgetary and I need to move forward, I need to get this put into our system, now starts the process of the initial design and bill of materials. At that stage in the game, if the customer is still moving forward, they recognize that it is going to cost them $500,000, $550,000. At that point, an RF site survey is completed. That RF site survey, there is a cost associated to that. That is very time intensive. There's a lot of engineering that's done behind that. It's very fancy, very expensive equipment that a technician shows up to your building, walks your entire floor, every 50 square feet, takes all the measurements for each frequency for each carrier that's going to be deployed, and that information gets loaded into IB-Wave. There is a cost associated to that, so don't be surprised when you get a quote and there is a cost from the integrator for that. Once that is completed, they're going to load that into IB-Wave, which is the software tool that the carriers want to see the propagation maps in, and they're going to complete the detailed design and revise that bill of material. At this stage in the game, this is where the facilities team of the customer and a contractor, ensuring that you're working with a contractor that knows this customer and knows this building is absolutely critical. They're going to know where you can run cable and where you can't run cable. And when you don't get that right, you cause redesigns at the very end, which can be very costly and time prohibitive to the customer. So it's really important to engage all the right resources throughout the entire process. After that has been completed, the updated design, the final design is completed, and then the statement of work is done. This is where the outline of all responsibilities through the entire process are identified for your customer, and they can really understand what stage each person plays and where they need to, where the responsibilities lie ultimately. This whole entire process from there, that can go anywhere from 1 month to several months, really depending on the urgency of the customer. At that point in time, once the customer is committed and moves forward, now is where the carrier approval portion comes in. This is the part where it can take longer. The fastest and easiest way to get that carrier approval, which you absolutely have to have before implementing the system, because you don't want to put in a $100,000 system, and that would be a low cost, that is a smaller system, and have a carrier say, you know what, it doesn't meet my standards, it's not up to my specs, I'm not putting it in, I'm not going to authorize it turning it on. That's the worst thing for your customer to hear. So the best thing to do is work with a tier 1 integrator who knows the carriers. Not only do they need to have the RF engineering portion, that's almost the easy portion, right? They can get that talent. However, the carrier piece, the relationships, knowing exactly what Verizon and AT&T want in this market, in these types of facilities, that's absolutely crucial. And only our tier 1 integrators have that type of knowledge. It's intangible. They can't buy it. You can't buy your way into the industry. You can't buy that type of relationship. So you need to work with these guys that have that, so that when that first go pass, when that first carrier approval package goes out, it gets approved as quickly as possible. Another critical component here is understanding what the carrier's requirements are so that your customer and your integrator can work together to make sure the most cost-effective system that's up to the carrier's approval standards will be going in for them. So at this stage in the game, the majority, so it's a 12-stage process, which 75% of it is actually run by the integrator, which is why it's absolutely critical to work with a good integrator. As we move to the next process, we're going to see the contractor. So what I find really fascinating about this is that the contractor, they have one portion of that 12-stage process. They do help in regards to the site survey and making sure that that antenna is put in the right place, that I can actually run fiber where I want to run fiber, and I can run coax where I want to run coax. But the installation, that is absolutely critical. Even though it's not the majority of the entire time-intensive process, if you don't get the installation right, you will absolutely you can cause short to very big delays within your projects. You can put cabling in incorrectly. It won't pass the PIM test. There are a lot of downfalls to not having a contractor who understands DAS systems, the complexities of HELIAX cable and the complexities of PIM to put that in correctly. So you want to absolutely work with somebody there. Even though it's a small portion here, it can be a huge problem within the systems. I think most recently I had heard that anywhere from 60 to 70% of problems can happen in the installation throughout the DAS process. So once that is completed, you're going to move back on and bring the integrator in to do this commissioning, to do all their black magic and fancy tuning, as I call it. And then from the commissioning, they're going to do their acceptance testing. And at that point, they're going to redo that RF survey. So now they can complete their package to the carrier to turn on the system. So they've got the initial RF survey, which showed the carrier, this is what your signal looks like in my building without a DAS. They have their IB wave design that shows, based on my design, here are the expectations. Here's how your signal is going to look afterwards. And once it's all done, they do another RF survey, which completes that package and shows the carrier that their design did what they said it was going to do. The carrier will review it, come out to the site, and they'll go ahead and turn it on. Now this process, from start to finish, can go anywhere from 3 months to 12 months, 2 years easily, depending on a lot of different variables. The customer's time, having the right parties, having the right integrators work on the designs, and then simply the carrier's response time within the market. So working with the right folks will make sure that that process can get expedited as soon as possible. So some additional portions of the implementation, we start with material procurement. This is an area where distribution really does play a large role in. So making sure that the equipment, the right equipment, is confirmed prior to arriving on site, making sure that you have the right amount of couplers, making sure that you have the right amount of jumpers. Jumpers have become a really big deal within our industry, particularly PIM-rated jumpers. You have to have the right stuff, you have to have the right connections and terminations, otherwise you can delay your project. And trying to find 100 jumpers in the last minute can be a very difficult thing to do. Meeting the current carrier's requirements, making sure that you're PIM-rated. Construction planning is absolutely critical, making sure that you're working with a contractor that can help you plan, understand the locations, understand where site access needs to be coordinated. Installation, we talked a little bit about the importance of working with the right contractor, making sure that they understand the difficulties with coax and PIM. And then commission and validating, making sure that the integrator is coming in, turning on the system, and making sure that it works correctly. So just some common installation problems are labeling, grounding. Here's a classic example of a kinked cable, which is something you don't want to see. This is really where the contractor can come in and make sure that it's done correctly. HELIAX is a very difficult cable to work with. It is incredibly sensitive for as hard as it is, and people don't know that, people don't understand that. So working with the right contractor will make sure that you don't have to re-pull cable. Having the right splitters and couplers, and making sure that the directional couplers are installed the right way is critical. And then PIM, making sure that it's terminated correctly and it's not being hung in an area where it's got metal poles or things of other type of equipment of that nature that can cause PIM issues. So what we've done at Annixter is we've actually created what we're considering our elite DAS network. We're taking the best of the best, be it the best integrators who have carrier coordination skills, who have IB wave, who have RF technical expertise, as well as the contractor space. We're ensuring that the contractors and the installers on these projects, we're making sure that they are certified on the cabling products, that they understand the PIM pieces, and also that they know how to install the systems at the head end as well as the IDF closets. Contractors really don't have growth initiatives to become a full-blown RF integrator. They're not going to do the design, but they want to make sure that when they're putting these systems in the building, that they're doing the best job they can possible. So what we've done is we've taken a network approach. We're just here to make sure that all the right players, all the right pieces, all the equipment, all the right OEMs show up at your customer's site so that you can have the best deployment possible.
Thank you, Carla.
Thanks.
Art, please go ahead.
There we go. The operations support. How many people? NUC, Network Operations Center. You've heard the term. How many people know exactly what a NOC is? All the screens, the telephone calls coming in, alarms popping up. Monitoring infrastructure can be anything from servers, switches, routers, DAS systems. That's what we're here to talk about today. I went to my first NOC in 1971 as an outside plant supervisor with Illinois Bell. I've been working in and around NOCs for over 40-some years now, 37 years of experience to forget because it's baggage, and about 7 years that actually applies. For iNOC, we provide NOC services. We're an outsourced NOC. We provide it for all types of networks, wireless, fiber, microwave, and even the cloud services. So what I want to talk about today and what I want to cover is what goes into the planning for operations support and specifically for DAS. We're going to use our 15 years of experience building and supporting services for DAS networks. And from our point of view, so many times we're brought in late. There's no budget. The support costs isn't that much left. So now all of a sudden they're trying to get by as quickly and easily as possible, and in the long run, it's a killer because we are responsible for maintaining and actually executing the service level agreements, the requirements of those, the business requirements. So when you're in there as a neutral host provider and selling the service to a carrier, they started talking about uptime. Yeah, we want 5 nines, forget that. 3 nines is probably more realistic. How much uptime are we going to have? How quickly do you respond to alarms? How quickly do you open tickets? How quickly do you resolve a problem? If dispatch is needed, how quickly do you need to be on site? That is what's built into a service level agreement typically. And the operations center is going to be the one that is challenged and tasked with maintaining those requirements. So the first thing that I'd recommend is bring in your NOC service, whether it's outsourced or internal. Bring those people in right up front when you're doing the proposals and make certain that it's covered at that time. And when you cover it, primarily it's the hardware that's going to determine most of the information that's made available to the NOC. There's going to be a host, it's connected to remotes. Maybe it's a gateway, they might call them nodes, whatever it is, you have that relationship on site. Underneath it, you have the power feeding it. Coming into it, you have the carrier connections, and I'm showing a black, a blue, and a red as being 3 different carriers on this one neutral host system. And up on top, you have a management network, a way to connect into that host or that gateway, connect into it and the other infrastructure using a separate path, a dedicated, it could be dial-up, it's probably a TDM circuit from the telco or whatever it is, it's a second path in, connects to some sort of management router, and now you connect into the gear. So the elements from a hardware perspective, you have a management connection coming in from the NOC, you have the carriers connecting into the host, that connects out to the nodes, and then everything is fed out to the handset or the whatever device they're carrying. When you're designing your network, put together at the very front end the ability to recognize when something fails and an alarm is thrown by the host, is there any way to identify it with a specific node, the host itself, a technology within that host, because those are the things that will be unique to each one of the carriers. There are a lot of things that can break in a network that don't affect all 3 carriers, if it's a 3-carrier system. So you need to keep those things in mind, and you need to keep those separated. From a management perspective, a NOC perspective, we want hardware that is easy to manage. It's critical. So that gear should be creating industry standard alarms. You know, we refer them to as SNMP traps. There's polling that goes on. There are a whole series of standards for the industry, and different hardware vendors execute those more effectively than others. Bring that into your initial consideration and make sure you have a solid set of alarms and messages coming out of that gear. And some sort of graphic user interface, the ability to go into the gear remotely and get a beautiful view of what's going on in the gear and maybe even bring up troubleshooting guides and things like that. Some of the gear puts that in there wonderfully, and it makes it a pleasure to support from a NOC perspective. And then finally, the one that almost always gets overlooked, and that's why I put it on the bottom so you can overlook it, the management network. I mentioned the fact that you have a connection that comes in from the outside world into that infrastructure. It's a separate path, and it's that way because things can break from a carrier perspective coming into the gear, and if you're riding with that information, you lose your view into the gear. So you want an external path into the gear. So now if 2 or 3 of the carriers go down, fiber cut, whatever it is, you still have a path, an external path into the gear. Unfortunately, that path can also break. And if that breaks, you lose all visibility and you don't know, was it a fiber cut, a power outage, everything is down, or is it simply a management hiccup and your frame relay circuit is down from whichever carrier provided it? So you really need a second path in, and that's always overlooked. Should be a dial-up or something like that, really simple, but a way to isolate your problems. So once you've built that monitoring solution down there in that bottom left and you have the infrastructure generating alarms and information, now you need, from a NOC perspective, and this is where the rubber really meets the road, how do you get all of those alarms into a single pane of glass? How do you put together the workflow management tools and tie in the databases and the communication networks? You need to integrate your trouble ticketing system, your communication systems. You need a configuration management database where all of the information is stored. The ability for the first level NOC team to be able to visualize the services, the network, and what's happening within that so they can quickly diagnose issues. And that's what we do. We've integrated all of the tools into one solution from a single NOC position. You can see everything coming in. It all is tied to management databases. Tickets are generated, and it all comes into that first level NOC team right there in the middle. And they're going to take that information and start taking action on it. And they're going to have a run book that tells them everything that they need to do. This really needs to be planned out, thought out, and delivered. And that run book starts with, this alarm means this, it affects that carrier, here are the steps to remediate it. Needs to be in the book. For notification, if this occurs and you open a ticket, this carrier needs to be notified in this fashion. And all updates need to occur every 2 hours or 4 hours or whatever it is thereafter, and here's who has to be notified. If you need access into the site, good Lord, be sure to give us the information when you set it up and all of those requirements on what it takes to get into a site and when you can do work. If you think it's a big deal when you're building the network, think about it 3 o'clock in the morning on a weekend when something is down and you've got to get in there and restore it because it's a healthcare facility with 24-hour coverage versus trying to take care of Circuit of Americas during an F1 race when everything is locked down and now you have to be right on top of it, people are on site. All of that gets built into that first level, into the run book. You know exactly what has to happen because that Tier 1 team, and that's probably one of the most expensive elements of the support solution. It's not 3 people with pagers. They're trained technicians. They know how to communicate with carriers because they're going to have to open tickets with carriers. They're going to have to update carriers, provide information to them, and they have to be able to do it to each carrier individually because you can't be telling one carrier what's happening in another carrier's network. All that has to be built into it. And then the ability to escalate, do your on-site dispatch, call out fiber repair teams, whatever is required, down to the third-person support team. And then ultimately, all of those databases have to be drawn together because you're going to, from your trouble ticketing system, you're going to identify what incidents brought down service, affected the uptime, which carriers were affected, and you're going to need to provide SLA reports at the end of the reporting period because the carriers are going to use that for settlements so they can reduce the cost of the neutral host system they're buying from you. It's just the way it works. So you need a well thought out and solid program to do this. So in summary, bring us in whoever is providing the NOC service. Bring them in up front. Make sure that the hardware supports the requirements for a neutral host, the reporting, everything that goes with it, all of your back-to-back agreements, they have to be tied in so that if you have a 4-hour response time or a 2-hour response time, time for alarms to come in, do the troubleshooting, determine somebody needs to be dispatched, get a hold of them, and give them drive time to get to the site with spares. All that has to be thought through. 24/7 NOC, it's not 3 people with pagers. You're at least 5 or 6 people deep. And they better be really good and know how to talk to the carriers. And then finally, a fully documented run book. And when you're planning this and putting the cost of it together, I would say that tier 1 piece right in the middle with the 5 people and the run books and the tools integration and all that, it's something you can do internally, or it's one of the natural ones to outsource to someone else because they can help you manage the risk and the cost.
Okay, well, thank you, Art. Well, you ran a couple minutes over, so we can take 1 or 2 questions, but after that, please feel free to come up to us, and we'll be happy to answer any questions. And the slides will also be available on the NEDAS website. Does anyone have any questions? Looks like you're all ready for lunch. All right, thank you very much. Shmee, you can get the sign in it. Perfect. Perfect. All right, that'll do the job.
That's great news. I didn't know.
So is that for the communication link between the term and
Oh, wow. Similar background. So you can tell get your cards. My daisy already. On the outside. The question is, you get by choose these buildings.
The nice thing is, one of the nice things in terms of tenant density, typically
By the way, long-term capital management. See what they had.
It took a while for it to.
You guys had great products too. Legacy.
I guess it's terms of this is we started to keep up the internet, and that's we worked for 6 hours. One of the guys came in.
That's a great background. It's great to meet you. And I just wanted to say thanks. I had no clue.
Well,
we got a great time.
Only from relays to.
Yeah, so the good news is we're new. So our management. So I just talked. I guess my we have an in-band data channel. We go quiet when we're turning the leakage. We can send data, so we have 1,150 servers. We were talking to our still have that inside
And that's in Chicago. Yeah.
Cool.
Yeah, I thought it was
It's a great place.
Good to meet you.
You got it.
Yeah, thanks for your time. I will,
Okay, so
we have any sort of, projects over the
Right now, I've been working with Bill and with Amit right now on more of a multiple strategic perspective. I haven't really gotten down into regional at this point. And I don't know what else is going on. Yep. I'm trying to figure out where is this going to money again? Well, to see opportunity for this council.
Right. Well, my hope is that they are in utter confusion and disarray for at least a year and a half. But no, they'll be, they're going to be a real powerhouse. Yeah, at least they'll have great reach.
Yeah.
I know myself and supporting them. Yeah, is going to be a process. It does a lot of really nice stuff for heading, but the leverages and that's nicely across space. We have products, media, global access products. We really think we should fire all the way.
Yeah, and I think it's, you see the Ericsson media dots and the wall of lamp sites, and again, certain buildings with a look at that, and in certain kind of it's fine.
So IME is deployed overseas, right?
Yeah.
And it's deployed well.
I think, yeah, it depends, and again, it depends on the market, is where it's focused, right? In Europe, where they sell a lot of that's almost not building, then it'll work fine. Where you start looking at the enterprise market now, where you've got this spider product. Now that's just a little against an area. So you gotta take this out. And then if you go around these 1,000 square foot, you're gonna be. Oh, you're at that roof? What do they bring for,
Spider scale. John Barnes there.
Nice.
No, I've heard of it.
He doesn't leave.
Oh, is that right? Yeah,
and you can use multiple operators. If you look at their 19-inch rack, half of them you want operators.
He's a good dude.
Yeah.
Other operators.
Yeah.
So it has a little bit of flexibility. It's a little bit better solution that's out there right now.
Yeah.
It's
So it's a multinational for small size.
Right now, I'll let you go.
Yeah,
I'll be up there in March.
We only see each other in Las Vegas and Germany.
Yeah, everything.
If you see her
this fast machine?
We're in Manhattan too, so you're in Boston, so
I live in South Florida, which is next to Framingham.
so I live in Providence and my business is in Spring,
Yeah, no, I'm down there quite a bit. Yeah, no, that's great. And what I think the best thing to do. Yeah. The best thing to do would be to get you in touch with them. What do you think about this?
No, I know, yeah.
I think we travel to Virginia.
I'll give you a jingle on the way up.
All our engineer.
All right, thanks. Bye.
See what they think about it.
Cool, yeah, I'd love to. We can do a webinar too if you want to do a quick NDA, and also, if you're at that point, you guys are interested, even if you just send us a power spec, we do power auto sensing AC also and DC with the other end. So
Yeah,
look,
she sounds so sweet. Oh, she sounds so. And I love you still. to your heart, straight to your heart. I can get to your heart. She said, 5 seconds in your heart, straight to your heart. I can get to your heart. to me, lost like when you were mine. You can take what you want from me, just don't offer me your time. Stay. Love can be long. Wanna know, it's true when you say in the satellite, but it seems as though we're breaking off. Victims of lost in translation, I'm glued to your station. You don't have to be flatlines, so pump it up. If I could just pick you up right now, then there is one thing that I would be preaching, but my heart has a chamber of trust for you. I wasn't good, even just too lost for you. Yeah, you're making promises, you're making promises. Ooh. Yeah, you're making promises, you're making promises. Ooh. Yeah, you're making promises, you're making promises. Ooh. Yeah, you're making promises, you're making promises. What am I supposed to say? An old love called yesterday. And she sounds so sweet. Oh, she sounds so. Yes.
All right, I'm going to just make sure these our afternoon session guys are all set. We'll get started in probably about 2 or 3 minutes, so stand by or sit by. All righty, so hopefully you got to lunch early and were able to eat something. If you're still hungry and you would still like something to eat, we did. The caterer unfortunately ran out of protein, so I am willing to buy you guys a sandwich if you guys are happy with that. And if you're hungry, just place an order up front with our registration team, and we'll get that taken care of for you within about 25 minutes. So just let us know. There'll be plenty of food and drinks for this afternoon. I guarantee that. So you got to stick around in order to see me follow through on my word to you. So without further ado, I'm going to introduce this awesome panel. Base station hoteling, micro solution deployments. So this panel here is going to be moderated by Jake Rossweiler, who's the COO of Sublime Wireless. Jake has more than 20 years of venture-backed business operations, engineering, sales, and business development experience within the wireless communications and IT industry. His wireless carrier experience includes various leadership roles at Sprint Nextel, AT&T, including Senior Director for the New York area and the Northeast Design Leader. He's worked with strategic investors, venture partners. He's funded, designed, launched, and operated networks for wireless operators, utilities, oil and gas companies throughout North and South America, Europe, Africa, and Asia. So without further ado, I give you Jake.
Good afternoon. Thank you for that introduction. Thank you for NEDAS for today's event, and thank you for Zenfi for sponsoring this panel. I'd like to introduce some of our panelists from right to left. We've got Ken Sandfield. He's the EVP of Solid. You have Ray LaChance, who's the President and CEO of Zenfi Networks. Joshua Broder, who's the CEO of Tilson. And you have Mark Parr, who's the president of Bandwidth Logic. The format that we're going to be using for this panel is a little bit of a Q&A. We're going to be light on slides. I have a couple in the very beginning that we're going to be going through. And towards the end, time permitting, we'll go to some questions. So, starting with the first question to the panel, what is your definition of base station hoteling and its importance to the wireless industry? Ken?
Hoteling, my view, is really the location of the RAN assets in one central location. So, you know, by putting all of the more expensive, more complicated assets in one location, you can service them, you can scale them better long term, and you can provision them long term. So it really is a central location, right, where that is all taking place, versus a distributed approach.
You have some slides you'd like to?
Yep. Want to stand up? Oh, I should have put that up earlier. So we're going to talk to you about micro solutions. We're going to talk to you about the city core, Cloud RAN, C-RAN, but really what drives how much capacity is needed on a pole. You know, what drives that capacity? Obviously, it's users. I get that. But really, what drives the capacity in terms of technology? You know, is it baseband processing? Is it the RF on the end? Obviously, it's all of it. But where are those RAN resources located? Are they located on the pole, like small cell, or are they located, you know, baseband unit with a radio head separate? You know, different topologies. What does future scalability mean? You know, we all talk about 5G. There's LTE, right? That's going to be coming up, right? So how could that play into it? How does that play in the outdoor areas? A lot of cities are deploying Wi-Fi, while LTE might end up being a part of that as well. Where is the silver bullet? So I produced a slide real quick. I apologize, it got a little messed up in the conversion, but if you follow the little yellow lines, I think you'll figure it out. So this is obviously focused on fiber, because I'm a fiber optic product electronics company, so we're focused on fiber. However, after the aggregation points to the right, there perfectly could be some great opportunities for microwave, millimeter wave type of applications as well. So I'm not trying to say that there aren't any other solutions. But here, most importantly, I'm trying to illustrate the three types of technologies. So today, and this can be considered a small cell as well, I guess, CPRI radio heads, where you have a baseband unit and a radio head. Those are a pair, and they're matched together. There's typically not a routing function. There's typically not a daisy chain function. And most of the time, it's considered a fiber cable, right? Typically, you know, those are going to be CPRI or OBSAI fed, and you're going to have several bands of MIMO capability, and you're going to put that on the pole. There's other ways. There is ways to daisy chain it using WDM optics, which I'm showing there. So there are ways to daisy chain CPRI, even though it's not part of the native spec, which allow you to put repetitive poles all in the same fiber strand for efficiency. Gigabit Ethernet small cells, essentially very similar in architecture, except the fact that you're distributing Ethernet, and there's no proprietary, there's no RF packets, if you will. It's all standardized Ethernet, right? Once again, you can daisy chain that using WDM optics as well. So that's another tool in the toolkit. Lastly, if you can see that on the bottom there, the next generation of DAS solutions are also going to provide an opportunity for some really neat applications to drive higher capacity and more bands and more RF at the dense urban deployment. So what I'm showing here is the ability to put CPRI across the DAS to a radio head. I'm also showing the technically that little box is supposed to go around both of those, showing the combination of baseband and radio, essentially Nino B at the front end of the system, driving the DAS remotes out there in one location. So basically the same as putting BBU and RHU together. But most importantly, we're mixing and matching CPRI and RF to aggregation points and out to remotes. So the main point I want to make here is, where do the radios go? Where do those assets go? You asked me the question about hoteling. Well, the reality is all these applications are taking advantage of hoteling, but they're not all taking advantage of having the expensive assets in the hotel on the left of that line. A lot of, like for example, the small cell has a lot of that processing being done on the pole, whereas more of the DAS has all of it being done at the hotel. And one would argue that the baseband radio head unit has kind of a split, capability as well. So my goal of this slide was to kind of just to remind everyone kind of the options that are available and how things are starting to flush out. The biggest difference in all of these is really that the DAS is still king on number of bands and total spectrum in terms of how much you can do on a pole in a very small space. However, there's other issues with DAS versus some of the other solutions. So anyways, hopefully that helps kind of explain some of the options and the way things can be done as we talk about the CRAN and Cloud RAN networks.
What is hoteling? Any other comments from the panel before we move on to the next question? Anything you'd like to add? So what is the importance? Why now? Why is this a relevant topic to the industry today?
Well, excuse me, I think it's part of the natural evolution in the mobile wireless space. Our goal in the future is to get as much mobile connectivity as close to the user as possible to increase capacity and increase bandwidth to end users. The way to do that is to densify the network. We see the base station hotel or the base station aggregation POPs that are geographically located near the antennas but not at the antennas as a very important component of this densification of the wireless network. So we envision a network with many hundreds of thousands, tens of thousands, or hundreds of thousands of antenna locations that aggregate at a point that has intelligence where you can have economies of scale operationally and economically that ultimately get aggregated back to an intelligent core of a mobile network. So it's a core building block for the future of mobile networks.
From a technology perspective, are there any key technologies that are enabling this to happen now?
So clearly, we need to look at the way the fiber networks that support the antennas today are architected. Today, you have the traditional model of a backhaul from a macro site or a small cell or from an aggregation point for outdoor or indoor DAS. Ultimately, the network requirements are driving the need for speed and low latency to reach those antennas. We just talk about the CIPRI protocol, which has requirements for 600 megabits up to 9.6 gigabits of bandwidth, and we're sub or multi-microsecond latency requirements. The only way to accomplish this is to have the base station as close to the antenna, the base station computing resource as close to the antenna as possible without being at the antenna. So we see this concept of front haul fiber and deployment of radio over fiber technologies as being an important piece, and it's going to require re-architecting of the fiber infrastructure that's out there today.
So sticking with front haul for a second, what mobile technologies can be supported on a front haul network if it would be deployed?
So I could speak to that. So what we're seeing in the field is front haul fiber networks, and those are fiber networks that provide connectivity from an endpoint and antenna somewhere back to some kind of processing technology or amplification technology back in a shared location prior to it being backhauled, are being used across a variety of technologies. We're seeing several flavors of small cells that operate independently as if they were discrete sites, but where the carrier still wants to share a common point of backhaul and not backhaul directly from the site. We're seeing small cell technologies that require control systems like small cell BBUs that are back at a hotel location so it can't quite stand on its own. And we're seeing lots and lots of DAS facilities. And I think what's exciting about this time is that the form factors of these nodes right out on the edge where the antennas are, is that the form factors are increasingly getting smaller. And one of the necessary outcomes of the form factor getting smaller is that more of the intelligence and processing and amplification are being pushed back to the point of demarcation between the front haul network and the backhaul network. And that's really where the idea of hoteling is so critical.
I guess, why is this such a big deal? There's tons of fiber out there today already. So what makes this different?
I get to answer. Well, I think really Ray can back me up on this. He's more the outside plant guru sitting on this panel. But when fiber optic systems are put in the ground, especially let's take Manhattan for example, they're really not point-to-point per se. They're ring topologies. The finances of putting that fiber in is based on a return on the model, how much they're going to get. A lot of lit services, managed services. So now we're not talking about lit and managed services. We're talking about essentially leasing dark fiber out for the most part in one aspect of a model. There could be a managed service model as well from, say, a neutral host or like a ZenFi. But it's really more of a hub and spoke type of architecture that you're going to start looking at. So you could utilize some of the fiber that's out there, but it's really, you kind of need to lay the fiber in the ground with the intent of having a hub and spoke architecture.
Right. Hey, let me follow on with that. I think that's absolutely right. I mean, we've had experience of putting up nearly 2,000 outdoor DAS nodes throughout the city using traditional techniques of laying big fiber optic cables and accessing them, bring them to light poles and street poles. And during that time, we saw that it's a very, building these networks the way they've been built in the past with these large looping rings and very sparse access to them is certainly not the recipe for supporting the dense networks of the future. If you look at Manhattan, it's got somewhere in the neighborhood of 3,400 intersections in New York, in Manhattan alone. Right, each one of those intersections ultimately should have an antenna someday, or multiple antenna locations. And to think of breaking into your cable every block all the way up Fifth Avenue using traditional fiber techniques just doesn't work. So the networks that are out there today are really not built for the amount of access and fragmentation that's caused by deploying these distributed antenna and small cell models.
I'd like to add to that. Let's define what densification is really going to mean. So for every site you see here in the city, imagine a 10-to-1 split. That is ultimately what's required to have any city, not just a big one like Manhattan or the city of New York. It's a 10-to-1 split. We've seen that in Asia when they went through this next step of densification. They took their, for every one site, they had to add 10 more. So they had to create aggregation points out of those existing sites or create new ones. So now just imagine how fast you're going to start burning through fiber if every link is a point-to-point. And I mean, you're going to be using every tool in the toolkit to get connectivity. I mean, it's quite substantial.
Yeah, I think just to add one last point, and then Ray can correct me again. So instead of necessarily, I called it a hub and spoke. I mean, it could be a backbone run up an avenue, but it's when you're going down the streets that almost like an Ethernet, you're having drops down streets, pull it back on a common backbone. So it's still a hub and spoke graphically on paper, but it almost looks like an Ethernet essentially.
That's right. So thinking about the fiber and the outside plant, there's this other concept of the hotel. What is the hotel? How many carriers need to be in a hotel? And what can a hotel support?
That varies. The real model is it depends on how sophisticated you are in building out a hotel. So the ultimate cost savings here, just from my experience, I'll use rough numbers. I've built a lot of DAS networks in New York City alone. And typically you're going into Class A office space, even trying to find space in the basement of a Class A office building, it's not easy. In some cases, I built 30 Rockefeller Plaza some 10 years ago. Getting power in that building was a challenge because of how much the studio draws already. So now you have to look at that equation and say now you're not taking up Class A office space. You're aggregating multiple base stations together in one location. You're also minimizing not only the carrier's insurance requirements because they might not have to deal with the DAS anymore. That might be the enterprise or a neutral host or other maintenance provider. Gaining access in buildings in Manhattan is a challenge. So now you're not accessing, 3,000 buildings, maybe you're accessing 20 or 30 base station hotels, meaning the carriers. Power aggregation, cooling, your backhaul alone is now, instead of having, let's say a gig access at every one of these buildings, you can now put 10 gig and bigger access backhaul transports together. So it's hard to give you a hard, firm number, but it would typically, to me, start at the range of at least having 5 distributed antenna systems or 5 base stations. So no matter the mix or match of carriers, to kind of cost justify building out that plant. And when you build the plant out, you might have, let's say you get 10,000 square feet and you get the first 2,000 with first right of refusal for the next part, and you only create hot and cold aisles in that one section, and you keep building that plant out as needed. You don't just go build out some big giant data center with Liebert units and et cetera, good plug for Liebert.
Making it scalable.
You scale it.
And we're finding that as we deploy in different kinds of environments, what we call a hotel varies greatly. So in some of the dense urban areas within what we would traditionally see as CLEC hotel kind of data centers or central offices, we see really big base station hotels coming in at the kind of multiples that we just talked about. But as we get more into the neighborhoods and the suburbs of the metro areas, we have what I'll call the base station in-law apartment. And the base station in-law apartment is typically a macro site. And at that macro site, which used to be a pretty full shelter, but as technology has progressed, has gotten to be an increasingly empty shelter, we're adding racks back to have very small DAS head ends or just additional racks of BBUs and controllers and additional radios to control much smaller networks. And sometimes those networks are in the 3 to 5 DAS nodes or 3 to 5 RRUs or 3 to 5 small cells. And because those communities are lower density, the necessary deployment is lower density, but some of these base station hotels are, in fact, co-locations on existing head ends, leveraging the existing backhaul without a backhaul upgrade.
With the base station hotel, is there a risk of putting all your eggs in one basket? What happens if one of them goes down? Isn't that a large area that could be without service?
It could be, but could consider every major financial trading entity in the city does the same thing. They're not all at their offices. It's not just J.P. Morgan has their data center, Goldman has their data center, et cetera, et cetera. They're all at least in 111 8th Avenue. They're probably in 60 Hudson Street. They may be in 32 A of A. So if something happens, they would take out a significant swath of trading, quite frankly, millions of dollars a second, right? But that's where you build fortified base station hotels, just like a data center, a little bit different model where you're not charging like a data center. But a lot of other things can happen that can take out, in this modern day and age, without getting into the conversation, but there's a lot of things that can take out a lot. Built wisely, you can get something that's fortified, that's going to have a high degree of reliability, call it 5 nines, and have a backup plan to that as well.
I'd like to add to that. Clearly, there's a resiliency problem if you're going to home multiple, former macro sites, small cells, DAS, whatever, back to these aggregation points. It has to be built to a higher standard than the traditional cell sites are built today for resiliency. It may require, a better battery backup system, generator system, better cooling, higher reliability. That said, using today's model for the wireless space, and having come from the optical networking space and seeing how enterprises and banks do the resiliency, there's a world of difference. The amount of resiliency that goes into a banking network is significantly greater than what happens in the wireless space. But what I expect to happen as the technologies develop and mature for the connectivity to the cell sites, and the cell sites become more intelligent, and we move from this consolidation to this concept of a cloud RAN model, I expect that we can build resiliency into the network just like we build into banking networks today, right? We go with optical path protection or other link layer protections, all the way to higher stack protections. So ultimately, when CIPRI's delivered over Ethernet circuits instead of over a native physical link, those types of advancements in the technology will lead towards better resiliency in the network and less of your eggs in one basket.
And I might add, just to reinforce what Ray is talking about, I think as we're in the more fragile transition time to implementing more robust topologies and implementing data center level quality of service in our resiliency. In the short term, these densification networks are largely offloading data, and they're augmenting existing macro sites that will still provide some level of call completion, the level of call completion we have today in the service of public safety. So I think in the short term, I think what's really at risk is our ability to data offload and do the things we enjoy, but the ability to complete a 911 call, at least in the years while we're headed to a more virtualized processing space in clouds that are more resilient, is largely going to be dependent on good voice call completion until we're in a better place from a resiliency standpoint.
That's a great point.
You mentioned the term Cloud RAN. Another term that's often used is CRAN. And sometimes CRAN is used as centralized RAN, Cloud RAN. Could you kind of untwist that and distinguish what those might be and how they may be different?
Well, the reality is ultimately they mean the same thing. Like I said up here, where you're putting your assets. But the reality is it's really where are you doing your baseband processing. So, and how are you doing that, right? So right now we're talking about specific boxes that go into the hotel and that do that baseband processing and then put it in the CIPRI packets or proprietary packets and get it out to a radio, right? Eventually, the cloud will really become a cloud. What do we determine? A cloud today, processing cloud, is just a bunch of racks of computers. And in the not too distant future, all the equipment that we're talking about putting in the cloud will just be that. It will just be a racks of CPUs that do all that call processing at that location. Ultimately, in a perfect world, the stuff that goes on the pole is as light and as low in complexity as possible. Things that fail, things that require upgrades, things that you have to touch. Think about if you did a 10-to-1 split upgrade in Manhattan and you had to go once a year and had to service every one of those. You don't want to have to touch them anymore. So the goal is to put as much of the stuff that you need to change or potentially repair if it fails in a location where you have access and you can touch to it. So ultimately, I believe they mean the same thing essentially, but from a cloud perspective, it refers to where that processing is being done. It's hosted,
So looking at base station hoteling, there's potentially a lot of stakeholders that can benefit from this. So as you kind of look to the future and the potential of base station hoteling being deployed in a micro solution, tell me a little bit about how the stakeholders, whether it be the carriers, municipalities, the end users, the landlords, could benefit. What are the benefits this brings to them?
I think one of there's a couple obvious benefits, right? The economies of scale that you get for capital deployment and the economies of scale you get operationally are fairly obvious. And how do they apply to a landlord? Mark mentioned 30 Rock, and it was hard finding space to put the head end. It was hard to find power. Well, the objective here with the base station hotel model or this aggregation point is to find a cost-effective space that can be conditioned to a point that it provides the reliability that you're and the access you're looking for, and then bring multiple sites in. And rather than having to solve that problem at 30 Rock and across the street at the other Rock Center buildings, bring those in-building DAS systems back to a central aggregation point and share in the economies of the CapEx for the base station, the CapEx for the cooling, and the power systems that are put into place. And then operationally, share on the backhaul. And, as Mark said, a 10 gig backhaul comes into the base station hotel rather than a gig or 100 meg that would have been distributed out. Share in the OpEx for sparing and the ability to dispatch your text to a single location to work on the smart gear that Ken mentioned. And so I think there's economies of scale that are obvious, with the financial from a financial perspective as well as an OpEx perspective.
And I think the idea of hoteling is inextricably linked to making the form factor of the remote nodes smaller. So as we seek to put these things more in the public way, out on utility poles, in increasingly high levels of finish, in office spaces, in really cluttered public shared utility infrastructure environments, necessarily we have to shift processing and other supporting technology back to a central location. And so I think not only does that allow us to get closer to our customers and put nodes down into the nooks and crannies, but it also allows the carriers and owners to focus their scarce CapEx resources on the very difficult work of getting into those nooks and crannies, which can be really challenging places from a real estate and an installation perspective, and hopefully be done with that real estate and installation job and be able to surf behind that with upgrades in the hotel for years to come.
Yeah, and just to add to that is, we're all obviously here because of the proliferation of wireless, right? You know, I'm working on an opportunity, we've got a hotel secured, and the problem is, for the hotel is, it's 20-something stories, and it doesn't deserve a full-blown 3-sector base station, right?
Mm-hmm.
So do we just avoid those people going to that hotel? The hotel owner doesn't want to see that. They're like, my clients are going to want to use their cell phone. You know, excuse me, Wi-Fi, that's great. Maybe that gets prolific, or as prolific as the Wi-Fi people want it to be, which I believe it will also, but it'll be prolific right alongside with commercial mobile radio service. Now we could take that site that really only merits one sector off a 3-sector base station, and I could serve it off of one sector at a base station hotel, not spend $250,000 to fit out a head end. Again, it's not Class A office space, but it's a Class A building. It's a Midtown Manhattan hotel. I just solved the problem for that owner.
Right. And let's remember that it's still a fairly new concept. Not having a centralized CRAN and a remote radio head, that's not new. It's being done quite substantially. But the concept of a hotel serving in-building DAS, lots of in-building DAS systems, and there's also the concept of sharing, right? For the most part, carriers don't have a problem sharing on a DAS, but when you talk about an outdoor pole, they still don't like to share. And that's a concept that's going to, you know, it is economies of scale, right? It's like any other colo macro site, but the reality is when it comes to small poles, smaller type things, street furniture, if you will, the reality is they haven't figured out, you know, how to share. And the reason they haven't is because the small cells and things that are being deployed are single operator. So they're really cute and really sexy, and you put them on a pole and you can kind of not see them if you squint. and you know what, it's all done. It's like, yeah, that's great, but that's only one operator and he just took up a whole pole. And how many poles are there on a street, right? And that is significant. That's a technology barrier. It's a kind of a mind share of how people feel like they need to go about it. But when we start the large scale deployments, you know, like the guys here have been talking about, those are where the issues are going to be huge, because we can't afford to hang 4 boxes on a pole, and we definitely don't want to put 4 pieces of fiber to that pole either. There's no need for that. So there's going to have to be some colo. There's going to have to be some sharing of fiber resources. There's going to have to be some sharing of resources on the pole, and that is, I think, a big thing that is yet to really happen in a big way, like it is for DAS and other things.
So, taking what you just said, you know, talking a little bit about concepts, can we turn this into some reality, some real examples of why this is exciting for your company, each of you, and examples where you've worked on these projects that were able to leverage this type of an ecosystem, although it may be still emerging. Do you have examples where you could cite where this has been something successful for you?
I'll start with that. So most of our experiences come from Asia, who's done most things first before they actually happen here. We have the largest centralized Cloud RAN deployment in the world, in Gangnam and in the surrounding areas in Seoul. And now these are front haul CPRI fed radio heads. They're not small cells, they're not Ethernet, anything like that. They're true CPRI fed, but they totally gutted the existing fiber network to build a whole new ring and star topology in order to accommodate the scalability of these networks, and as well as future space on the poles. And they're poised for any new technology that comes. Even if they got rid of the CPRI and went to Ethernet, or even if they got rid of some of the Ethernet or CPRI and went to DAS, their network will accommodate anything. And that's really what we're going to have to do in this country as well, because the reality is it's not going to be one size fits all. There's going to be some places where fiber is needed, some places where millimeter is going to take place. But the reality is all those things will be required in order to make it happen. We've already seen, you know, any of you travel to Asia, you'll be blown away by the data speeds and the coverage. They have both. Coverage and data speeds, you know. And you come back here and you're like, oh my gosh, you know, I got 1 bar, you know, of nothing here, you know. And you're happy, you know, I got LTE, I got 1 bar. And why is that? It's because they've basically bit the bullet, all right? On one of my slides I put, what's a silver bullet? There is none. You know, technology can make up for a bunch of gaps, and there's a lot of cool stuff coming, you know, that people make. But the reality is that at some point you got to build a topology that you can scale. You know, whether it's LTE or whether it's 5G or whatever is coming, you got to have a system where that when that year comes, rather than completely rebuild your network again, you're just changing boxes. Everyone knows we're forever in this industry going to be changing out cards. And like you were talking about, you know, what used to fill up a whole shelter full of TDMA radios or even CDMA radios is now one little rack of stuff,
Tell
right?
them what you really mean. There's no such thing as future-proof.
There isn't future-proof, but yeah, you got, you know, but now all these shelters are like, so in Asia, for example, they had shelters. They had the same situation. What did they do? They turned those shelters into huge fiber aggregation points. They're like, well, hell, we got this beautiful building. It's air-conditioned. It's got halon. It's got all these great things. Let's just put a big, gigantic fiber switching plant system in here and create a very robust fiber network. So there's a lot of opportunities. We just got to, you know, bite the bullet on the table.
Other examples?
Well,
go ahead.
Well, I mean, I could give Ray's example for him. He's probably put more fiber in the ground and more units on poles throughout the city. It's a similar architecture, right? I guess what he said before is they've learned from their ways of how to more efficiently lay fiber in the ground. I don't know how many years it is now, maybe 10, 12 years ago, I was with a company that founded Transit Wireless doing the New York City subway, and this was the core of our architecture. It's base station hotels being built around the city as we speak. There's some up and running right now. They're running fiber through the streets on a hub and spoke architecture going down into the subway network. We had the opportunity to put that fiber in the subway tunnels, which was basically MTA right-of-way, which is a state entity. You know, I opted to keep it out of there because we wanted to be able to play in the field and actually feed buildings. And it took me years, but I kept telling carriers, base station hotels, until one finally came to me 2 years ago and said, hey, can I use this base station hotel to feed other buildings I'm in? Yes, and it's a working model.
There you go.
Yep. Yeah.
Right here.
We've primarily deployed pole-mounted nodes, and the carrier's willingness to hotel either in the in-law apartment style at an existing macro or at a dedicated, more sophisticated, high-density hotel has really enabled us to focus on getting out onto the utility pole lines and doing pole licensing and installation. And what's really fun about it is that once the carrier's made a decision that they're willing to hotel the facility, it allows us in the field to go think about what the right technology is to solve the problem in that particular area. And we've talked about all those technologies already, pushing RRHs out in kind of a CRAN topology, in ODAS facilities, and various flavors of independent or semi-quasi-independent small cells, all sharing common backhaul. So, our real-world success story this year is being able to deploy 1,000 of these and having the hotel be a non-issue. The hotel is taken for granted. The carriers are doing it. They're happy with it. And our focus really is around getting the nodes out into the nooks and crannies and being as close to the customers as we can.
Sure. Let me just throw out one last comment. I had an epiphany about this about 4 years ago, 5 years ago. We had just sold our company, Lexit, that was in the fiber asset business and construction business. And from 2007 through 2010, we put up approximately 1,600 or 1,700 outdoor DAS nodes. When we were building those nodes, we were bringing them back to base station hotels because that's what you had to do with outdoor DAS. There's no other place, right? So at that point, we had sold the fiber business. We were thinking about what we wanted to do in the future. started getting excited about mobile growth and all the opportunities out there. And then I started looking at the infrastructure that was supporting the mobile world today. Besides, you know, we learned a little about DAS by doing those nodes. We looked at macro sites. We looked at the concept of small cell, and we had, in fact, we put up about 100, 150 or so small cells. And we started to realize that this concept for base station hoteling made sense when we looked at opportunities coming to us for in-building systems. And every in-building system had a riser, a fiber riser, had remotes on floors, had an aggregation point in the building, which is great, but it also had a base station in the building. Then next door, we'd get a request for the building a few doors down. And guess what? It had the same base station aggregation point. Then we'd see all these in-building requests, and I was thinking, well, for outdoor DAS, when we put it on the 50th floor, when we put it on 34th and 5th, we had a remote there, and we'd fiber back to the aggregation point, and it connected to a base station. What's the difference if it's the 50th floor of an office building and the 34th floor of an office building? So I saw that, and then we started looking at macro sites, and I saw you see all this equipment on macro sites, and there's about 2,000 macro sites in Manhattan today, and every one of those has all this equipment on the roof. And I'm thinking, why is that base station there? That doesn't need to be there. So if we have this tenfold increase in sites, and I think it's going to be even bigger than that in New York City, it's probably going to be 100,000 antenna locations in the city of New York. This is the only way to do it, is to follow this model of aggregating all the intelligence of the mobile wireless network, move it closer to the core, put the low-cost assets out on the edge, and support it this way. So from my perspective, as a fiber guy, certainly not in the class with these wireless guys, and nowhere near their experience, it just doesn't make sense the way you guys had built these networks in the past.
Well, it's really an exciting time to be thinking about doing this cost effectively, because today, the equipment that's going into the base station hotels, most of it will inevitably be virtualized. But the necessity to provide fiber out to these antenna endpoints will exist after the virtualization moment happens. In fact, it'll be more important as that loop is extended from the antenna all the way back to some cloud computing facility. And so today we're calling it a base station hotel, but it will essentially become an aggregation point. And the point of demarcation between what today we're referring to as the front haul network in a transitional environment and the back haul network will converge. And what will be left in the wake of these base station hotels will be places where we can get fiber from existing backhaul networks out to the sites, and essentially we're building the backhaul networks of tomorrow and our front haul networks of today in anticipation of this virtualization.
Well, thank you. I'd like to take some time to open it up to the audience for any questions they'd have for the panel.
Excellent.
No
digesting lunch, perhaps.
You got nothing?
We have one over here, okay, hold on.
How you doing? Jordan Fry from Snyder & Snyder. My question is about how many square feet does a base station hotel take up, and what type of properties do you target when you look to find a base station hotel?
Why ask me?
It depends, I think.
It depends.
There you go. Jeff is out there laughing somewhere, and Carla. It really depends. The 30 Rockefeller Center is probably my life nightmare at base station or head ends, whereas we had to work really hard with the carriers to slim down their gear. We got it all done, and about 6 months later, GE said they were selling that floor, so we had to move the head end. We moved the head end to the 7th floor right down the hall from the NBC commissary, and Jimmy Fallon got his own show, and he said, I want the 7th floor by the commissary, move your head end. And it's been moved 3 times, by the way. But in one case, we had probably about 700 square feet. In another case, the first case was actually probably about 400 square feet. I always use around 600 square feet as a good number, and it's growing. It's kind of growing and it's shrinking. It's growing because we're getting more bands deployed. You know, we're going to have 600 megahertz auctions hopefully someday, and other bands are going to keep coming, but technology is shrinking as well. You know, one of the biggest things that I've been pushing for years is You know, a laser really like 0 dBm. For those who non-technical people, that's 1 milliwatt. And that's all things combined onto one of Solid's lasers, for example. All those technologies, you just attenuate them down until you get down to that low level. But carriers are still handing us base stations that are putting out 40, 50 watts, and we don't need 40, 50 watts. We just attenuate it, but then we're providing power for that, cooling for that. So you're gonna see that's a good question, but so in today's day and age, I say 600 feet that would be in one building. That becomes more efficient and probably gets down to about 350, 400 feet in a base station hotel because you're sharing facilities. And again, it's going to start getting smaller as we start getting away from this amplifier mentality at the base station. We get more into IP technology and more of I'll call it a traditional CRAN type of smart networks.
Yeah, and to elaborate on that for a minute, one of our favorite things to do with small cells is to use them at a base station hotel downstream of a DAS system so we don't have to attenuate radios. If you're going to amplify anyway, you might as well start with a really small radio. So we're building an ODAS, a pole-mounted ODAS system in a small city, about 150,000 people kind of size city, maybe 100 remote pole-mounted nodes. And all of the ODAS head-end equipment and the attendant banks of small cells that'll inject RF into that ODAS are probably 8 racks. Rough size for 100 remote nodes.
For a true, hotel colo that serves lots of buildings or poles or what have you, I would use more the analogy of you building a data center, right? More than square footage. So with a data center, you need cooling, and you need power, and you need fiber. And so if that's not already, if you can't figure out how to make that work, then that building is probably no good, regardless of how many square foot you have. It has to be secure and not waterproof, hopefully.
It's nice if you can co-locate these facilities with a pre-existing telecom co-location or data center use. The idea of turning raw space into a hotel is something we really try and avoid unless geographically we just don't have a choice.
Or the data center's expensive.
Thank you.
Right.
Other questions?
No, it doesn't look like it. Yes, we do.
Hi, Steve with the Mer Group. Can you make some reference about options for in-building DAS for residential, high-rise residential, of course?
So I'll take in-building DAS. So the high-rise residential has been really a difficult one for many, many years. And I think what's going to be required for those type of facilities is really the next generation of hardware. So whether it's a small cell solution that just gets on the Ethernet, or whether it's a DAS with basically small cells at the front end, it has to ultimately be a solution that the enterprise can deploy cost effectively without having to wait for the carrier to fund anything. As long as a carrier has to be asked for permission to buy a box, the reality is you're not going to get it. If it's a big building and every carrier wants to be in there, you're not going to have any problem. It's the other 70% of the buildings in the United States that carriers don't really care about because they're just not optimally for their ROI. It just doesn't work out. So if the enterprise can buy all the equipment to make the thing work, and the carrier says, "Yeah, I'll sign off, and you can make it work," then we'd see a lot more deployments, in those type of environments. And then, of course, there's costs associated with it. So, I mean, that's my view on the high-rise, residential.
I'll add on to that. Again, this concept of base station hoteling helps that model because we're eliminating that cost of that space in that one high-rise, and maybe it's 20-story, 40-story, but it's eliminating that cost. And you're also going to see something else happen in the future. It's going to be a little tricky with 911 regulation, but right now there's no real in-building 911 regulation. But imagine if you can, that you could take that capacity from 9 a.m. or 8 a.m. to 6 p.m. when nobody's in the residential building, they're all in their office, right? So you could take that same base station resource at the hotel and migrate it. Doesn't have to be to whatever building you're going to, but you get the point. You migrate that. So now you've got a better efficiency on your small cell or what have you. I think the other thing here is going to be, as Ken said, is the drivers, not only from technology, but it's really going to be from tenants. You know, I was just telling this story earlier today. I went to go help some guy do an assessment of his building to get a certificate of occupancy. It's got to meet fire code. The radio's got to work in the building, right? And I looked at him, I said, have you considered putting, again, this is a big residential building on the other side of the Hudson. I said, have you considered putting a DAS in here or something? And he goes, no, why? I said, because there's no coverage in here. If I were to come, and this is a brand new build, if I were to walk up to this building and look at my phone, I'd say thanks, but no thanks. And I think you're going to start seeing that happen. We're talking with REITs that are starting to realize Class A office space, residential buildings. It's because, again, we're prolific. Somebody's going to pay for it. Might as well put it as an underlying bill in the lease, you know, or in the buy of the building, but it's going to start happening. And again, this model that we've been talking about helps that move forward.
Well, to the panel, I think we're out of time. So to the panel, thank you very much for the presentation. Thank you to NEDAS for hosting us, and thank you to Zenfire, sponsor.
Thanks. Good job, Zach.
Thank you.
Great.
Thanks very much.
That's great.
Yeah, thanks.
Good job.
That was a good panel. That was fun.
Hey,
That was good
thanks.
stuff.
Yeah.
Thank you, guys. So, how many people are here are salespeople? Raise your hand if you're in sales. Have you thought about contacting this venue for a DAS system? Wi-Fi here is great, but cell coverage not so good. Right candidate for you. Hey, I bring you leads and opportunities. That's what this event is all about. So we do have a coffee break built into the schedule, but what we've done was the coffee break will be between 3 and 4 o'clock at your leisure, so you don't have to feel like you have to rush back in and out. So you're welcome to sit back and relax. We're probably going to just jump right into our next panel, and we'll keep the program going. So if you want to, like I said, you know, we're all friends and family here, so feel free to get up and take calls and do what you need to do. But we're going to jump right in. Give me 2 minutes just to make sure that they're all set, and I'll come right back and do some introductions. All righty, folks. We're going to get started with our next panel here. Third-party validation for DAS systems, an inside or outside job? So this could be an interesting discussion. This particular panel is sponsored by VCOM, and Dominic Valleco, who is the president of VCOM, will be leading the discussion here. He's a 34-year veteran of the telecom industry. As VCOM's founder and president, he's led the organization from 2 employees to more than 50, with 2 main offices on the East Coast. He's a qualified expert witness in telecom engineering throughout New Jersey, New York, Pennsylvania, Delaware, and Michigan, and he's also testified in federal court on behalf of the FCC and U.S. Department of Justice in 2 high-profile cases. I guess that'll be a conversation starter for later when we're having drinks with Dominic,
Right.
I guess. So without further ado, there you go. There's Dominic.
Thank you, Alyssa. As you had mentioned, and from your discussion earlier this morning when you were talking about the time frame of wireless, and as you mentioned, I've been in the industry for 34 years. In '81, I was actually working on some of the original FCC applications. So I'm only 25 like you, but. All right, good afternoon. I have the distinct pleasure of introducing, not only working with these 2 gentlemen, but of introducing these 2 gentlemen for our panel today. The panel that we have today, what we're going to do is really have a sort of a roundtable discussion and talk about some of the issues that they've seen, I've seen in third-party validation of DAS networks. Our first guest here is Nathan Cornish. He's the Director of RF Engineering for Transit Wireless. He's the leader of the RF Engineering Department. He manages the commissioning of all wireless carriers for the network. He oversees the RF design development, works with Transit Wireless's wireless customers to interface into the DAS systems. Partners with all departments. He ensures the RF system not only meets the carrier technology and cost efficiency requirements, but ensures the system operates with the highest availability for the entirety of the system's 20-year contract. Excuse me, Mr. Cornish previously held the position of design engineering team leader with Broadcast Australia for 5 years before being promoted to RF engineering manager within Transit Wireless. He served as the lead engineer for the multi-million-dollar digital radio services synchronized rollout, that's a mouthful, synchronized rollout across 5 capital cities with a focus on bid, design, implementation, and commissioning. Nathan earned his Bachelor of Engineering in Telecommunications Engineering with first-class honors and his Bachelor of Business in Finance with distinction from the University of Technology in Broadway, NSW.
New South Wales.
New South Wales, in Australia. Additionally, he was honored with the UTS Engineering Dean's List for outstanding academic results from 2002 to 2005. He received the nomination for Engineers Australia 2009 Young Engineer of the Year Award. Congratulations. And also with me, I have David Evans. He's the New York City area manager of DAS for AT&T. David is a seasoned and successful RF manager with over 15 years of experience leading complex technical projects, developing strategic and creative engineering solutions, and designing and improving wireless networks. At AT&T, he designed and delivered many high-profile DAS projects in New York, including MetLife Stadium for the 2014 Super Bowl, the Billie Jean King Tennis Center, the GM Building, Penn Station, Waldorf Astoria Hotel, and One World Financial Center. David has his BSEE and MSEE from New York University Polytech School of Engineering, and he's a registered professional engineer in several states. So with that, what I'd like to do is move on, if we could, a little bit here. Nathan, let's talk a little bit about transit, and if you can give us a little bit of an overview. Transit Wireless is probably one of the largest DAS systems in the world. It's complicated, it's a harsh environment. And then on top of that, as we were talking backstage, many of the things that we've talked about in today's panels, Wi-Fi and sort of the convergence, if you will.
Public safety.
Public safety, that's right. We've got the base station hotels I mean, you guys had base station hotels from the get-go, basically. Maybe you could talk a little bit about transit and the underground, just some of those things.
Right, so Transit Wireless, if you're not obviously heard of us, is the company that owns and operates the wireless and Wi-Fi infrastructure in the New York City subway. Now, the New York City subway, as you're all very much aware of it, us, even an Australian knows about it, is more than 100 years old. So it was never designed for Wi-Fi or wireless services. So it's obviously been a bit of a black hole for all the carriers for a significant length of time. So we've got that contract as a neutral host provider to build out these subways. And there are 279 subways, and as you can see on the board, we've broken it into a number of different phases, and we're currently rolling through our third phase and almost into our fourth phase. So this is kind of an interesting DAS system. It's not one building, it's essentially one building split over an entire city. So beyond that, there's a significant amount of infrastructure behind it. But also from a traffic standpoint, it's growing and growing. So when the build out started, it was less than 2 billion riders a year. Now we're seeing from last year, it's up to 2.6 billion riders, and it continues to grow.
We talked about how some of the concepts earlier, the Wi-Fi and that type of thing. Your system, and let me move forward here. On your system overview, we've got a system overview slide, but one of the things here is we talked about Wi-Fi, but maybe you could talk a little bit about the architecture, but also Wi-Fi. The other thing is relative to, and we talked about this before, you sort of have two masters almost, in that you've got the MTA, and while we've talked, some of the other guests here have talked about in building and dealing with the owners of the buildings, and while dealing with the owners of the buildings may be somewhat onerous,
right,
I can't imagine it compares to dealing with the MTA and the policies and the procedures and the safety and that type of thing. So, but we've got Wi-Fi there, we've got commercial carriers, we've got the MTA's 4.9 system as well. So maybe you could talk a little bit about that.
Yeah, so originally, and up on the board gives you a bit of an overview of the system. It's a sort of a layered network, similar to the previous discussions. We have a base station hotel facility that leads into an outside plant fiber network and then into the stations itself. But the MTA itself was originally just, a co-revenue share with us, but now the MTA has actually moved into being one of our carriers as well. So we provide the cellular services for the carriers, and they're all building out their networks to meet that. We provide a public safety network as well in a 4.9 network. So we kind of have two SLA requirements. One is obviously to the carriers themselves for their network, but we also have an agreement with the MTA for their 4.9 Wi-Fi network.
And that's where we're talking about here. We're talking about the parallel system. The parallel systems are really the 4.9 and the Wi-Fi in parallel with the wireless carriers at that point as well. So
right.
The one question is what challenges do you have with that?
Yeah, look, someone mentioned in a previous discussion that the convergence of Wi-Fi and cellular services. So what we did as a step to reduce the amount of infrastructure in the station, which despite it being, some would say, quite an ugly system, each to their own, the MTA spends a lot of time trying to make these stations less cluttered. So we wanted to get Wi-Fi in there because it was an emerging technology. So what we did was we paralleled the two systems together. So we essentially have coax and fiber running side by side, and then we have a combined box that sits there and provides both cellular, Wi-Fi, and 4.9. So from the MPA's perspective, they're getting around the fact that we're only putting one box in the ceiling, but we're actually providing three services. So that box itself, one of the strong components of that box is the subway is a harsh environment. It's considered an outdoor environment. So the boxes that go into the station need to be outdoor rated, both in temperature and in ingress, because when I mentioned the subway, they try to keep it clean and tidy. They literally have crews of people who come through with high pressure hoses and wash the entire station down. So we need to be able to protect against that, as well as the extreme heat that I'm sure you all complain about in about 3 months' time.
Let's switch gears here for a second. This is a slide that we've got with the Transit Wireless goes through with their design approval for carriers. But Dave, maybe you could talk about this a little bit here, because obviously you're involved with this from the other side of that fence, from Nathan. So here he's got a process where he goes through and he's got various bands that are out there as part of the system, some of which you occupy, some of which you don't. How does this vary from, say, some of the buildings and some of the other big venues that you've talked about? What are some of the similarities and what are some of the differences and relative to the design approval process?
So AT&T is a tenant on the system, and we do have some input as to what the design looks like. And ultimately, the design has to meet our needs, our requirements. The question was, how is it different from some of the buildings or other venues that we design? All of these stations are underground, so we don't have to deal with macro penetration into the stations in the same way we would have to deal with that in an office building.
The ingress and egress problem.
We do have ingress and egress.
It's different though.
It's different. So in an office building on the 10th floor,
got
we would have to
blown in the
compete.
windows.
We'd have to have a system that can compete with macro penetration, and we have to ensure that we're able to do that successfully. The design review process would be pretty much the same. So we would look at something, well, we would get something like this from Nathan. This would be typical to show us what kind of signal levels that we can expect from the antenna system under consideration. And what we would do is we would evaluate it to make sure that we can get our minimum requirements for throughput and coverage. And capacity does come into play, but most of these stations are relatively small compared to, say, an office building, which is going to have a few thousand people in it. The station's going to have a few hundred people in it at any particular time. Not a gigantic station, but a normal size station. So we would review all this material. We would make sure the bands that are intended for use by us, the amplifiers and the bands on the side there, that there's enough power available to us, and the amount of spectrum we want to deploy we're going to have enough power for the amount of spectrum that we want to deploy. So we would go through that and give feedback to Transit Wireless.
Now, the title of this and the emphasis of this presentation is really third party. Third party help come in at this point here, or?
It may, because we may want to do an evaluation of the ingress-egress signals, as you alluded to earlier. The stairwells leading in and out of the stations are important for us, and you'd be surprised at how much the macro signals can penetrate sometimes, and there are street gratings as well where that can happen. So we do surveys on occasion, and we would want to use a third party to do that kind of survey for us. We don't really have the resources, and when we do, it actually makes sense to do it with a third party anyway.
Well, especially in this environment, because you've got safety training issues, you've got just a whole host of issues that you maybe wouldn't have, say, in a building.
Right, and there may be some economies of scale that could be capitalized on for a third party to then collect benchmark data for not just AT&T, but for any other operator who we're interested in seeing that kind of measurement.
Okay, and Nathan, maybe you could talk a little bit about the design approval process and what you go through internally.
Yeah, so
with Dave.
Yeah,
and
well,
the other carriers.
there's Dave, there's the other carriers, but unlike most buildings, we also have a very strong owner-occupier, essentially, in the MTA. So before we get to this stage, we actually go through a full approval process with the MTA. So generally, we've actually got to the point, by the time we get to giving Dave the approval for this, it is what it is. So there may be an antenna that's in the wrong spot, but that's because of the fact that the MTA hasn't approved it. Now, this may be different to other venues Dave has, where the onus is on ourselves. Dave doesn't actually need to approve this design, because if it doesn't meet our SLA requirements, we have to fix it anyway.
And we're going to get into the SLAs in a few minutes.
Exactly.
Too, but, right.
So the design approval is there. At this point, it's an information base because of the fact that we've done so many of these, and Dave's guys are quite comfortable. But the initial 6 stations, I'm sure there's a lot more due diligence done on
There was
the
more
whole
due
thing.
diligence and more back and forth.
Right.
The implementation process, now this is what you've outlined as your implementation process for Transit Wireless. Construction, the CW testing, carrier integration, and the CMRS, or the commercial testing. Now this is where, when we're talking about third-party validation, this is where the third-party validation really starts to come into play. And maybe we can talk about some of these, but, and the question really is, what value does it bring to you, to Transit, and to both of your masters, if you will, to the MTA and to, say, the wireless carriers?
Right. So obviously there's a number of stages in construction similar to any other building. The first step of construction is actually validating the installation. And generally that is done by the construction company that does it, but we also bring in third parties such as VCOM at that stage to, they validate that the people actually doing the work know how to use the test gear, are certified in using the test gear, actually understand the results, and they're providing the results we need. So we don't have the resources to be out there every night of the week, and generally Transit Wireless and all our subcontractors are building every single night of the week from 9 p.m. through to 6 a.m. So having a third party that does this regularly and can spot check at that point really helps.
So the third party here then is, I mean, there's the validation component to this. So I know, like, we've done some of this for you, and I know you've had other firms do it as well. But we come in and we'll do like the CW testing, and we've done some of the commercial mobile testing as well. And like you said, we've also worked with, and we'll get into that as far as the construction validation, that type of thing. But so there's a validation component, but then there's also just a resource component as well.
Right.
So it's more than just validation.
It's more than just validating, because you can have an engineering team that does a particular project very well, and is used to doing it. It's when you get beyond the normal, it's no point having that resource in your team if you can rely on a third party to provide you that input.
Now, Dave, here the question for you here is, and Nathan had mentioned, we're going to go through this in a few minutes about the SLAs, and I don't know that some of these building installations that you have, some may not, but specifically I know in the subways there are SLAs. So how does having this process and this carrier approval process that they go through, and the fact that they use third parties, how does that help AT&T from a decision-making standpoint, from a just an operating standpoint? How does that help you? What value does it bring?
So we have our resource constraints also, which Nathan mentioned, and there are the phased projects are 39 stations each, the latest ones anyway, and we just don't have the resources internally to be able to do that much work when these stations are ready to come on. Everything has to happen simultaneously, so that's definitely a factor. But there's also a lot of equipment that we need to have tested that the AT&T doesn't own. So there's a lot of shared equipment. We do want to ensure that it's working, but it's equipment that's shared amongst the carriers, all the operators, all the wireless service providers, and we actually prefer to have somebody who's a third party looking at that with an objective overall view to make sure everything is working for everybody, and we feel that there's value there. We do our own functionality testing as well, but we like to see a thorough third-party analysis to make sure everything is working the way that it's
Sort of a
designed to work.
sanity check from your perspective. One of them is a sanity check to the other one, basically.
Exactly.
Right. Okay. Now, on this next slide, again, this is Nathan, this is one of your slides, the propagation model. We'll spend a minute on this, but basically, and you can see here on the slide, what we've done is we've gotten, there was the RF prediction, and then we did some field measurements for you. Let's talk about the kinds of problems and issues at that stage that we've found and actually been able to correct, and how helpful this was in the value. And there's another question I'll have after that.
Right, so Similar to normal buildings, there's a CW process that's done to establish the building itself. The subway itself, we've now done more than 100 subway stations, so we generally know what the walls are going to do. So we don't walk out there and test every single station to see what the propagation's like, because it's the same as the last one. But what we've done here is we've outsourced to VCOM in this standing is there's a certain effect that we see in the subway, we don't understand it. So we've done our own modelling, we've given that modelling to you, and you've gone out and validated how close our modelling was to the reality. So, having that resource to take, it would have required my engineers to go out there in the field and do this, and if you may have picked up our roll-ups quite quick, doing something like this properly takes more than a few hours in the field. It takes preparation and then it takes documentation. So giving that to a third party who does it well just keeps my designers designing.
And from a design standpoint then, this can help you, and like you said, in the subways, I mean, use IBWave. IBWave is an excellent tool and it works well, but these subways are 100 years old.
Right.
You've got plans. I remember looking at one of these with you with a tunnel recently that the drawings were from 1939, I think, or some from way back. And so the ability to capture all of that and then get that properly into IBWave so it can do what it needs to do is difficult.
Right.
So in this particular case, I mean, here, so basically what you're saying is over and under prediction that IBWave is doing because you just don't have enough information about them.
Right, and this is someone in my team has coined the wall effect, but essentially you can, if you want to get into the details, you can see that there are a bunch of I-beams running along and IBWave predicts it as it's just going to go straight through it. But through this testing ourselves, we can see that it creates a sort of a steel structure that the propagations won't go through.
Right. And then we talked a little bit about, we'll touch on this for a second, but the CW testing, the carrier wave testing. In these cases here, when you've done this, and my recollection when we've worked with you on these things are a couple things, besides actually testing to verify that everything's working properly. You also use it to help with power distribution, adjustments to the system, that type of thing, so that, again, you did the modeling on the last slide. Really, it's to fine-tune the system so that when you're ready to bring on an AT&T, you're pretty confident that the system works.
Yeah, so this is a big project, and it's a big project for the carriers. So what you can see here is the CW testing that we've done once we've built the system out, which is common to any NEDAS distributor. The difference is here that this is a sign-off that we provide to the carriers that they're happy that it meets the model. But more than that, for us, this helps us identify ahead of time, based on historic, if there's going to be any issues for the carriers that we need to fix at this time. This doesn't show it in this slide specifically, but I think if we go to the next one, you'll see that what we've got here is this is an issue that CW has identified for us using the third-party testing. Up the top is red's not good, as opposed to AT&T liking red. I say red's a bad thing, so red is bad over here. On the side is the IBWave prediction, and having our testing done ahead of the carriers getting involved has demonstrated to us that our construction company has actually made a major issue with the couplers and the splitters. So having VCOM come in, they did the testing, they've given us feedback and said, hey, hang on, this one's an obvious one, but there's something wrong here, you guys need to go resolve it. And so that gives us the ability to go back to our construction company, resolve it, retest it, and then provide, the only thing AT&T would have seen in this is that final result. So they don't need to know that there's issues along the way because they've got a lot of issues they're dealing with themselves. They're paying us to get it done. They don't want to see issues.
So the two things that you had mentioned here then, and I'm going to ask you a question, Dave. You had mentioned, well, one, I mean, obviously this gives you the ability to, you've got your SLAs and it's your sort of first sign-off with the carriers, but it also gives you the ability then to really hold your contractors' feet to the fire because you can't just keep going down there and sending people back.
So I guess just to break in, as a result of this, we actually, it gave us the ability to go back to our and we'll get to this later on, go back to our contractors and go, hang on, this is a major issue, how can this happen? And it turns out their knowledge of the system wasn't good enough, so it encouraged us to go back and retrain them, essentially.
Right, right. And then Dave, for AT&T at that point to see, and what Nathan's described here is you didn't see the first one.
Right.
Which frankly, I
He
would
does
imagine.
now, he's a bit concerned.
No, well, actually, we need to know that this is going on.
Right.
So we don't need to see the details necessarily, but we do need to know that due diligence is done. We do not want to turn on a system for commercial service and then go out there and find half the station doesn't work when we're testing it. We want to have confidence that it's going to work on the day that we turn it on.
Especially with 7 million passengers a day.
Exactly.
Right.
One of the biggest things your team deals with is this doesn't have a downtime, it's live.
Yeah.
And so if you come in and I give you issues, you have issues from day one.
Yeah, we don't want to see that. Everything's got to be tested uplink and downlink in these stations. We don't want to see, if you see just walk test and it looks green, you go there and you have no uplink. We need to have a level of confidence that we're not going to find that situation.
And in the testing here with transit, it's both uplink and downlink. So the uplink is a more difficult test to perform.
Yeah.
The downlink is pretty, not simple, but the uplink requires a little more ingenuity to get that thing going. Now on the metrics testing here, this is where absolutely third party comes in here. And in fact, I know we've done it for you, but you've had other firms as well. You've got other firms that have done this for you. But and these are the standard metrics for throughput, RSRP, RSCP, that type of thing. Let's jump back a little bit to the Wi-Fi and 4.9 and some of your requirements there. And then, Dave, what I need you to talk about is maybe just, again, some of the value here that you would see.
So I guess similar to these are obviously carrier metrics that I hope majority of you are quite familiar with. We have similar metrics for our public safety and Wi-Fi systems. So we have negotiated these agreements with the MTA and essentially ourselves for our Wi-Fi. But we also have to demonstrate ourselves before we make it live.
And Dave, at this point here, what happens is these are some of the reports that you see coming from Nathan. So, from transit. So he's got, as you know, and you already know the process and you've seen the process, but as we've walked through it here, I would assume at this point you've got a pretty good feeling that the system is actually working as you require it to work under your SLA.
I would say so, yeah. But ultimately, what we will do is, these are great, but once we go live, we're going to get our stats from our network, and we can see exactly how it's operating. We're going to see what kind of signals we're getting into the system, and we're going to see if there's dropped calls and things that are on the downlink as well. But it's really critical that this work be done before we turn it on. So.
And then we've already touched on the SLAs a bunch here. Let me just move on.
Yeah, I think, well, just to talk quickly on that, the advantage of having a third party work through the SLA agreements, which we rely on VCOM, is the third parties deal with the carriers every day of the week. So they know what sort of SLAs they're looking for. So, you may, as a neutral host, have relationships with carriers, but the third parties deal with them every day of the week, so they have an understanding of what's required.
Now, this is just some, in fact, we'll move on here in the interest of time, but this is just some more of the testing here. And Dave, what we could do is we could talk about some of your testing, and this sort of fits in with, in your couple slides that you have where you talk about some of your design requirements.
Okay.
Nathan, you had talked about contractor training, and I know that we've worked with you, and you know that other firms have worked with you as well. It's a different set of contractors in the subway. It's a different requirements, different safety, it's just different. It's not, in fact, you found that. It's not the contractors you might use otherwise.
Yeah, look, I mentioned to someone at lunch, you may have picked up I'm not American, I'm from Australia. My background is broadcast, where we get to fine tune out and tune everything up. We moved to New York Subway, where we have to use electrical contracts to install RF. I would like not to do that, but that's the requirement. So the way that we've gauged that is we make sure third-party training houses have actually come in and certified those workers before they touch it, because otherwise we end up with headaches. It's built, the contractors don't know it doesn't work, and so on. So
the training is on an electrical, these electrical contractors typically wouldn't have this training, but sweep testing, PM testing, that type of thing. And then I guess the question is in that particular case, overall the results are probably good, but I'm sure there's been some mixed things.
yeah, look, we've trained, we have a number of different contractors, and some of them have picked up on it well, and some of them haven't. So the ones that haven't have either decided to go that extra training, or they've decided that this relationship doesn't work. But you know, ensuring that you train the installation teams correctly is very critical, because they're the ones who are out there doing it.
Now, Dave, you would have a similar problem in the buildings. One of the comments here on the bottom of the slide, it says a quality assurance program is a must to reduce the expensive rework. Now, for you down in the subways, it's very expensive to send one back, but you've got similar issues here.
It's expensive no matter what.
It's expensive no matter what. You and I were talking at lunch, just changing out antennas, and you'd think maybe it's easier in the building, but the problem is the buildings in New York are all pretty full most of the time. So it's easier said than done.
It's absolutely critical that we get a contractor who knows how to work with the material. And there are examples where that hasn't happened 100%, and we've had to go back and fix things, and it's always a big problem, because once a site goes into service and it's available to the public, it's a site that we can't simply shut off and fix things. So it becomes a real problem, and we really need to make sure that this is handled properly before, during the construction, and not fixed afterwards.
Now, on this slide here, this is just some of the
training,
some of the slides, right? Yeah. EMF testing also, we've done EMF testing. One of the issues that you have, Nathan, specifically is sometimes these antennas are they're very close, right? Especially if you've got tall people down there. So EMF testing is an issue. Well, obviously that's a third-party thing for you as well.
Yeah, you shouldn't, doing that yourself is not the right approach, because there's liabilities that are involved.
Right. Now, Dave, let's talk a little bit about AT&T Wireless. You're licensed in New York. In your areas in New York City, you've got 700, 850, 1900, and 2300. Now, we talked about this. So the other thing is about half the time you're a neutral host tenant, the other half the time you're a neutral host operator. So you're on both sides of that fence as well.
That's right. So when we're approaching like a greenfield project, we usually look to do a full neutral host design, which means we can accommodate another carrier. And in that regard, we're like a tower company, and we market the asset and try to get a tenant on board. But if we're joining a third-party system, then it becomes about evaluating to make sure that our needs are met, and that we're joining a system that we're spending shareholder money on that's going to make sense for us.
So we are the neutral host. I mean, you as a carrier or an operator, you've got specific frequency bands. Now you as a neutral host, you've got to open that up to bands that you wouldn't normally operate, but now you've got to operate and make available because some of your tenants
need
it. Right, exactly. Now, and then you could talk a little bit about the design approach. Now, without going down through all these things, the interesting thing about this is when we talk about there's sort of internal and I'll call third party or external, and you see about halfway down the list here is where the external really starts to come into play. And maybe you could talk a little bit about that.
Sure. So starting at the top, it's an overview of the project. The design summary information, maybe we would send somebody some information about what we're looking for. We would evaluate the venue capacity to determine how much capacity we would like to deploy, and that drives our BTS dimensioning. It may drive the design scope if there are a lot of zones required in a stadium, for instance. But at some point, we get to where we need to do survey work, benchmarking, and understand what is the actual problem that we have to overcome with the DAS. And at that point, you can see we bring on a third party, usually.
And I'm going to keep moving through these. We're running out of time quickly here. And you and I have talked a little bit about this one here, the sectorization plan. This is where it's both inside and outside work. So your guys will figure out, this is what we need, we think, for traffic distribution, but then you need someone else to really figure out how to implement it, or that's what you use a third party for.
Well, there may not be enough information in the drawings that we have. There may be sector boundaries that make more sense. where the walls are located or where there are architectural features. So yeah, we look for third party to maybe guide us with that as well.
And we've talked about a lot of these already. Let me move to this was an interesting discussion that we had, the empty floor plans. Maybe you could talk a little bit about empty floor plans, and I'm sure a lot of people in the audience here can relate to that.
Okay, so typically we see this in an office tower in Manhattan. The owner will give us drawings that show the core of the building, the elevator, banks, and then the walls, the curtain walls of the building or the windows. But none of the tenant space is shown in the drawings. We don't know where the offices are, where the break room is, or where the cubicle walls are. And we have to move forward with a design because we have a project that we have to move.
And you know that these walls are coming, you just don't know where.
We just don't know where.
And how many, right?
So we've done some evaluation on some of the projects that have come on the air, and what we really like to do is make sure we have extra RSCP or RSSI built into the design to overcome anything that we can't predict with empty floor plans. So we want to budget in extra power, basically.
Okay. And here we've talked a little bit about this too. This is where you've got same building, alternate designs.
Alternate design.
Yeah, I think that's an interesting. If you can talk a little bit about that.
So this is a hotel.
This is your ingress-egress issue, or it can be the ingress-egress.
Can be. It can be. This happens to be a floor that's a little above the ground, but we were concerned about the initial design on the right, showing that we weren't going to have enough signal strength near the windows, and we did a revision. I think we increased the power in the remotes for this as well. We moved the antennas outside of walls, and we revised the design based on our benchmark data.
And you're saying there, in this case here, oftentimes you'll go to a third party to sort of get an outside view as to how different ways to do this and different ideas.
Absolutely.
Kind of like the sanity check that we talked about before.
It's always good to get that.
Right. We've talked about this a bunch already. I'm going to move on to the next one. These are just some design solutions that you've given me. And the interesting one is the one up on the left with the two antennas. Now, the question is, are they two antennas, two bands? Is that diversity? Why do we have two antennas in that picture?
That is I'm not even sure where that is, quite honestly. But that is it's not two antennas, two bands. This is a full two-sector deployment, it looks like.
Oh, okay. And I see the other ones. You can see the picture to the right of it. You can see the two-sector antennas sort of angled a little bit.
Yeah.
And then you could see that entrance there to that stadium or whatever it is there, the arena.
Yeah. But these are just typical antennas that we would use.
Now we've got a couple more minutes here and I want to get into questions. So really we've talked about this, the third-party discussion. Nathan, you've got contractual requirements with the MTA. Mm-hmm. And we've talked about that. You've got contractual requirements with the carriers like AT&T. And then in this case, you've used VCOM, and I know you've used other third parties as well. Mm-hmm. And Dave, you are, as AT&T, you're both a tenant and you're an operator of a neutral host. And then you operate, we've talked about that a little bit too, you operate your independent DAS system. Sometimes, like an enterprise situation where you're building for a particular customer might be, just unique to AT&T at that point.
Yeah.
I guess on each of these, really the whole thing is bringing back, and I think we've talked about this, bringing back the value that the third-party validation is, the sanity check, in this case here, the SLAs,
I think it's a resource. It is independent, which is obviously good for the two parties to be independent, but also it's a resource that is consistent and repeatable. So you can grab this resource as part of the project plan and bring it in and out. If you were to do that internally, you have a lot of people sitting around waiting for the project to finish. It's not a good way to use resourcing. You do pay obviously a little bit more, but in the long run you get a better quality product and you get a more timely product.
Okay.
One of the other ways that a third party can actually help us is if we're dealing with like an interference problem on a system, especially if either us or one of our competitors owns it. A third party can bring somebody to the table who's neutral, who doesn't have any self-interest, perceived self-interest. And I have found that to be helpful, actually, to use third party in that situation.
Good. We are just about out of time here. I want to open up the floor to questions. Oh, we've got a couple right down.
Right there?
Gentlemen, thank you for the presentation. I want to kind of focus in on the training aspect. I'm a contractor here in New York City, and I, like you, need that resource for training. So I'm wondering, my question is really, is there an independent resource?
I have a card I can give you afterwards.
For training? Do you provide the training? I mean, I know we have a lot of manufacturer training, and I'm appealing to Bixby for training for cellular, physical hands-on for technicians and installers, and that's an uphill battle so far. But where do you go for your training? I mean, at Transit Wireless, where did you go?
I guess one thing that we've created, we obviously send, if we have INRID 2 gear or if we have another manufacturer, we send them out for that certification, and that's a requirement. You should definitely do that. What we did was, you saw it's in phases. So what we do is we get the contractor for that phase, and we usually end up paying them for their time. We bring them into our facility. VCOM kind of provides certain input. They do the RF component on the generals, but we grab the suppliers. So if we're using RFS connectors or spinners connectors, we get them in. We're buying enough of them. They need to demonstrate, because not only is it beneficial for the contractors, it's beneficial for the suppliers to know that their products are being put in properly, because at the end of the day, they get finger pointed at. So it's about, we try to set up a day or two where you bring them in, you get the experts that know what they're doing, and you get them in a room, and you just certify them through that process.
So it's kind of like a multi-vendor training seminar that you're conducting, and in this case, you're going through VCOM?
Exactly. VCOM does the kind of the RF testing and certification. Then we have our fiber provider demonstrating the splicing process and testing, just to make sure everyone is on the same page. The prep work saves the time in the long run. I guess a good example, let's say an RF component, a coupler and antenna costs $200. For me to install that probably costs $5,000. For me to replace it, if it's not working, it probably costs $20,000 or $30,000. So spending that time up front, it pays for itself, essentially.
Very quickly. In fact, we've seen, even where we've done the training and it doesn't always stick. It's oftentimes it's at a different level than some of these electricians are used to. They just haven't worked in that environment. It's not their bailiwick. And, where we've run into problems, we've still had to go correct
Yeah,
things.
so I've actually, on top of paying, say, VCOM to be at the training, I've paid VCOM 2 or 3 days on top of that to be out there with the contractors just to reinforce it. So in 3 weeks' time, get out there for a night. It's a quality assurance that you need to have.
One follow-up question, really on a totally different spectrum on a technical end. What does it take from an aggregate bandwidth perspective to support 7.5 million people on their cell phones? What is your pipe?
So that's Dave covering.
So we're deploying the same spectrum that we use on the macro network inside the subway station, but it's basically a distributed architecture in the same way that a cell phone network is. For AT&T, each subway station has its own cell site dedicated to it.
Its own cell site.
Right, the base station hotels, and we didn't spend a lot of time on that, but you had heard in the previous panel about base station hotels.
Right.
The base station hotels that Transit Wireless has are several and are very, very large. If you've been in there, they are large, effectively data centers, and as David had said, the carriers have multiple, either small cells, BTSs, Bs, multiple. Usually each carrier's got several racks of equipment, so.
Yeah, so our base station hotels typically hold 60 sectors for every single carrier, for every single technology. So they all bring their own backhaul, and this gets back to the base station hotel discussion, but having a base station hotel means they can pool all their assets into one spot, means they can save on their backhaul costs, and it's not even so much save it, it's easier to get backhaul to one place than to 279.
Yeah. Well, they bring it to you.
Yeah,
and then
we
you
deal
bring
with
it
that
to the
because
other
we take
right.
the fiber to that location.
Any other questions? Yes, in the back we have one.
Said I'd do it.
I think we're out of time, too.
Thanks a lot. The question is, how do you plan to maintain this network in terms of radio performance and maintaining those KPIs and SLAs over time as the network changes, as the subways, new walls are built or whatever? how are you going to be sure this thing's still working the same way in year 2, year 5, and moving out?
Well, that's interesting, actually. We had this conversation the other day. I mean, you've got your whole operations crew that basically maintains and keeps an eye on the network, but then actually Nathan and I had this conversation the other day about maybe annual checks beyond that to verify they're within the SLAs, that type of thing, and just for your own performance to confirm your own, sort of the front steps that we talked about, sort of coming back and just verifying it's working the way it was designed and intended to.
The carriers have their own monitoring, and they will tell you if it's not working, but you don't want to get to that point. So what we do is we currently, and we're still in the build process, but we go out there and do spot checks, etc. But like we're saying, we're looking at maybe a third party to come in after it and annually come back and check certain parameters, etc. It's better to know it's not working ahead of time.
With that, I'd like to take more, but I think we're running a few minutes over.
Yeah,
So
that's great. Thank you so much.
Thank you,
and we're going to go
everyone.
right into the next session, so bear with us, and we'll make that transition right now.
Gentlemen, thank you.
Thank you, Dominic.
Very nice. Good job.
I think we got to get these mics off.
Yeah.
Hello? Can you hear me? Oh, there you go. Okay, excellent. So I don't need to put that right to my mouth there. So this is kind of new and different for me. I'm actually up here. As you guys know, I've been kind of keeping the event going on and the program going on. But what you might not know is that I'm a two-term elected official in the village of Mamaroneck. I sit on the Board of Trustees. We have a village of over 19,000 people. And that is the role that I am in right now, in that capacity, in moderating this particular panel, because we are going to be talking about zoning, jurisdictions, and rights of way. You know, a lot of issues and concerns in deploying solutions have to do with what do you need to get done from a planning and permitting standpoint, what are concerns from an environmental standpoint, and what are the legal and FCC requirements that we need to account for. And so I have a panel here of esteemed specialists who will introduce themselves, and we'll have an interesting discussion, I can guarantee that, about all of these issues. So we'll start right now with Marvin on the end here.
I'm Marvin Webster. I'm with Environmental Corporation of America, and for about since 1992, I've been involved with just about every aspect of National Environmental Policy Act and National Historic Preservation Act, also environmental permitting for wireless facilities. When I talk about NEPA and NHPA or National Historic Preservation Act, that's principally environmental issues and historical resource issues for wireless facilities.
I'm sorry, excuse me, just before we go to Lino, if anybody can make sure that the doors are closed, that would be very much appreciated. Thank you very much for that. Lino, go ahead.
Good afternoon. My name is Lino Sharetta. I'm a partner at the law firm Wilson, Elser, Moskowitz, Edelman, and Dicker. In my background, I specialize in representing municipalities as either town or village attorney or special counsel with respect to land use, zoning applications. And incidentally, I was village attorney in the village of Mamaroneck for a few years, so familiar with the zoning process and the planning process with respect to wireless telecom.
David Bronson. I'm a special counsel at Phillips Lytle, and I specialize in telecommunications infrastructure. I say to my daughter, until they put the chips in our head, the infrastructure, the equipment has to go somewhere, and that somewhere is somebody's property. And it's either personal property or public property, the only two types of property. And there's a transaction there, and that's where I get involved, whether it's permitting or the actual agreement, that intersection of real estate and telecom.
Thank you. That's great. Thanks. So I'm going to start with Lino. What does the process actually look like? You know, if you're a provider and you're coming into a municipality, what does that look like?
Well, what I tell my clients and municipalities that I do work for, I would treat a cellular application, wireless application, really like a site plan with the exception of the timing requirements, which are much more expedited when processing a wireless application. So with respect to timing, I always tell my board members to keep the timing in mind, especially with respect to co-location, with respect to the processing of the application, because a lot of these times the board members, they think of it, yes, as just another planning application, but they have to realize that there are timeframes and constraints. They shouldn't be delaying, and that's what I like to focus on with respect to these applications when they come before my boards, is expediting the process and get it through quickly.
So from my experience, anyhow, as a trustee, a lot of the public concerns have to do with, you know, not just the process. You know, they actually don't really care so much about the process. What they care about how it will affect them, and in particular, environmental concerns. And so I know, you know, we're lucky to have Marvin here up on the panel. How can we demystify these environmental concerns that residents tend to have about bringing cellular services into villages, towns, and cities?
Well, you know, federal agencies, FCC being one of those, have a process where the federal agency has to consider the environmental and cultural resource consequences of an action. And as far as demystifying, you have residents who essentially don't want to look at these facilities. They want all the benefits. And so the opposition, if you will tend to latch on to environmental and historic resource concerns as a way of throwing a stumbling block in the way of deployment of facilities, when it may not be the environmental or the cultural historic preservation aspect that they're necessarily opposed to. It's just a good way to, it's a lever to use to pull things in your direction if you're opposed to facilities.
So we've got the perspective of, the village, town, city, what they're looking for and how they can work through the process. We got residential concerns, right? Or, end users and, constituent concerns from an environmental perspective. So what's in it for the providers?
Well, we have to build out. We are required under our, the carriers are required under their federal licenses to build out and serve the public. So this is a necessity. The good thing is that I think the regulatory wind is at the carrier's back now, going back to, in 2012, the Middle Class Tax Relief Act passed what's called Section 6409, and then in 2013, I was at the NEDAS event in Washington, spoke about the FCC coming out with a notice of proposed rulemaking, spoke again the last year in 2014, the rules were coming out, and now speaking here in 2015, the rules go into effect literally next week. And what those rules do is make co-locations, modifications, the need to swap out equipment go much, much quicker. And I think the localities actually appreciate that, even though they're suing actually to stop the rules. They appreciate that there are bright line rules that they can go to their constituencies and say, look, these are the rules, we have to follow them. The rules make clear that a substantial change, more height, defeating the stealthing, more protrusion, excavation, those are substantial changes that do not go through a as of right, if you would, permitting that has a 60-day clock on it.
And so how are village planning boards and zoning boards and all those types of boards, how are they getting educated, and how are they going to be able to respond to this type of requirement, a new ordinance, and put that into play?
When people like David come before our boards, it's a pretty easy thing to do because, I'd say, maybe 5 years ago, you'd still have people come out, talk about RF emissions and radio, things that we kept telling the public, listen, you can ask for this kind of information with respect to make sure they comply, but you can't deny an application based on that. They're preempted. So what's happening, what I've seen is carriers now much more sophisticated coming before the boards, and they make my job easier because they're the ones who are coming and educating my board, educating the public, because I just have to say, hey, look, David, please explain to the public, what's going on here in terms of your application, what we can and what we cannot do. I always advise my boards, it starts with your local law with respect to regulating, wireless services. If you have a good local law, okay, it makes the process, and I know you can probably appreciate it, the better the local law, the better it is for everyone, okay, because it's easy to maneuver in the process. When you have a local law that's not so great, that's when things get a little hairy, there's questions of interpretation, and that's when things can go awry. But when you have a good local law, I've noticed, and maybe you can comment on this too, David, but things tend to go a lot smoother. Right? Yeah.
Well, that's going to be a huge issue over the next at least 3 to 5 years that we're going to see, is making sure local laws can accommodate these things. Because as I talked about earlier in the opening session, we're moving at lightning paces here. And municipalities don't, period. I mean, it is the most sluggish process. And here you have, entrepreneurs and people who are looking to solve problems. Technology is being developed, and we're just not moving fast enough. And it's not just the planning process. Now, it's the environmental process. I know municipalities have environmental concerns, architectural concerns. How does that all come in play from your perspective?
Well, David talked about the new rule that we have, and there's a component in that rule that allows for Well, let me back up. There's no categorical exclusion for DAS or small cell facilities, be they in the right-of-way, be they inside a building. What there are targeted exclusions. And so from a federal process, what you have is you have the ability to now exempt yourself from certain requirements, but you first have to subject every facility to some level of documentation to determine whether or not the categorical exclusions that have been granted by the commission with the new rulemaking, whether or not those apply. For instance, we now can put new tower structures within the utility right-of-way, provided that there's no substantial increase over the existing above-ground utility poles, if you will, and provided that other certain requirements are met, so that then at a federal level, you're complete with that process, so that when you go into a zoning or a permitting process, that's out of the question, and then it's up to local ordinance if there's an architectural review process within the local ordinance that's not preempted by the federal.
But to pick up on Lino's point, yeah, having a good wireless ordinance is important, but to your point about the speed of change, that, I try to build a DAS system on a very high-end area in Long Island, and you're applying DAS to an ordinance that requires a setback and parking at a facility, and you're just, and balloon test for something that it just doesn't work. So you really have to be creative and work with attorneys like Lino who want to work with you.
Yeah, absolutely.
Yeah, and that's key. I mean, I've been through municipalities on the other side where it's not so friendly. You go in and you're met with a lot of resistance, because I think part of the reason is the education's not there. I think they need to be educated on what's going on. I mean, I know in one municipality that I represent, I think we've changed our local law. I'd say within the past 5 years, it's probably been changed about 4 times, which is, in the municipal world, lightning fast, okay? But like David was saying, when you have people who want to work with you, things tend to go a lot smoother. And municipalities know now they have to hire consultants, and with the right preparation, they know what questions to ask, with respect to aesthetics, stealth technologies, and these are things that we can work with together to get a mutual, win-win.
And you're a part-time trustee. They meet once every 30 days or so. So you have to get some help on this. I mean, I'll tell you, I also think that we're at a tipping point, that there really is a generational change now. And I'll tell you a story from this DAS system I was doing on Long Island, very high-end area. People started to say, well, I don't want this outside my, it was 500 feet away from the road, their house, but I don't want this on the road because it's going to diminish my property value. And so we got all the experts together to show that there isn't that effect on the property values, and we're about to present to the board. And one of the trustees got up and said, I'm a real estate broker, and it's really not true, because people who are coming in to look at the homes in this area are asking, what's the coverage like? So it's really, we are at this point where I think people are more comfortable with the technology, and we're going to see an easier time.
So it's really interesting to give you a little bit of insight into the role of a trustee. For instance, I actually meet once a week. There are public meetings that are televised every 2 weeks, and on the weeks that we don't have a publicly televised meeting, we have a public work session meeting that's not televised. But we're also invited to various monthly meetings. The Westchester Municipality group has monthly meetings, and they bring in special presentations. And the last one, I was supposed to leave early because I had another meeting to go to, but I had to stay because it was all about DAS. They had experts come in and educate the municipality government, including those who run in the village manager office and the village managers and the clerk's office, about how to negotiate rights for towers and issues having to do with DAS. And it was really very fascinating. But just like with anything, we're not necessarily the bodies that are making those decisions, nor are the village managers. And a lot of these decisions are being made in the fire departments and the police departments, and then they have to roll up. And it gets to be rather complicated because one hand doesn't always talk to the other, And consultants are always the best, the most highly sought after folks that to bring on to projects because they cost money. But getting access to education by means of attorneys and advisors and volunteer members is really what they rely on. And it's really challenging to work through all of these issues, especially, right, and bringing it back home today for in-building solutions. I mean, we have in-building solutions, which, I mean, yes, you could, you know, we're talking about putting, you know, cell sites out or small cell sites on buildings and, you know, being able to put DAS systems, you know, but what happens with in-building? These are private property owners.
Yeah, I mean, you know, it's not the same as a zoning issue per se, because you're not building, you know, a macro site or a tower or a rooftop. You're installing something within the private property of the owner that needs, you know, a building permit perhaps, an alteration permit, if you will. But you certainly need to do a transaction. You have to have an agreement with the owner and address the landlord's concerns about aesthetics, about you know, who's paying for the power, you know, compensation, if any, a revenue share, if any, who has the burden of building the neutral host, if it's a neutral host system. So you have to have that agreement with the property owner. It's not so much a regulatory issue.
But what about the invisible?
The
It's the spectrum. What about that invisible that we, yeah, you could put some equipment in a building, and yes, you can shake hands and do a deal, but
well, there are people here much more knowledgeable about spectrum than I,
Yep.
but you know, everything has to work together, and you can't interfere with licensed frequencies, and that's, you know, that's the way it's got to work. I mean, you know, in terms of the invisibility, if you will.
And from my standpoint, if it's invisible, it's that much harder to regulate from a municipal standpoint.
That's right.
Because, again, it's not a structure per se that a zoning code would define it, but you might have to go get a building permit for it. But again, those are things that municipalities now have to probably further legislate and change their local
Right.
laws to address that.
Right.
it's really challenging. And who's responsible for ensuring it's FCC compliant once it's in the building?
It's the licensee's responsibility to ensure compliance at the federal level, because that's the trigger that pulls them into the federal process is the fact that the agency has to issue a license. So that on a federal level, it really doesn't matter whether you're inside or outside. You get away from the exterior view shed, but you still have the same requirements because there are building interiors that are historic and that can be damaged by installation or deployment of wireless technology. So in many cases, you would end up submitting to an agency, say the State Historic Preservation Office, and getting a clearance, but you know, you may be required to modify the placement of antennas or the way that they look in order to preserve the historic integrity or the historic fabric of the building you're installing in.
And I do a lot of transactions for rooftops and other facilities. The most important provision out of 25 provisions in the agreement is the interference provision. Most important to my clients.
How do we deal with building permits then, and inspections and all that type of stuff with all of these unknowns? I mean, yeah, it's one thing to see a DAS system installed properly and having, powered, correctly done, but how do you know that that's actually been compliant to FCC standards and regulations and all of that?
Well, I think just like planning boards or whatever agency is responsible for the approval, as the municipality, you can request information that you are compliant. You can't regulate it, but you can definitely ask for that type of information. So for things that would not require, let's say, a site plan approval or special permit, I guess your building department or zoning official would have to request that information just like a planning board would or a zoning board would in an application.
Yeah, and you'd know if there's interference, and then you go and look at the license and see who has the actual license. If it's unlicensed spectrum, they can't interfere with licensed spectrum.
Yeah, interesting. We have a couple of wrap-up slides, but before I go there, I wanted to know if anybody had any questions. I can't give you the mic, but I'd be happy to. Oh, we have a runner here. Great, thank you.
Thank you. Jake Raspail, Sublime Wireless. Looking at this, taking it as a perspective of carriers going into municipality, having done a lot of work in both the smart grid space, municipal wireless space, how does this dovetail with what municipals may put in for their own needs, if it's a smart grid system or a municipal wireless Wi-Fi system, and then also comparing that with what the cable company may do as a area Wi-Fi? I mean, there's shades, sometimes shades of gray when it comes to what's going into the municipality and how it gets dealt with. I wonder where your perspective is.
Very, very much so. And, when we were gas system, on Long Island in these communities, I would say, look, there's a Wi-Fi antenna for this cable system. They didn't come to you. They just did it under their cable franchise, and their cable franchise doesn't talk about antennas. It talks about, fiber optic or coaxial cable. So you're touching on something that's, very, very important. And then, municipalities do want to put Wi-Fi systems in. They also want to have other people, AT&T, Google, whoever in New York City, provide it gratis. But New York City has now turned the payphones into Wi-Fi kiosks going forward. So they're not going to go through it's a public-private partnership and it's going to be franchised, but it's not on the municipality's dime.
Anybody else want to address that? Any other questions? All right, so let's see who's up first.
You want to go to 2 more slides for me? Yeah. So what I'll talk about is just in the new rule that became effective for the environmental portion. David said the 6409 portion is next week. The environmental portion of this rule became effective February 9th. And it offered targeted exclusions. And so just by example, I'll just give you one of them. I've already talked about new structures in the utility right away. This one has to deal with co-locating on existing utility poles, so that basically if you meet certain size requirements, for instance, you're allowed to co-locate on a utility pole without having to go through submitting to State Historic Preservation Office, or because it's a federal process, there's an obligation on the licensee, the applicant, to consult with Native American tribes. And so the problem that we had was that we would have an outdoor DAS system that had a certain number of poles. Let's say we had 30 poles and 10 of those were over 45 years old. Well, as a technicality, the carriers were getting caught up in the problem of having to do a SHPO consultation. Whenever you do a SHPO, or State Historic Preservation Act consultation, you're also obligated to go to the Native American tribes. Well, the Native American tribes have fees, so we had poles where there's no ground disturbance. Another entity is bringing in the power and the fiber that you need. So you literally have a small cabinet on the side of a utility pole, cabling up to antennas that are either at the top or somewhere near the top, small antennas. So there's no ground disturbance. There's no possibility of harming archaeology on the license, on the federal licensee side. But some of the tribes were asking $4,000 per node. So what this exclusion does is, if you meet the size requirements, it allows you to avoid having to go to consult with the Historic Preservation Office, and it also avoids having to pay $40,000 or $50,000 in fees when where really it's just a technicality and there's no real harm, or very remote possibility that there would be a harm from that type of facility. And this is one of the exclusions.
Do you want to talk about any of the other sides?
No, I mean, if people have questions, they can come in. We can talk about the various exclusions.
Okay. All right, the 2014 FCC infrastructure report.
Okay,
in order.
that's me. Go about 3 slides in. Stop there. So this is what the rules are that would, create efficiencies in local review of applications. And again, it applies to co-locations, replacements of equipment, removal of equipment. And if any of these are applicable, meaning there would be a substantial change, it doesn't get streamlined. So what you have in terms of these are, is there a the relevant tests are, is there a change in height in the first one? Is there a change that protrudes from the edge a certain amount? Next slide, please. Are there changes in cabinets beyond the standard? Is there an excavation involved? Or something, or a deployment outside the current tower or base station? And base station is defined to be very broad to include buildings. Does the installation defeat the existing concealment elements? Meaning, would the paint change? Would it require taking away any of the stealthing? And are you adding fencing beyond what was originally, number 6, or beyond what was originally there, unless it relates back to a permitted substantial change? So any of these would bring it back to a more, not as streamlined permitting, and the town could have a more formal zoning review of the change. But what the FCC did is give these localities and the carriers bright line rules so that there are no ambiguities, no interpretations, and that if something comes under these as not being a substantial change, it gets a 60-day look at by the locality, and otherwise it's deemed granted. Very important, very helpful. As I said, the regulatory wind is at the carriers back in these, and the government is preempting, if you will, local governments.
And is it fair to say that because municipalities tend to move so slow, that anything that the FCC does at this point really is what is going to be followed and adhered to on a local level? And so if you know about this or have access to this type of information and leverage this, you can actually accelerate yourself through any kind of local process if you need to.
Yeah, that's it. Okay. It's the end of the day. NIMBY, you've heard of NIMBY. Well, we faced Banana, which is built absolutely nothing anywhere near anyone.
All right, I'm going back. One more. Sorry, I just had to see where I was at.
And you can take the last slide.
Oh, I'm going to go back again.
That's it. And go back.
These are handout materials. You get to read these at home.
And just to pick up where David left off with respect to 64.9, what I said earlier, you should have, as a municipality, a local law that establishes procedures and standards consistent with the limitations established by federal law. So with respect to the new guidelines, yes, local laws now should be tailored to fit the FCC guidelines. With respect to the application, I said earlier, treat it like a site plan with the exception of the timing, obviously. The timing has to be expedited. But when I say a site plan, it just makes it easier for a planning or zoning member to understand that this is the process, but we have to take it through, but again, with certain expedited timeframes. Hire consultants, especially if there is a significant gap issue or least intrusive means. And lastly is don't delay, and I tell it all the time, it's a big thing. That's where municipalities tend to trip up. And don't discuss, RF emissions in a decision unless the applicant hasn't met the federal standards. You're allowed to request it from the applicant, but you can't deny it on that reason. So, and that's it.
Well, yeah. Any other questions before we wrap up?
You don't want to be a delayer, or because you will, as a municipality, you will end up in the record at the FCC about why this is a problem nationwide. So.
And then they will adjust all their
and
laws and regulations
they will make it,
in order to
And as a carrier, you shouldn't hesitate to work with, special counsel. I mean, the first call, what I like to make is to the town or village attorney when I'm not it. So just to start the process and to get a sense of, okay, what's the environment here? What's the climate like in terms of processing these types of applications?
All right, there we go.
So
we're all set. So we'll take, we're going to clear the stage here. We're going to bring up our last speaker of the day, and then we're going to go into cocktails. So plenty of food and drinks are going to be waiting for us in about a half hour.
So yeah, just one, beyond NIMBY and beyond Banana, there's also NOPE, which is not on the planet Earth. So
That's right. Thank you guys. Appreciate it.
Thank you.
That's cool. Hello, hello, hello. Here we are again. Last session of the afternoon. Hunter Newby is holding us back from drinks, but I promise you it'll be interesting. So we've talked a lot about the micro view today. We talked a lot about what the future is. Hopefully you are compelled to challenge one another and think beyond what you know and try to figure out how do we get to where we think we ought to go. So one of the ways that we could do that is by looking at the macro view. What is it that we have and how do we work with what we have? Hunter Newby is here to talk to us a little bit about that today. He's one of today's top innovators and entrepreneurs with a track record of success in communications network infrastructure. In 2008, Hunter founded Allied Fiber, the first integrated network-neutral provider of dark fiber in the United States. By developing modular co-location facilities in towns and cities throughout the U.S., Hunter also aims to strengthen area communities to become centers of commerce and boost local economic growth. And if you guys remember earlier today, y'all know I'm like 25, which means I probably have known Hunter since I'm 3. So without going any further, Hunter.
Thanks, Alyssa. Thank you. Thanks, everybody. Thanks, Alyssa. It's great to be here. And yeah, so I guess that means I'm about 28 or something. I don't know. We've all been in this business for a while. So I'm going to discuss the macro view. I talk a lot about macro things and micro things in terms of the physical layer networks. I've built a few different physical layer things. I understand all the layers of the stack. I like to stay down low. I like to be in the real estate business and enable the network operators to do what they need to do without much interference, or minimize the interference to the greatest extent possible. So small cell is certainly a development in the wireless space, which is probably more than a trend at this point. And a lot of the terminology that's used, whether it's small cell or HetNet or femto or pico or whatever, all of that relates in the wireless world spectrum and then some physical asset. And that physical asset, typically an antenna, needs to be appended to something. So I'm sure you've heard all day today, and like you heard on the earlier panel, and David was talking about it, the issues really relate to rights of way and rights of use. So how do you get the rights of way, rights of use, the spectrum, the antenna, the device, and then fiber to that point, because wireless drives the need for fiber. One of the dimensions of my business, Allied Fiber, was to figure out how to build a neutral fiber infrastructure around the United States that starts and stops with the submarine cable landing stations, but along the way provides access points and our own buildings that we place every 60 miles as neutral hubs for interconnection. And when you think about our design, which I'm about to get into here, from a ring architecture perspective, wait, I hit the wrong button. There we go. Think about our design, and again, this is generic. I'm not specifically referring to Allied Fiber at the moment. This type of design exists elsewhere in the world. We're just doing it here in the United States, but it's kind of serendipitous how it all came about. You see sort of the basic elements of what's occurring here. And again, the most macro of views, if you close your eyes and think of the United States and the submarine cable landing regions, which basically this area, Florida, the Seattle, Pacific Northwest-ish area, and then LA. Those are the bookends that connect the world. So the submarine cables land and touch there and then traverse through the U.S. So I just have a reference to an ocean generically and a landing point. Greatest macro level view, but then from there along the way, you see there's sort of a physical design between long haul and short haul fiber, and then those access points along the way, which are intermittent or sort of intermediate points, kind of like on-ramps and off-ramps to a highway. So the red line there is short haul, and that kind of fiber is designed to be spliced into, as opposed to long haul, which you can't really, not necessarily do. But then you see the cell tower array, and we get into that specifically as it relates to this topic. In terms of the distance that fiber laterals typically are built, which for the most part is about 1 to 2 miles from an existing fiber plant. And then sometimes microwave is used to extend the reach of fiber, which is the depiction there on the left side. So this is really the core. And then we have to drill down into small cell for backhaul. And you could see cities and towns and whatnot. And really, the small cell backhaul requirement for fiber is thousands of times greater than what it is that we're building in the core for the superstructure. So even if you think about a legacy metro fiber network design, back in the old days, which isn't even that long ago, maybe 10 years, people thought that a 432 count cable in the metro was big. And an 864 is, really big. 864s are very small relative to what's required for fiber penetration in buildings. And when you start to think about that and the physics of it, an 864 count cable is a pretty thick cable. And the access rights that are required in cities and for points of entry into buildings, manholes and whatnot, so from the manhole and then the conduit systems and then into the buildings and the risers, all of a sudden it gets pretty congested when you start to do the numbers on what small cell is going to require for backhaul, meaning fiber pairs per antenna site. It makes the old metro fiber network architectures look woefully inadequate. So there's a lot of growth that's going to occur there. But still, again, in the macro view, I think of it as, well, that's nice that you're going to do all that development and we're going to increase the frequency capacity to an antenna for a localized backhaul. But then how do we connect those clusters together? Essentially, how do we connect the cities? I see cities as buildings in the U.S. sort of landscape. So New York and Chicago and Atlanta and Miami, for example, to me are just cities, or buildings in a city. That's a real macro view. And then you can see what this design looks like is, well, what's between, for example, what we just built, what's between Miami and Atlanta? Well, there's a lot between Miami and Atlanta. There's a lot of cities, a lot of towns, and there's a lot of cell towers. And the cell tower design is sort of akin to the old metro fiber network design from a backhaul perspective. When you get into the density of the urban areas and how much coverage needs to occur in the buildings and in the venues and what have you, the fiber counts are astronomical. I was at a conference, MetroConnect in Miami earlier this year, and I was listening to one of the guys from Crown Castle talk about how much fiber they have. We did some rough math. I don't think that they had actually done the math themselves, but it turns out that Crown Castle, as a tower operator, has over 100,000 strands of dark fiber themselves. And that's with today's network design. They're going to probably increase that tenfold in the next few years. That's great for fiber manufacturers, but it's also really good for the people that do zoning and rights of way and the lawyers and the real estate people that enable that. Oops, I jumped too far ahead. So you can't really read a lot of the details there, but this is what we've built so far. From Miami to Atlanta, it's a 734-mile route. Everywhere you see a little flag is one of the Allied Fiber buildings. They're modular buildings, precast concrete steel. Just imagine it like a neutral meet me room, looks like a Lego. And we place them approximately every 60 miles, which is the distance that light travels in fiber before it needs to be amplified. So our colo business is inherent. It is dictated by physics, which is nice. And again, this whole route is built with the design that you saw on the preceding slide, which there are access points throughout Florida every 5,000 feet and in Georgia every 3,000 feet, which is sort of a vestige of the past of the way that the railroads built the original duct and handhole infrastructure. And a handhole is basically like a manhole. It's a pretty heavy-duty plastic box that gets buried along the side of the right-of-way, and that's where our fiber cable goes in and slacks and then goes out. And it has access points of entry for the laterals to be built in. And in the case of this topic, that would be all the wireless backhaul, and then beyond the normal sort of traditional wireless backhaul, the small cell backhaul. So thousands of strands of fiber aggregating into hundreds of strands of fiber, aggregating into our core distribution route. And then you can see a picture here of the US, and this is our route design to get around the country using railroad rights of way. And again, the reference here is to the submarine cable landing regions, in case anybody wants to know why I picked this. You have the transatlantic north, the LATAM, South American cables landing between Boca Raton and Jacksonville. Now there's 2 new cables, and then the Pacific Northwest and Southwest for Asia. So where the U.S. sits in the world is between all these continents, and it's basically the thoroughfare for the vast majority of data. I don't see just that, though. I obviously see basically every cell tower and every antenna along the way. It'll be very interesting to watch all of this develop. And I was just talking with Alyssa sort of about this conference and how she came about this and you know, where she is with it now, and now it's growing, which is great because I see this area, small cell, being probably the biggest growth area you know, in this country, probably every other country in the next several years, because of the amount of investment in capital and infrastructure that needs to occur. And it needs to occur in a very logical, sort of well thought out, well planned way, or else a lot of people are going to lose a lot of money. And if you don't have something like this to connect back into, obviously, you know, there's some deficiencies on a national scale, and we have a very large country, so this is clearly necessary. But it'll be fun to watch this track, because as it happens and the right sort of recipe occurs at the most micro location, back to a midspan, back to a macro, people are going to realize what the whole combination means and who does what in the hierarchy. And it'll be good, I think, to sort of revisit this and come back and explain to people what we've seen in the Southeast as it relates to wireless backhaul and the successes, and specifically this topic, and who's deploying small cell and how that's groomed back into our core superstructure, and then what they do with it beyond that point. And we're just going to watch this whole pattern repeat as we go around the country. So, okay. I was going to open it up for questions, if that's okay with everybody. I know I kind of breezed through that. I'm happy to drill down on any part of that, to the extent anybody has any questions about it. Yes?
Where do I go? Where do I go? Thank you. I got it.
Hi, Hunter. John Celentano. In serving small cells, are you suggesting you need a high fiber count cable to, say, run down a road or street, or to connect all the different cells, that there's a dedicated pair or four fibers from each cell back to the hub?
Yes, as I understand the network architecture, which has been told to me, and again, I'm not in this business, but I look at what, for example, Ray LaChance and Zenfire are doing here in New York City, and the fiber densities are, you know, at a minimum 10x what they were for serving an enterprise office building. And yeah, that's not what I'm suggesting, that's what's been suggested to me. That's just as it relates to small cell, not even just bringing fiber to places where it doesn't exist yet.
So I guess my question is there not availability or development of an add drop capability where we could have fewer pairs that we're connecting into at each site, and we're picking up the signal and dropping the signal at each site along the way?
Yes, that is possible. That's a traditional architecture for metro transport. It's just that there's a logical number in terms of physics as a ratio that you can't get beyond in terms of how many pairs you're going to be able to aggregate from an antenna. The antenna needs fiber, so that's number one. The number of antennas that exist in a small cell deployment, somewhere in the order of, I think it's 6 times what I've read from the Wireless Association. Was it CTIA? 6 times. So, okay, if it's 6 times that number, and you're bringing a minimum count of 24 to a tower today, or a tower site on a building, the minimum to 24, so you multiply that times 6, you have a threshold number somewhere, you know, around about 150 fibers that you have to bring to each building. So if you're going to do that, you wouldn't just bring that number of fiber, because the incremental cost of the fiber is nominal. It's the cost of the labor, and really it's the cost of the point of entry and the lawyers and the real estate, right? Typically the landlords don't care about the count of the cable, they care about the diameter of the PoE or whatever. So people are going to overbuild fiber. It's a future-proof, in a sense, what the deployment looks like. So however many antennas you think you need today, when you move to 5G, whatever that may end up looking like, you're going to need to bring fiber to those antennas too, and not just upgrade the antennas you have. That's what I've been told. I just do the math in my head, and I think that that's a really big, scary number, considering the fact that probably half of the country still has no fiber at all to the tower as a starting point. And then now we're talking about small cell. We don't even have fiber to all the towers that we have, and now they're going to multiply the number of antennas in the buildings times 6. So I see that as an opportunity, by the way, not as a difficulty. We need to think about it and come up with a plan. Does that make sense?
It does. I don't know if the multipliers are quite right. I think what you're referring to is the number of small cells that equate to the capacity of a macro cell. I've heard numbers as high as 10.
There you go. I'm giving
Right.
you 6. It could be 10, whatever.
But we're talking at an individual cell basis, less traffic, if you will. So why do you need to multiply the number of fibers? So I don't want to get into it. I'm not as conversant as I need to be on it as well. But
Yeah.
my point is, it just seemed to me that if we're looking at high count fiber cables, maybe we can get more efficient if we had more electronics at each cell to be able to perform kind of an add drop function. But to your point, you can only do it for so many sites, right?
Correct. And again, I'm here to talk about the macro view. So I go back to, my macro view slide, right? Which is sort of that slide. I'm talking about connecting my buildings, which are the smaller sort of buildings there, every 60 miles, which is like town to town. So we don't do small cell. We don't do wireless backhaul. We're the superstructure that everybody connects into. So this is the macro view of how to aggregate all the traffic from the towers and the towns and whatever. Getting into the architectures of what it's going to look like to get to the endpoint, that's going to evolve and mature, and I've just seen that in the past few years, how that's changed with DAS, for example. So it's either a statistical thing, so you have to have better math, no matter what. The algorithms need to improve, so you have better throughput and lower latency and higher capacity. But the sheer physics of it is that if there isn't fiber, nothing happens. And that's kind of what I'm looking at. And I'm taking in all the same data points and whatever that people are saying. I just know that it's more than it is today. And I agree that it would make sense to be able to push devices all the way out to the edge. But then you've got space and power requirements for that stuff that simply don't exist. Most people have been serving buildings in a metro transport perspective from some gear that's sitting in a basement somewhere in a closet fed by an unprotected power feed that usually has water and rats running all over it. Okay, how are we going to overcome that when you need to do densities like an arena but for a city? That's challenging. So yeah, I think more fiber needs to be thrown at the problem in addition to solving for all the other things.
Thank you.
Sure.
Thanks, and that's why we're here today, to learn from one another and share thoughts and
Yeah.
ideas. So that was perfect. Thanks. I'm gonna come right in here.
I didn't see the notes on the Rocky states. Is that because of the challenge on cost or regulation related?
Sorry, could you repeat that?
The Rocky Mountain states. It looks like you are passing. Are you available also? Are you deploying on the Rocky Mountain states?
Rocky Mountain states?
Yeah.
Oh, yeah. I get that question a lot. So you want me to jump ahead to this map? Whoop. Boy, this thing's sensitive. I'm not avoiding anyone, okay? It's just that the submarine cable landing regions are in those points, and I don't go through the middle yet, or at least project that I'm going through the middle, because it's not on the way to the subsea landings. The Rocky Mountain states need to be served too, so let's let this all manifest. And I think the greatest thing that I would ever do would be to build what I call the cross, which would be to connect Chicago, Kansas City, and Dallas, and then probably San Francisco, Denver, Kansas City to Ashburn. And then we're done. The quadrants can be dealt with by the regional and metro fiber providers that serve those areas. We're not in that business. This is the most macro level view you're going to see of a neutral infrastructure provider in the United States. Not to say that the Rocky Mountain states or any other region don't need the same design. We'll get around to that, hopefully. It's just a question of when, time and money.
My question actually came from my experience as I'm involved in the deployment of the RF side, and I find almost most of this place actually still on the MLPP or T1s still, and
Oh, yeah.
not finding RFs. So I was wondering if there is any challenge for you guys to regulation related. A lot of these places are actually being preserved for ski resorts and so on. So maybe there is a challenge or a law with the regulation related. So that's basically my question.
The challenge is geography, quite frankly, and population density, which is the challenge that every country faces. So if you're familiar with the OECD list, which is this French organization that ranks the United States 28th in the world in broadband speeds and penetrations, the problem with the OECD ranking is that it calls the United States a country. It also calls Luxembourg a country. And Luxembourg's the size of the stage right here. Okay, not fair exactly. So of the 27 countries that are ahead of the United States, there's only one that even gets close to comparing to our geography, and that's Australia. And even they are smaller than us, and they're a continent too. So Colorado, and I was just there last year, and I spoke at the Mountain Connect conference, which is really great. The folks that live out there in that area are very acutely aware of this problem because they live with it every single day. And they have a lot of microwave out there because there's just a lot of great geographic expanse, and the ROIs aren't there, and they're kind of looked over rather than being looked after. And there was actually this one woman who drove for 6 hours to get to Vail, which is 2 hours outside of Denver. And she came from a county that's the size of Connecticut, a county the size of a state. So, of course, I gave my whole presentation about what we're doing, and they said the same thing. When are you coming through here? Because we need that to tie into. This is great. This is what I work on, okay? National network plan, neutral for everybody, but it's very capital intensive, but it incorporates the micro level aspect of aggregating small cell in it so that we can capture the greatest amount of demand. So hopefully soon we'll be able to answer that question. But yeah, there's big challenges here in the US, geography and money. Okay.
Great.
We're right
Well,
up on
thank you.
5 o'clock. I hope that was informative. Thanks again, Alyssa, and thank you all for listening.
All right, so before I let you go, I have to just say a couple of words. I do have to thank profusely the Advisory Council, who is forthcoming and honest with information and feedback, and I'm doing the best I can to keep them updated on a regular basis. So thanks to Jose Burgos, Ray LaChance, Dominic Valeco, Steve Yapsuga, Art Mierdik, Ezra Hug, Manny Gutche, Chintan Fafadia, Mike Collado, Doug Wiest, Douglas Fishman, and Tom Chamberlain. Well, I got to thank you for attending. Hope you got a lot out of it and a lot more to come and to build because of it. We want to thank our Platinum Networking Reception sponsors because we're going to have a couple of drinks, if not more, and some bites to eat in just a couple of minutes. JMA Wireless, Telecom Infrastructure. Gold Networking Reception sponsors, really appreciate your support. Our event sponsors, you're all here, they're all here, thank you. Our media partners, our webcast, thank you so much, Jolie, and the Internet Society, and our annual sponsors. And last, but certainly not least, my team is awesome. Megan Gallagher, Lauren Dukes, Zachary Ostro, Tara Jarvis, April Sauer, and Amy Cecil. Thank you. We wouldn't be here. Thank you. Oh, and if you have a moment to fill out these surveys, that would be appreciated.